So now that we know how to work the Maya interface, let's go ahead and start actually manipulating objects. Now we're in a new chapter, so I want to set a new project. We're going to go File, Project, Set, and then I'm just going to go down to Exercise Files on my desktop here and go O2 Manipulation. And once I do that, it sets all my paths so I can open those files. Now, manipulating objects in Maya involves selecting them, moving them, rotating them, and scaling them. All of these functions are available on your keyboard. So let me show you where the tools are first, and then I'll show you some of the keyboard shortcuts. And this is actually a really fast way to work with Maya. We have Select, which is here. It's also here in the Edit menu under Select, but I don't know anybody who ever goes to the Edit menu to get there because it's right here. You can also go Move, Rotate, and Scale. And those are also here under Transformation Tools. Again, they're buried. You really want to get to those through the menus. But the really key thing here is the fast way to get to these is that all of these keyboard shortcuts are the top left corner of your keyboard. So it's Q, W, E, and R of your keyboard. So Q is Select, W is Move, E is Rotate, and R is Scale. So Q, W, E, R. You can get to all of these tools very quickly just by putting your 4 fingers at the top left corner of your keyboard. So let's go ahead and play with Select for right now. So I'm going to hit Q and go into my Select tool. When you're in Select mode, you can just left-click on any object in the scene and select it. Now notice how the objects also show up here. If I have my channel box active, I have, for example, the handle, a tire, body, and so on. So every object that you have has a name and parameters assigned to it. If I want to, I can also rubber band any objects. So if I left click and drag, I can, for example, select everything. If I don't want to select anything, I can just left click outside of an object and just select nothing. Or I can rubber band just part of the object and select just that part. Now, in addition, we have shift tools. So if you want to shift select, you can individually pick the objects that you want. So I can hold down the shift key and just select the objects that I want, and they will select. Shift select is a toggle. Every time I click on it, it either selects it or deselected it. So if it's selected, you'll unselect the object. So this gets kind of funky when you hold down the shift key and you rubber band select. So if I shift and rubber band select, it's actually going to deselect those things that were active and select the things that were inactive. So that's just something you need to be aware of when you start working with Maya. Every tool in Maya has what are called options. You can get to those options in several ways. One is by just double-clicking on this icon, and it brings up the selection options. Another way is by clicking here for the tool options. So whatever tool is active, if you click here, you'll bring up that exact same menu. And also, if you go through Maya, you'll notice that most tools here also have a little box off to the side. If you select just the tool, you'll select the tool itself. But if you select it with the box, it will bring up those tool options. Let me show you that for the Move tool. Transformation Tools, Move tool. If I just select the tool itself, it just comes up. But if I go Move tool and click on that little box, it'll bring up the options for that tool. So let's go ahead and go back to the Select tool and see what some of the options are. Now for this particular tool, there's not a lot of options. You either have Marquee or Drag Select. Okay, so you can drag select or you can marquee select. Now there are additional ways to select objects. One is by using the lasso tool. So let's go ahead and click on that. And that's just a standard lasso that we can use to draw areas that you can't quite get with a rectangular rubber band box. And again, you have some options here. One is called open and closed. And what that is really just how it draws it. So you can see it's not closing the loop yet. And this one automatically closes the loop. Now, in addition to this, we have what are called soft select options. Now, these are really more for when you're actually modeling within an object to give soft deformations to an object. So those are the basics of the select tools. Now let's go ahead and start moving objects within the scene. Moving objects is pretty simple. You can either select an object and then just hit the move key, which is W, or you can select the move icon here, or if you want to dig through some menus, you could actually go modify, transform, move. So typically I just hit the W key to get into move mode. Now when you select an object to move, you'll notice this little gizmo comes up. In fact, I'm going to go ahead and zoom in and show you what that is. So that gizmo, if you notice, it has 3 axes. It has red, green, and blue. And notice how these correspond to the axes here in the bottom left-hand corner of the screen. Now in Maya, it is a 3D program, so we have an X, a Y, and a Z axis. These are always color-coded. The easiest way to understand this is XYZ equals RGB, so red, green, blue. Just like your color palette is RGB, your X, Y, and Z also correspond to that. So if I click on, for example, the red, it moves it along the X-axis. If I click Y or Z, I can move along any one of those axes. If I click in the middle of this icon, I can move it wherever I want. Now I'm going to go ahead and undo that so I center my tire back. Now I can do this with pretty much any object. So for example, I've selected the body of the wagon. I can move this wherever I want. Now one of the things about moving within 3D space is that sometimes you don't really know where you're moving, particularly if you're grabbing the middle of this gizmo. You don't know if you're moving back and forth or up and down because it's kind of hard to see this in a perspective view. So I typically move things one axis at a time if I can. Or another way to do it is to just go into a side or a top or a front viewport and just move those along 2 dimensions. So for example, if I'm in this front viewport and I'm moving, then I'm really moving along the plane that that front viewport is on. Now, if you want to, you can always undo. Control Z is your undo key. So I'm going to be doing that a lot because I'm going to be moving things and then undoing that. Now, in addition to just moving with the gizmo, you can also move using what's called the channel box. If we go up here, we'll see these 3 buttons. If we want to, we can go to the rightmost button, and that's the channel box. And what this does is it tells us what object is selected, in this case, body, or the body of the wagon. And we have our translation options here. So if I want to, I could just type in numbers. So let's say I want to move this, say 2 units in Y. I hit that and it jumps up vertically 2 units. If I want to move it in Z, I can just type in a number. Well, that's a little bit too big, but let's go ahead and type 5. And I can change those to whatever I want. If I want to re-zero this, I can just select all of these. I'm just left clicking and dragging and just type a 0 in and it will zero everything. So if I can select all of these fields and type in a number, it will go into all of those fields. That's kind of handy, particularly when you want to zero something out. Now, another way to use the channel box is by selecting the title of the channel and then going into the viewport and middle clicking. So any one of these parameters can be changed with a middle click. So I select this, middle click, and I drag left and right, and notice how it changes those values. It's almost like dragging the slider. This can be very, very handy. And I can do this for more than one if I want to. If I wanted to move this diagonally along YZ, I can just, again, middle click and drag left and right, and I'm literally just moving that slider. So in addition to moving single objects, you can also move multiple objects. Let's say I wanted to move the whole wagon. I can just rubber band select everything, hit W, and I can move everything all at once. The Move tool also has some additional options here. So if I select the Move tool and select an object, I can either double click on this or go to Tool Options here. And we can go into some settings for the Move tool to make it work in different ways. The most important one of these is the Move axis. And that determines exactly what axis we're using for the object itself. So for example, let's go ahead and select the rim of this tire. I'm going to zoom in a little bit here so you can see this axis here. Now this rim has been rotated. So if I go into object axis, you'll notice that the directions, my X, Y's, are actually changing, because if I go into the channel box here, you'll notice that this is actually rotated 51 degrees. So when I go into my Move tool here, you can see when I go to world settings, it's identical to XYZ. But if I go into object settings, it will take on the rotation of that object. Now you can also do some really cool stuff with this. You could actually set this to any custom axis you want, or you can set it to a specific point, edge, or face of an object. Now, in addition, we have what are called snap settings. Now, let me show you how this works. I'm going to go ahead back to my channel box, and I'm just going to go ahead and select the body of the wagon. Now, if you want, you can actually turn on any one of these snapping options. So I'm just going to turn on Snap to Grid, and as I start moving this, you'll notice that it's actually snapping to the points of this grid. Also notice when I turn on snapping, the little icon in the center of this gizmo goes from being a square to being a circle. So when it's a circle, it's in snap mode. Again, you can snap to all sorts of things. You can snap to a grid, you can snap to curves, you can snap to vertices on an object. So if I go to snap to that, I can snap to the individual vertices on any one of these objects. And you can also snap to surfaces. Now, typically for positioning objects, you want to snap to the grids. Now, in addition, if you go into, for example, the front or the side viewports, you can snap to any one of these orthographic viewports to precisely position this object. So that's everything you need to know about the Move tool. The next tools we're going to look at are Rotate and Scale. Now those are located over here, and they're also E and R on your keyboard. So if I select the body of this wagon, I can rotate it just by selecting the Rotate tool. When you activate the Rotate tool, you'll notice the gizmo is composed of a bunch of circles. You have a red, a green, and a blue circle, as well as a yellow circle here around the outside. These circles correspond to the axis in which it rotates around. So for example, if I want to rotate around the Z-axis, right now it's pointing at me, I can just left-click on that blue circle and rotate around the Z-axis. So essentially you're rotating perpendicular to that axis. If I rotate around the X-axis, that would be the red circle. And the same for the Y-axis. Now, in addition to these, you also have this outside manipulator. And what this does is it allows you to rotate around the camera view. So whatever view is perpendicular to the camera, so however you're looking, it's going to rotate around that view. So if I'm looking at it from this way, I'm rotating around that axis. If I'm looking at it from the bottom, I'll rotate around that axis. Now, if you want, you can also click in between the circles, and that gives you kind of a free form rotation. Now, I find this to be a little hard to control, this freeform rotation, and I always tend to rotate just like I move. I do it an axis at a time, and that way I'm a lot more precise when I work in Maya. Now, as you've noticed, you can also manipulate your rotations here in your channel box as well. Now, rotations in Maya are in degrees, so from 0 to 360 degrees is a full circle. I can go ahead and zero these out just by selecting them all and hitting 0. Now, the next tool is the Scale tool, and I can just hit R or select the Scale tool from the little menu there. And the Scale tool looks a lot like the Move tool in that it has a red, a green, and blue, and a yellow box instead of an arrow. It has boxes. And all you have to do is grab any one of those to scale it in the direction. So if I want to scale it up and down, I just grab the green one, red one, blue one. And then the center one is a global scale. It scales everything. Now, one of the nice things about scale is that you can scale negative. So take a look at the lettering on this wagon. If I scale to 0 and then go back the other way, you'll notice how the lettering flips around, which means I've kind of scaled it and kind of mirrored it. So that's a great way to mirror objects, is just to scale them in a negative direction. Now, if I want to zero all of this out, I actually have to type in a 1, because in Maya, 1 is my default scale. Some packages will go to 100%, but in Maya, it's 1. So those are the basics of the rotate and scale tools. When working with rotate and scale, one of the more important things is the location of the pivot of the object. Now in Maya, every object has what's called a pivot. So for example, if I selected the body of this wagon and I rotated it, it rotates around that pivot point. Now you can set this pivot point to customize the way that things rotate. Let's go ahead and select this handle of this wagon. The pivot point for this handle is actually set to the 0 point of the scene. Now, a lot of times when you create an object in Maya, it will actually just default the pivot to 0, 0, 0 in the world. But that's not where we need this pivot for this handle to move properly. What we have to do is we have to actually move that pivot from here to here, so that it will rotate around this pin, which is supposed to hold it in. We can do that by moving the pivot. This is done by hitting the Insert key on the Windows keyboard or the Home key on the Macintosh keyboard. So I go ahead and hit that key, Insert for Windows or Linux, and I can move that pivot wherever I want. In fact, I'm going to go ahead and go into my front viewport here and just precisely position that. Now, once I have that positioned, I can just hit Insert again or Home, and it goes back to normal move, rotate, and scale mode. So I can go back into my perspective window, and I can rotate the handle. And notice how the handle now rotates around that pin, which is supposed to hold it in. Now, one thing I'm also noticing here is that this handle is a little too low. So I can certainly move this up a little bit. And again, just hit Insert and move that pivot down. And now I should have a pretty good rotation. Now this pivot also works for scale. If you wanted to scale this handle, when you scale it, it's actually going to scale starting with that pivot point. So you can see how when the pivot is at the bottom, scaling this vertically scales it from the bottom up. You could also say, for example, with this, if I move the pivot to the front of the wagon, you can see that when I scale this, it scales more in one direction than the other. Now, another way of manipulating the pivot is to use the Center Pivot tool. We can go Modify Center Pivot, and that will always put the pivot to the exact center of the object. So pivots are really important for modeling, but they're also very important for animation. For example, if I was going to animate this wheel or something like that, I really do want to have these pivots exactly centered so that the wheel moves with an exact center. So those are some of the basics of pivots. As we manipulate objects, we've seen that we can view those manipulations in the channel box. All you have to do is click on this top right icon here and bring up the channel box. So for example, if I translate something, those numbers show up in the channel box. But if we want to, we can actually do a bunch of additional things with the channel box. If you right-click over any one of these values, or if you select a number of values by shift selecting them, and right-click over them, you'll see that we have a whole right-click menu for these values. Now, some of these are related to animations, such as key selected, key all, and these are for setting keyframes in animation. We can also cut and copy. Now, this isn't cutting and copying the actual values, but it's actually cutting and copying the channels themselves. Because one of the things you can do in the channel box is actually create your own custom parameters for objects and use those to further manipulate objects. In addition, we can do what's called a freeze. Now, what a freeze is it basically takes an object where it's at and it resets the pivot. For example, if we have this wheel on this object and we hit rotate, you'll see that the rotation here is actually at 51 degrees. If I want to, I can freeze the rotation of this object, and notice how the wheel doesn't rotate, but just the pivot goes back to 0. Now, this is another way to affect a pivot. In fact, if you want, there's actually a modify that allows you to freeze all transformations on one or many objects. And what that does is it zeroes out all of the transformations and rotations of any object. Now, we can also do that on an individual basis from the channel box. In addition, we have what's called break and select connections. It's actually a higher level animation function where you can actually have one object controlling another. So, for example, if you wanted to, for example, move the wagon and have the wheels automatically roll as you move the wagon, you could do that using connections. Now, the thing that's actually most important is the lock, unlock, and hide, which is down here. So if I want to, I can actually lock a rotation value. So, for example, let's go over to this handle. Now, if I want to, let's go ahead and move the pivot. So I'm going to hit the insert or the home key, and I'm going to move that pivot so that it's pretty much at 0. Okay. Now I'm going to hit the insert or the home key again, and then I can rotate this. But the thing about this handle is that it should be constrained only to one rotation, and that's rotation around the z-axis, because in reality, this isn't going to be able to rotate this way or this way, right? So if I want to constrain it just so it can rotate around z and not around x or y, what I can do is I can just select the channels here in the channel box for rotate x and y, right-click over them, and go lock selected. And when I do that, they turn gray. So now when I reselect this, I can't rotate left or right or around the axis. I can only rotate this where it's supposed to be rotated. This can be very handy because then that way you don't accidentally move something in a way that it's not intended. And it makes animation a lot easier because there's fewer mistakes. You can do the same with the wheels. Obviously, these wheels are only meant to rotate around this axis. You don't want the wheels moving like this or any other direction. So what you can do is you can just take each of these wheels. This is rotating around the z-axis. And so I can just, again, lock X and Y for the tire and also for the rim. So now I can't rotate the tire any other way than how it's supposed to go. Now, another thing you can do with these is you can actually hide values. So let's go ahead and select the handle again. And if I'm never rotating around X or Y, why do I even need to see that? So I can right-click here and just go Hide Selected. And that will actually hide those values that I don't want to animate. I can undo that just by hitting Control-Z, and that will undo that if you want to bring those back. Now, there are some other menu options here. You can also lock and hide selected. So, for example, if I had a value here, I could lock it and then hide it. And then you can also say, do you want to be able to keyframe these? You can either make them keyable or non-keyable. This actually goes into animation functions, but if you don't want to be able to set a keyframe on something, you can actually make that happen here in the channel box. Now, another thing about the channel box is that you can also view how an object is built. In other words, the history of an object. And this is just a coffee cup that I built. And if I select this object by left-clicking on it, you'll see I've got all the stuff here in my channel box. And if I wanted to, I could, for example, select these, right-click, and go freeze my translations, and that would set those to 0. But more importantly, if I scroll down here, in fact, let's go ahead. I want to show you another little option here in the channel box, is that we have some filters here along the top. If I click here, it actually turns on or off the layers palette. We have a little window here called layers. If I don't want to see that, all I have to do is click on this leftmost icon, and that will get rid of it. So that way we have a little bit more on our screen. Now, when I select this object, you can see I have my translation, rotation, scale options here, but also, if you notice, I've got all of the construction history of my object. So as I get into modeling and as I start building an object, Maya will actually keep track of everything that I do. And this actually can be seen in a number of places, one of which is the channel box. So, for example, this coffee cup actually started with a cylinder. So I took a cylinder and then I added some detail. I extruded in the coffee cup, and then I built the handle, and I actually did a number of tasks to build this coffee cup, but it all started with just a simple cylinder. And if I want, I can actually go back to these original parameters and change them. For example, the radius of this cylinder, if I want to change it, all I have to do is highlight it, and then I can just middle click and drag, and I can actually change that value, that original value that actually goes all the way up and filters all the way through all these other changes. So one of the nice things about this is that you can actually go back through your construction history and change things from within the channel box. And with any of these parameters here, you can also right-click over these and also lock or key or do whatever you want to any parameter in the channel box. It's not limited to just the translation, rotation, and scale. One last thing I want to show you about the channel box is that it does have an additional attribute, and that's called visibility. And that's essentially either on or off. So actually, you can just type the word off, and an object will go invisible. Or you can turn it on, and the object will go visible. Now, this is a good way to turn things on and off, and we can actually connect this to other objects to actually physically turn things on and off. This is actually one of the bases of how South Park is animated in Maya, is through a lot of animated visibility. Those are some of the basics of Maya's channel box. One of the more important windows in Maya is the attribute editor. Now, it's kind of similar to the channel box, but it's a lot more robust. You have a lot more controls over it. You can get to the attribute editor a couple of ways. One is just by clicking here, and that will go ahead and bring up the attribute editor. Another is by selecting an object and hitting Control A, and that will actually toggle between the channel box and the attribute editor. Now, the attribute editor is different for every single object because what it contains is all of the things that make the object what it is. So, for example, we have this coffee cup, and the coffee cup was built from a cylinder and then modified to create the shape of a coffee cup. And if we look in the channel box here, we can see all of this construction history. We started with a poly cylinder, and then we did some extrudes and so on and so forth. And if we go to the attribute editor, you can see all of this activity, and each one is a tab, and each tab has tons and tons of controls. So the very top tab is always going to be your translation and rotation options. So for example, here I've got transform attributes, and I could actually translate this here by just typing in numbers. So this is exactly the same as what you have here in the channel box. In fact, if I make this number 2.256 here, I go to the attribute editor, it's the same here. Now, in addition to this, you have options for the pivots, whether or not you want to display the pivots, and also how the object displays. There's also additional ones here for rendering, such as Formental Ray, which is one of the renderers within Maya. Now, each tab also has additional parameters. So, for example, the second tab is usually the Shape tab, and that determines what the geometry actually looks like. So, for example, in this one, you have how does the object look, and we also have stuff like render stats, whether or not this object renders, casts shadows, and so on. So each of these tabs has some very critical information for the object. Now, if you notice, we've got a lot of tabs because we did a lot of things to make this object. If you want to, you can actually hit these left and right arrows and go all the way to the end, and you can see how the object was built. In fact, if I go to the second to the end one here, this one's called Polycylinder 1, click on that, I've got the same controls for the original cylinder that I used to create this coffee cup. So if I want to, I can size the original cylinder, which created the coffee cup. And we also have what's called the material, which is what's applied to the object to give it its color. In this case, we use a blend, and here's the color. So all of this is controlled in the attribute editor. The attribute editor isn't the same for every single object. If you, for example, select a camera, I can go to my viewport and select the camera in my viewport. The attribute editor will be completely different because now I'm working with the actual camera that I'm viewing the coffee cup through. And what I can do here is I can actually change those parameters that affect the camera itself. So every single object will have different attributes, and those attributes can be adjusted within the attribute editor. As we work with Maya, we'll be using the attribute editor a lot, so I want you to just understand where it's at and some of the basics of how to use it. As you start working in Maya, you're going to start creating lots and lots of objects. So one of the things that you have to really be concerned with is keeping yourself organized. It's always good to have a global way to view all of the stuff in your scene. In Maya, this is done using the outliner window. Now, there are two places to get to this. One is under Window, Outliner, and you click on that, and you can actually have a floating window, which is kind of nice. The other way is to do this as a viewport. Now, I'm going to close this floating window, and I'm going to go down here to the bottom left, and you're going to see this little icon here. And if I click on this, you'll see it sets up the windows so that I have an outliner here on the left, and then just a standard perspective window on the right. So either way will work fine. It's just how you choose to work. Now, what the outliner does is it allows you to see every single object in the scene. So, for example, this red wagon is made up of a body, a rear axle, made up of wheels and tires and all sorts of things. And each one of those individual objects shows up in the outliner. We also can see a lot of other things in the outliner, such as the cameras that we view the scene through, any lights that are in the scene. A lot of different things show up in the outliner. One of the first things you notice is that everything in the scene has a name. This is something I really want to stress, is that everything that you create in Maya should have a descriptive name. This makes it much easier to work. You know, if you know that handle 1 is the handle of the wagon, that's much better than some cryptic name. If you want, you can actually change the name of an object in the outliner just by double-clicking on that. So you double-click, and you can just change the name of that, for example, to wagon. And it changes. Now also notice it changes over here in the channel box. So if I double click here, I can also change the name, and it updates in the outliner as well. Now, one of the great things about having names for objects is that you can actually search by name. So if you have a constant naming scheme for your objects, you could actually sort through, the hundreds or thousands of objects you'll have in a scene just by typing in some global search terms. This can be very, very handy. So for example, if I wanted to find all the tires in the scene, all I have to do is type the word tire here with an asterisk for global, and then it just lists all the tires. So this can be very handy if you have a scene with a lot of objects. If you keep a consistent naming scheme, you can select things a lot easier. And I can just get rid of this just by selecting my search term and hitting the backspace and enter and just deleting that term. Now, another thing you can do with the outliner is you have a couple of menus here which allow you to display certain types of objects. These are actually toggles. So do you turn on what types of objects you can turn on? This actually turns on everything in the scene. So you could actually see things like the shaders and, for example, the rubber texture of the tires, the chrome texture of the wheels. You can see all of this in the outliner. And here's another little trick here is if this gets too narrow, you can just put your mouse over this border between the panes and you can just left click and drag and make it a little bit bigger. So if you don't want to show everything, you can just click here and that goes DAG objects only. And that's basically just the objects that you see in the scene, the physical objects in the scene. You can also turn on attributes so you can see all the attributes for an object. So if you want to see, for example, the move, rotate, scale, you can actually see the scale X, Y, and Z options for this. Okay, typically we don't want to do that because it's a lot of additional real estate on that screen that we don't need. We can also show how things are connected, and we can also do things such as change the sort order. So for example, you can do just by the hierarchy of the scene or alphabetical within type. We can also change the order of the attributes that are shown. So that's if I turn on attributes here. So this is a really great way to browse your scene and select objects. If you want to select things, you can select them from within the outliner. So for example, you could just shift select and select things by name. Or if you hold down the control key, again, this is just that standard selection type. So if you hold something down and you shift, it'll select everything between your two clicks. If you select something and hold down the control key, you can individually pick things. So those are some of the basics of the outliner. When you start creating multiple objects in the scene, there are times when you'll want to group those objects so that they can move together. Like, for example, with this wagon, you really want to be able to move the body of the wagon and have everything else move with it. You don't want things to be disconnected like this. We can connect all of the pieces together by using what's called a hierarchy. Now we can do that by using the outliner. So let's go Window, Outliner, and let's go ahead and position that. So for example, let's say we wanted everything to move with the body. In fact, let's just go ahead and do this one piece at a time. For example, we have this front axle, which is completely separate from the body. If I wanted this to move with the body, all I have to do is select this and then just drag it in the outliner. Let me show you how this works. You left click to highlight it, middle click, and drag. Now notice that when you get above a word, you get a double line like this. If you go between words, then you get a single line. If you go between words and let go, it just rearranges. So I could actually put this, down to the bottom. So this is kind of just a way to organize things. But if I drag it above the body so that there's a double line there, see, single line, double line, notice how this little plus sign comes up. And what happens is now this is a child of the body. So when I select the body, that front axle moves with it in a hierarchy. This is great. Well, what I can do is if I want everything to move with that, then all I have to do is just select everything. So I can just shift select everything, middle click, and drag it so that it's over the body. And now everything is a child of the body. Now I can move just the body and everything moves with it. And I can actually expand or contract that. We can take this a little bit further by creating hierarchies within hierarchies. Let's say, for example, we want this front wheel to turn. So, for example, we've got this front axle, and in reality, we really would want this to turn left and right and have the wheels move with it and have the handle move with it. So in order to do that, first thing we need to do is be able to get it to turn. So we have to move the pivot. So I'm just going to hit the Insert key and move that pivot right there so that it's kind of centered among that. And then hit the Insert or the Home key on the Mac. And then that will at least rotate around its center. but I want the wheels and the handle and everything else to move with it. So what I can do is just select the tire and the wheel. These tires and wheels are separate, so I can just shift select the tire and the wheel, and this tire and this wheel, and also select the handle. I'm holding down the control key here, the handle and the pin, which is in between the handle and that yoke. So now that I have all of these selected, all of these are attached to that front axle. I can just middle click and drag above the front axle. Now, if you notice, I've got two levels of hierarchy now. I've got the body, everything under the body, and then I also have the front axle and everything under that front axle. So if I rotate that front axle now, everything is moving all hunky-dory. Now I can do the same for these tires. Now if you notice, the tire is actually separate from the rim. So if I take this mag wheel and I rotate it, the tire isn't actually rotating with that mag wheel. In order to do that, they need to be a child of the wheel. So again, I can just take the tire, middle click and drag it, and do that the same for the other ones. Oops. And middle click and drag. So now I've got a 4-level hierarchy. So I've got the wagon, and then the front axle, and then the rim, and then the tire. So as you can see, we have something that actually moves realistically. In fact, let me go ahead and move this pivot for the handle. I'm just going to go ahead and hit insert there, and that moves perfectly. So now the front end of this works great. And for the rear of this, we could actually do the same. We could actually take these wheels and make them a child of that axle, and then again just put the tires as children of the rims. So as you can see, now we have a very organized scene. So if we want, we can just select the body, and that selects everything, and then we can go through, and in the outliner we can actually pick out certain things. Now another thing you can do is you can use the arrow keys to actually walk through the hierarchy. So if I have something here, for example, if I pick the wheel, I can just use the up arrow to walk up the hierarchy. Now I can't really walk down the hierarchy because it doesn't know which one of these to go to, but I can certainly walk up it. So if I want to select the parent, so I select, for example, this wheel, I can certainly go to the parent of the wheel and the parent of the axle as well, just by hitting the arrow keys. So those are some of the basics of hierarchies, and we're going to be using these a lot when we get into animation. Another way to look at the hierarchy of your scene is by using the hypergraph window. This is similar to the outliner, but it's a little bit more of a graphic representation of your scene. We're going to go ahead and open a scene here called Red Wagon Assembled. It's the same Red Wagon, except it's got the hierarchies all set up. So this is the one that we've set up in the outliner, and it's got all of the hierarchies set up and ready to go. Now, if we want to view this graphically, we can see it in the hypergraph. So we go Window, Hypergraph, and there's two options here. The one we want to go to is called Hypergraph Hierarchy. And this brings up a little window, and we can see all of the objects in our scene in a hierarchy. And you notice how this is all graphically drawn out. I think it's a much more visual and much better way to see things in your scene. In fact, you can go through this window and just highlight them just by moving your mouse over them and select them. If you want, you can hold down the Shift key and select multiple objects. So this is holding down the Shift key. And in this case, the Control key doesn't work because this is actually more of a graphical interface. This is more of a viewport like the front or the top viewport. And you can actually navigate this just like any viewport by holding down the Alt or the Option key and zooming and panning just like you do in any viewport. Now, in order to readjust this hierarchy, all you have to do is select the nodes. You can just rubber band select them. And just like you do in the outliner, you can middle click and drag, and you can put this anywhere you want. So, for example, if I want those supports under the rear axle, I can do that. And notice how they reconnect. So if I want to put those back over the body, I can do that just by selecting them, middle clicking, and dragging. Now, there are a few view options here. One will allow you to zoom to the ones that you have selected. The other one is a fit to screen, and the other one shows everything in the scene. So this one fits to screen everything within the hierarchy. So if we had multiple objects with multiple hierarchies, I could select that one object, hit this button, and it would zoom to the extents of the hierarchy. Again, this one zooms to the extents of everything in the scene. When we went to this window, we actually have two modes for the hypergraph window. One is hierarchy, the other one is connections. I'm not going to click on this because you can actually get to this from within the hypergraph window. If you select this button, that shows the hierarchy. This one here shows the connections. And this is essentially how the object is built. This particular object isn't really all that interesting. So I'm going to go ahead and close this window, and we're going to open a new file. We're going to go ahead and open scene, and we're going to open that coffee cup scene. And remember how this still has a lot of that construction history, which we can see here in the channel box. So let's go into Window, Hypergraph, and this time let's just go into Connections mode. And you'll see there's all sorts of stuff in here. And what this is how the object is built, how it's wired together. So each one of these options here is a separate node. So for example, the shader node, which provides the color, is here. And then any of these operations that we've done to actually create the object, for example, the original cylinder, remember how we had that? In fact, let's go ahead and get this coffee cup so we can see it. I can actually select that, and I can actually see that in either the channel box or the attribute editor. So I can select any one of these, and they will show up in the attribute editor. So for example, I can go to the poly cylinder, which I used to originally create this coffee cup, and again, I can size it if I want. So this is just another way to find it. Now, if you want to get really sophisticated, there are ways to actually totally rewire and reconnect your model. This is a very powerful window. Now, in addition, you can just flip between this connections mode and the actual hierarchy mode. This scene only has one object, so hierarchy mode really doesn't matter much at all. Now, in addition, we have a couple of menu options here. One allows you to rename the objects. This actually is a view, so allows you to frame all, frame selections, so on and so forth. This one here will graph either the scene hierarchy, and again, it's just like pressing this button here or this button, or input and output connections. And this one actually only graph out input or output connections, and this will actually rebuild the window. It kind of just reorganizes so it looks a little bit less messy. And then also, if you want, you can also show things such as rendering options, and we can also have different types of layouts. We can also orient this vertically, horizontally, and so on. So if I go graph layout style, orientation vertical, everything goes vertical. Or if I want to go schematic, it goes in a different way. And then the other option here is show objects, and we can show objects by type. So if you only want to see NURBS or polygonal objects, you can actually filter this just to see different types of objects. So those are some of the basics of the hypergraph window, and that's just another way to look at your scene. Another way of organizing hierarchies is by using groups. Now, I have the original red wagon open here, not the one that we created with the hierarchies. And if I open the outliner, you'll see that it's pretty much a flat hierarchy. Now, one way to create hierarchies is to basically just select everything in the outliner, middle click and drag, and I've created a hierarchy with the body as the parent. But another way to do that is by using what's called a group. I'm just going to go ahead and drag these out of the hierarchy. And if I want, I can actually do what's called a group. So let's go ahead and start with these tires. I'm just going to go ahead and select this front right tire. And another way to organize this is by using groups. So what we can do is we can go Edit, Group, and the option here is Control G. And if you group it, watch what happens. You get this little node here called a group. And under that group, we have our two objects. So let's take a look at how this works. I've got my group here, and if I want to, I can move that. Now, the group always creates a pivot point at 0, 0. So if I want to move that wheel or rotate it, it's going to actually rotate from 0, 0, because that's where the pivot point of that group is. I can certainly move the pivot point. I can just hit Insert and move that pivot point wherever I want. And if I want, I can actually center that to the wheel. I'm going to go ahead and Insert, and again, that's Home on the Macintosh. But the really interesting thing about this is that this is really a separate pivot point. So I've got this group pivot, and I can move that wherever I want. So I've got my tire has its own pivot, the wheel has its own pivot, and then the group has a third pivot. Now I can use this to a great effect in animation if I want things to rotate around different axes at different times. I can actually use groups to do that. So for example, if I want this tire to rotate around this axis, I can just rotate the group. And if I want it to rotate around its center axis, I can rotate the object itself. Here, let's take a look at this with just the handle. So if I want to, I can just go Modify, Center Pivot, and I've got the handle here with the pivot that's centered. So I can just rotate around that. But I can also group it. So I'm just going to hit Control G, and watch what happens here in the outliner with this handle. Control G, I create another group. This is called Group 2. And this pivot goes directly to the origin, which is at 0, 0 here. But I can certainly move that by hitting Insert or Home and just positioning that, for example, at, in fact, I may want to go into a top or a left viewport here. Let's go ahead and move that pivot point. There we go. Okay, much better. So I can move this to the base of my object. And now I've got basically two pivot points to work with. I can rotate here, or I can go into the outliner and I can rotate here. Kind of handy, and I can make as many of these as I want. So again, I can just hit Control G again, make a third group, and a third pivot point. And again, I can make one that goes around the top, for example. So now this rotates around the top. And I can actually rename these. I can just call this top, bottom, and then I also have one for the middle of the handle. So by selecting any one of these, I can actually create different ways that I can rotate the object. Another cool thing is that these groups are actually basically just empty pivot points. So if I take this handle, drag it out of the group, I still have that top and bottom pivot point, even though they're not really affecting anything. So I could actually drag that handle back over the bottom pivot point, and again, it will work. Now, another great thing you can do is if you go into the attribute editor for any one of these groups, I can actually go down here to display, and I can turn on what's called display handle. And watch what it does here. it's right here. So go ahead and if I turn that on, I get what's called a handle. And I can now grab that handle, and it actually is a physical object that I can locate in the scene. I can do the same here for the bottom pivot. I can just turn on display handle, and now I've got two pivots that I can play with. So if I want to, I can actually go here, and I can rotate around this axis, or I can come here, and I can rotate around that axis. So what you can actually do is create additional handles, pivot points, or whatever to manipulate your objects. Another handy thing with groups is that it's just a good way to kind of tie everything together without having to parent actual geometry. A lot of times it's better to have a group. Let's say I wanted to take everything and just kind of organize it. So I could actually, for example, create a group here by hitting Control G. Or another really cool thing to do is you can use that as kind of almost like a manipulation or a modeling tool. Like, for example, if I took just one of these wheels or both of these wheels, let's say, for example, I was actually making this model. So I'm going to go ahead and delete these wheels on the right side, and I can just select the left wheels and I can just group them. And when I group those, I can make the opposite side wheels just by doing a scale of the group. Or actually, what I can do, okay, this is actually a little trip. I can actually duplicate those objects or duplicate that group. And then I can just scale that group -1 to make the mirror image wheels on the opposite side. So you can see how groups are kind of a handy way. It's kind of almost like a little placeholder that you can use to create new pivot points, use for aid in scaling, and so on. Now with these wheels, once the group has been scaled, I can actually take those, drag them back out of the group, and their scaling will stay the same. Okay, even though the group itself, I can just go ahead and delete that original group. And the last thing I want to show you is that if you do have a group, you can get rid of it just by going ungroup, and that will actually just get rid of each of the groups, and it will get rid of the handle as well. So notice how we have this bottom group here with its handle. If I go ungroup, it gets rid of the group and the handle itself. So those are some of the tools for manipulating and using groups within Maya. As your scenes get more complex, you're going to find the need to hide things so you can focus in on what's important in a scene. One of the ways to hide and show things is just within the viewport. If you go over here, you'll see a show menu option. If we click that, we can actually turn on and off all sorts of object types within the viewport. So for example, if I don't want to see the grid, I don't have to see it. But more importantly is we can turn things off by object type. So for example, if I turn off NURBS surfaces, then the tires in this scene go away because those are made of NURBS. I can turn them back on as well. Now this is on a viewport by viewport basis. So for example, if I hit all the polygons in this viewport, they would still show up in all of my other viewports. Now, another way to hide and show objects is by just selecting the objects themselves. So let's say I wanted to work on the bucket of this wagon, and I've got all of this stuff in the way. So I've got, all this axles and all this stuff, and I really can't see clearly as to what I want to model. Well, the easiest way to get rid of this is just to hide it. There's a display menu here called Hide and Show. So we have Hide. We can hide the object that we've selected. So I can just hide the bucket, but that's not what I want. I could actually hide unselected objects, which is everything but the bucket, which is actually more what I want. Or I can hide everything. And there's also some additional options as well. I can hide by certain types of geometry, deformers, lights, cameras, pretty much all sorts of different things. Now, the real handy thing here is that we do have some hotkeys here. So if I go Alt-H, or on the Apple keyboard it would be Option-H, Now this is lowercase h. You hide unselected objects. Now, if you want to show them, you can go here and you can either show the last hidden or you can show all. But the really nice thing is that show last hidden is Control plus uppercase H. So if I go Shift Control H, it hides it. It shows it back. So if I'm working on the wagon itself, I just go Alt or Option H and then Control Shift H and it brings it back. So there's some other options here for show. We can show all. We can also show selection. You're probably wondering, how do I select something if I can't see it, if it's hidden? So let's say, for example, we hide the body of this wagon. Well, if I go into the outliner, I can still see the body here. And you can see that it's hidden because the lettering of this is marked in blue. So black means it's visible. Blue means it's hidden, so I can still select it in the outliner. It's just not going to show up in my viewports. And so if I want to show that, I just go Shift H and that will show it. Or I can obviously select it from this menu. And again, with the show menu, you also have the ability to show all and show stuff by type, like geometry and lights, cameras, and so on. So those can be very handy tools when you're working with complex scenes. So get to know the hide and show tools, and we'll go ahead and move on from here. One more way to organize your scene is by using layers. So I'm going to go ahead and open a file, and that's called kitchen.mb, and that's the one that I have open here. And in this, we have what are called layers. I can get to my layers menu by going over to my channel box and make sure that this or this icon is selected. This actually shows your layers with the channel box, and this just shows the layers. I'm going to go ahead and show it with the channel box, which is kind of the default way of looking at it. And if you want, you can size this up by just grabbing this little bar and just dragging it up. Now, if you notice, I've got some layers set up in this scene. Now, layers are a great way to organize your workflow in Maya. So, for example, one common thing to do is to put all of your lights on a separate layer, or all of your cameras and all of your geometry. Or if you have character animation, you can put all the stuff related to one specific character on its own layer. Some of the great things you can do with layers is that you can actually turn things on and off. So for example, here, I've got all the appliances on their own layer. So all I have to do is just hit this little V and I can hide them. The same with the cabinets in the scene. So every type of object can have its own layer. So if I wanted to create a layer, all you have to do is go into layers and just go create empty layer. And that creates a new layer. And if I double click on that, I can give this a name. So let's say we wanted to put all the furniture in a layer. I can just type that name, hit furniture, and hit save. And so now it's got that new name. Now all I have to do is select the chairs, shift select chairs and the table, and then you just right click over the layer and just say add selected objects. Now, once I've done that, those objects are in that layer, so I can turn that layer on and off. Now, there's some other things you can do with this layer. One is you can template things. So if I hit this button here, I can actually create a template. So that means I can see it in outline form, but I can't select it. I also have some additional buttons that allow me to arrange the layers. So for example, if I want to, I can actually move these layers down and up. And this is just more for organizational standpoint. And this button here allows me to create new layers as well. So I can either create new layers here from the layers menu, or I also have an icon here. Now, if I want, I can also right click over any of these layers, and I can go down here to membership, and it will actually bring up a relationship editor, which is basically just something that shows me what objects are in what layer. So if I select cabinets, you can see I've got cabinets 1, 2, 3, and 4. If I go furniture, you can see I've got the 2 chairs and the table. And if I want to, I can actually take objects in or out of those layers as well. Now, in addition to just display layers, I also have what are called render and animation layers. Now, render layers allow you to render a scene out a part at a time. And animation layers allow you to layer animations so that certain types of animation happen before others. Now, in addition to this layers menu, we also can delete selected layers, or we can delete unused layers. Now, if you delete a layer, what happens is that the objects themselves basically just go out into a no layer state. Now, we also have some options here, which allows us to add any new objects to a current layer. So if you're modeling, you can set a current layer. So for example, layer 1, I can go make that layer current. And then since that's the active layer, any object that I create, so for example, if I create a sphere or something like that, that sphere will now be part of this new layer. Of course, I have to have that selected. So when I create a new object here, when that's selected, then that becomes part of that layer. Of course, this is a toggle here, so I have to have that checked. So those are some of the basics of layers, and it's a really good way to organize your scenes as your scenes start to get more complicated. The next thing I want to talk about are selection masks. These are ways to actually mask what is and isn't selected in a scene. Now, in this really simple scene with the wagon, we really only have two types of objects. We have the tire, which is a NURBS-based object, and the wheel, which is a polygonal type object. Now, most of these objects are polygons, but the actual tires are actually NURBS-based objects. Now, in a scene, you may want to be able to select one type of object over another. We can do that using selection masks. We can set those up here by just clicking on this option here, and then your masks show up as toggles along this line. If I want to, I can turn on and off any of these types of objects. So if I turn everything off, I can't select anything in the scene. Now, if I want to, I could go here to Surfaces, right-click on it, and just click NURBS Surfaces, and that means the only thing that gets selected in this scene are the NURBS surfaces. In this case, that's the tires. And of course, I can do that for poly surfaces and turn off NURBS surfaces. Again, this is right-clicking over this. So in that case, I can actually rubber band select just the polygonal objects and ignore the NURBS objects. Now, this is a lot more comprehensive than just geometry. You could also do stuff for curves, skeletons, handles, and IK handles. For example, if I took one of these and I grouped it using Control G and then made a selection handle here, I go into the attribute editor for that group and turn on a display handle. If I turn off that, I won't be able to select that handle. See, so now I've got this particular handle is turned on. Now I turn it off here and I can't select it. Okay, so you can see how this works for all sorts of different objects. So we've got handles, curves, skeleton joints, lattices, clusters, all sorts of dynamics and particles and systems and stuff like that, and also lights, cameras, and textures. So this makes it much easier to work in your scenes. So let's say you're doing a lot of work with cameras. You could just turn all objects off and only turn on cameras. So that way when you rubber band select, you're only going to select the cameras in the scene. And again, the best thing to do is once you've set those, if you want to reset it, just go all objects on or all objects off. Now, another nice thing you can do is you could actually save this state to the shelf. So, for example, if I have all objects off except for NURBS surfaces, I could actually save that to shelf, and now you've got a mask there. And all I have to do now is, if I want to select just NURBS surfaces, I just click that, and it automatically sets my masks. Kind of nice, huh? So now I have a custom tool on my toolbar here that allows me to turn on just NURBS surfaces. Now I can make another one here. I could just turn all objects off and just right-click here for poly surfaces, and then I could just go save again to shelf. So now I have one that allows me to select only the poly surfaces, and then another one which allows me to select only the NURBS surfaces. So that's some of the basics of selection masks for objects. Now, there's also another one for components, which are the things that comprise objects. And if you want to, you can also turn on and off objects by the type of component, such as face or control vertex or edge or whatever. And we'll get into those as we get into the modeling chapters. Now let's talk about modeling and creating objects from scratch. We're going to first start with polygonal modeling, and you can find all of those tools here. So we go down to polygons, and that'll bring up the polygon tool set. There's also a shelf with a lot of those tools here. And actually, I tend to use the shelf, so I may be going to these, but a lot of these tools are up along here, and I'll try and show you where everything is at. Now, with polygonal modeling, the way it works is you generally start with a polygonal primitive. Now, that can be either a sphere or cube or cylinder, and then you reshape the object into whatever it is you're trying to build. So the first thing we need to do is go over some of these polygonal primitives and show you how they work. Now, if you have the polygon shelf active, you'll see they're all right here. You can also get to them through the Create menu. We can go to Create, Polygonal Primitives, and here they are. In fact, I'm going to go ahead and tear this off so that we have it right here. So let's just go down the list, and I'm just going to go through the basics of all of these polygonal primitives so we're all on the same page. Now, the first one is the sphere. And if you want to, you can just click here and create the sphere. Now, in order to create a sphere, all you have to do is just left-click and drag wherever it is you want to create that object. Now, I'm in wireframe mode. All I have to do is hit the number 5 to go into shaded mode so you can see that. I'm going to go into my channel box, and I'm just going to highlight just the channel box here. I'm just going to hit this icon. And when you create this, you actually create a node, which shows up in the channel box as well as the attribute editor, called Polysphere. And this gives you some of the options that you can use to create that sphere. One of them is the radius of the sphere, or basically how big the sphere is. And the other one is subdivisions. How much resolution is that sphere? You have ones for along the axis as well as height. And if you want to, one of the things I like to do is highlight both of these, and you can scale them both at once just by right-clicking and dragging left to right. So you highlight these. Now you can also do this in the attribute editor. Let's go over there and let me show you how to do that here. We have Polysphere 1, and again we have our subdivisions here and our radius as well. Now you also have some additional options here in the attribute editor, and one is how to create UVs, which is essentially how a texture will be applied to this sphere. Okay, now I'm going to go back to the channel box, and let's go ahead and look at some of these other primitives. The next one is the cube. All you have to do is click cube. Now you can also get to it here, and all you do is left click and you drag out the base of the cube, and then you pull up the height. Okay, now this is actually something you need to be aware of if you're building this in a front or a side viewport. Let's go ahead and delete this. Let's say I'm in the front viewport and I want to draw a box. Well, then I create that, but I can't pull the height. I actually have to go into another viewport in order to pull the height. The only way that I can create it in one viewport is in some sort of perspective viewport. So just be aware of that for this particular primitive. Now again, we have options here, such as width, height, depth. Width, height, and depth are kind of relative to how you draw it. So if you draw it in the top viewport first, the width and height are going to be a little bit different than if you draw it in a side viewport, because the first plane that you draw is actually your width and height, and then what you drag out is going to be your depth. And then in addition to that, we have subdivisions. So we can actually create subdivisions along height, width, and depth as well. Now, one of the things I also want to show you is that each of these options also has a little toolbox here. I'm going to go ahead and delete this cube here, and let's go ahead and recreate this. So when we create the cube using the Tools options box, we can preset the number of divisions, for example, before we even draw it. So that's kind of nice. But the one thing about this is that once you've set this, they stick around. The next cube I draw will also have that same number of divisions. So if I want to, I can actually just bring those back to 1, which is the default. So what you can do for any of these is you can actually reset the default options just by going into this Tools menu. So let's go ahead and delete these, and let's go on to some of these other options. The next one is a cylinder. Again, it's kind of like the cube where you have to draw out the base and then drag the height. And for each of these, we have a radius. We have the actual height. Now, the height is actually around the center. So you see how it actually scales up and down around the center. And then number of subdivisions radially along the top. And then also subdivisions for the top and bottom, which are called the caps. Cone, again, it's very similar to a cylinder. And again, it's got radius and height and so on. This is pretty self-explanatory. The next one is actually the plane, and that's pretty easy to draw. You just, again, left click and drag. And with the plane, all you really have is width, height, and again, the number of subdivisions. In fact, let me move that above the grid so you can see it. And then we also have a torus, which is kind of like a donut. So let me show you how that works again. What you do is you drag out the main radius of the torus, or how big around is the donut, and then you have to drag again for the thickness. So this is how thick my donut is. Is it a ring, or is it, Krispy Kreme or whatever? So, and again with this, you can actually change your radius and your section radius, which is actually the technical name. Another nice thing is you actually have a twist option here. So you could actually twist that a little bit, and you can also change your subdivisions. Okay, let's go through some of these other ones. This one is called Prism. In fact, let's go ahead. I'm going to go into the attribute editor for this one. So I'm just going to go Control A and go here to Polyprism 1. And let's go ahead and play with this a little bit. So we have the length of the sides, the number of sides. So this is almost like an n-gon. And then you can also have number of subdivisions in the height and the cap. So this is almost like you can make for example, this is the Pentagon or the Chrysler logo. And this is a hexagon or an octagon. And so it's a very easy way to make a regular sided object. Well, we've got a few more here. We've got the pyramid. And that's exactly like it's advertised. And this is the Great Pyramid of Cheops. And you can also create different numbers of sides. You can actually create a tetra or a penta pyramid, and also give number of subdivisions as well. I like this one a lot. This is a tube. They call it a pipe. So basically you set the radius, set the height, and then set the thickness. Okay, so it's a 3-step process. Let's go through that one more time for the pipe. Radius, height, thickness, 3 separate left clicks to get that done. And then again, we can go into either the attribute editor or the channel box to change any of these parameters. If you draw it and it's not exactly the way you want it, you can always go back and change it. So that's kind of a nice thing. And then a couple more. One's called the helix. And that's like a little spring there. And then you can also drag for number coils. And then you can also drag this section radius. This is kind of a nice way to make springs. Now, sometimes this would be a really hard object. Here, let's make a little bit more of a simpler one for this. Now, this would be a very hard object to model. So it's nice to have kind of a parametric version of this. And one of the nice things you could actually animate the height. So for example, if you had a spring in a car, you could actually just animate the height of that to actually get the bounciness of that spring. So that's kind of a nice little feature of that. And then we have a few more. We have a soccer ball, and this is great for creating geodesic domes, that sort of thing. And we have what are called the platonic solids. And if we go here, we have solid type. In fact, we need to go to the attribute editor for this one. So we go to Platonic Solid. We have a pull-down menu here, dodecahedron, icosahedron, octahedron, and tetrahedron. And those are the four hedron brothers. So those are the basics of the polygonal primitives. Now, what we'll be doing is we'll be taking these primitives and actually reshaping them into more organic types of objects using some of the polygonal modeling tools. So once you're familiar with these basic primitives, we can expand that to create more complex objects. So now let's go ahead and start modeling some of these primitives into actual objects. The first thing you need to understand when doing polygonal modeling is you need to understand what makes up a polygonal model. So let's go ahead and start with a cube. So I'm just going to go ahead here, click on cube, drag it out, and I'm going to shade it by hitting 5 on the keyboard. Now, if you notice, we have this object. It's a three-dimensional object. So each dimension has its own component. Now, components are those things that make up the object, the things that allow you to edit the polygonal object. So if I want to get to those components, all I have to do is bring up my marking menu. Right-click over it. I've got three main components here. I've got a lot of other stuff here, but the one I really want to look at here are faces, edges, and vertices. Let's start with vertices. If we go to vertex, notice how these little points come up here. And those are where all of these lines intersect. In fact, a vertex is a point, and a point is basically one dimension. So if I can take those, if I want to edit this, all I have to do is select one of those and just hit move or hit the W key, and I can reshape by moving those vertices. So vertex is basically one point. If I right-click above this and go edge, we can select the edges. Now, the edges are the lines that connect individual vertices. So if I select the edge, I can certainly edit this object by moving the edges. So essentially, an edge is a two-dimensional construct. It goes from point to point, and it creates a line. If I right-click over this again, I can go to face. And what faces are essentially the planes that are connected by edges. So if I go, I can actually move these faces around using my move tool. So what we've got here is we've got vertices, edges, and faces. And by manipulating these, we can actually reshape any of these polygonal primitives to create a model. Now, one tool that's actually really cool is the multi-select tool. So now I've got face, which allows me to select only faces, edge, which allows me to select only edges, and vertex, which allows me to select just the vertices. But I also have what's called a multi-tool or multi-mode. It's not really a tool. It allows you to select faces and vertices and edges. Now, this can be really handy when you're doing certain types of modeling operations. Now, typically, I tend to stick to either vertices or edges or faces, but there are times when you'll want to be able to switch between those. And then if you right-click here and go to object mode, you actually select the object itself. Now, I've been using the marking menu. Another way to get into this is to click on this button or hit F8, and that brings you into component mode, which allows you to select and modify whatever it is you want. Now, in this option, you can actually use the selection masks to turn on and off individual components. For example, if we go all components off, then I really can't select anything. But I can go here and, for example, and right-click and go poly edges, make sure that says poly edges, and I can select edges. Or here, I can select vertices. Or here, I can select faces. I can turn them all on or off if I want. So I actually have a little bit more control here, but I have to also go up and make these selection masks myself. typically I say all components on if you want, and if you do that, you get all of that, or do them all off, and however you want. But I find it's a lot faster just to use this marking menu and go in and just get to your objects this way. Now I'm going to go ahead and delete this. So those are the basics of how to select and modify polygonal components. Let's go a little bit deeper into polygonal editing. I'm going to go ahead and start by creating a sphere. Let's just go ahead and create a default sphere and shade that. And then if I want to, I can edit this just by right-clicking and selecting vertex. Now, if I wanted to actually reshape this, I could just take those vertices and move them around. Now, one of the things you'll notice very quickly when you start moving large groups of vertices is that you get kind of hard edges around the points where you move those. If you want, you can actually modify this a little bit more organically by using soft selection. So how you do that is you basically double click on any one of these tools, any one of the move, rotate, or scale tools. So let's go ahead and play with the move tool. If I double click on that, you'll see I get my move tool settings. If I scroll down, you'll see a little section here called soft selection. This is really handy. If you turn on soft select, you can actually dial in the radius over which this is affected. So every vertex that I've selected, in fact, I can unselect and reselect these, now has a fall off. So everything I've selected will move 100%, and then over the radius of, in this case, 4.76, it will fade off to 0. Best way to look at this is to say, okay, let's just go ahead and play with this. You can see now, instead of moving just those vertices, I get a nice fall off, which gives me a really nice way to model organically. So I can actually reshape this and make this look a lot more organic. Now this works not just for the move tool, but also for the rotate and the scale tool. Now you have to make sure that it's turned on, and if you've turned it on for one tool, it will default to all the other tools. When you go to rotate, you don't have to actually turn it on again. It will inherit the settings from whatever you had from the last tool. Now, some of the nice things you can do with this is you could actually do different types of curve presets so that it will fall off in different ways, linearly, parametrically. You can make it so that it actually creates like a little bump here, like that. So you can make all sorts of curves. In fact, you can actually dial in your own curve by using this curve editor. All you have to do is just left click on any one of these and you can actually make your own curves. So if you left click here, and you can actually create your own fall off curve. If you want to get rid of these, all you have to do is just hit that little X, and that'll get rid of any one of those. And then if you want to, you could actually give it your own color. If for some reason you're afraid of the color red, you can certainly change that color to blue or whatever. So you can actually make whatever color fall off you want. You can go from blue to green or green to blue rather than red to yellow. And that's just a display thing. You can also do what's called reflection. Now what reflection does is it actually finds the vertices on the opposite side of the model and allows you to edit those as well. This probably works better on a fresh model. In fact, I'm going to go ahead, right click, go to object mode, delete it. Let's go ahead and start with a new sphere. And then let's go ahead and turn on soft select and make sure that reflection is turned on. Right click, go to vertex, and select some vertices. Now notice how we've got this reflection turned on. If I'm going to model something organically and I want to make sure that it's symmetrical, all I have to do is turn on that reflection and it will reflect around whatever axis I select. In this case, it's the x-axis. So anything on positive x, again, x is red, so on positive x, it will move negative on the opposite side. Now this is for things that are created along the x-axis. Now this is reflected along the pivot point of the object. So if I go and select the actual object itself, you'll see that that's where it's reflecting off the pivot point of that object. If I move the pivot of the object, the reflection point will change as well. So as you can see, this is a very handy tool for organic and soft modeling. Now, another way to select polygonal objects, or really any sort of component, is by using Paint Select. So I'm going to go ahead and create a polygonal sphere here and shade it. And let's just go into face mode here. And normally if I want to select something, I can just shift select or rubber band select or lasso select. But we also have what's called a paint select tool. So all I have to do is select this. In fact, if I double click on it, you've got some options here. And I can just start painting my selection. Now I have basically a brush that allows me to paint that selection. If I want to size the brush, I can do it one of two ways. I can go into the tool options and just give it a radius of what I want. Or the more interactive way is to hold down the B key, B for brush, and then just left click and drag. So this also works really well with a tablet. And this is also an introduction to the Artisan Painting interface within Maya, which you can use for a lot of other things. Now, one of the more popular workflows when you're working with polygonal objects is to use what are called subdivision surfaces. Now, we've gotten a little bit of a taste of this just by the way we can view polygonal objects in the viewport. So, for example, I'm working with this head, and if I just hit the 1, 2, or 3 key, we can actually see how this surface subdivides. So 1 shows you the actual polygonal model of this character's head. 2 shows you the subdivision surface with the polygonal cage above the head. So actually this is the model here. The model is actually the cage, and we can just affect that and it affects the surface underneath. Or we can hit the 3 button and that just shows us the mesh by itself. So for example, if I selected the vertices of his nose, I could obviously reshape this. And if I selected the vertices of the head, notice how when I select this vertex, it actually goes off of the head. So if I hit the number 2, you can see that that's because the actual vertex that I'm manipulating is on the cage, which is actually a little bit off of that head. And so, for example, with all of these vertices, you can see how those work as well. So all of this display stuff is all fine and dandy, but the real key for this is that you want to be able to animate this low-res version, because that makes it a lot simpler to manipulate and render, and it's going to be a lot faster if you work with the low poly version in Maya. But you want to render a higher res version. So when you actually get to the point where you're rendering the scene, you want the renderer to see this one. So in Maya, there's actually 2 different workflows for using subdivision surfaces. So let's go over the first one. Now, this is probably the more standard one, the one that a lot of people who are familiar with Maya have used for a long time, and that's called Subdiv Proxy. So how this works is on the polygons menu, we have what's called a proxy. And we have Subdiv Proxy and remove Subdiv Proxy, all of that. But the one that's most important is this one called Subdiv Proxy. Now what I can do is I can just hit this, or there's actually a hotkey here, Control plus the tilde key. And when I do that, what it does is actually creates 2 objects. In fact, if I go into my outliner here, you can see here I've got my head, which is my original model, and then I've got a copy of that, which is the smoothed version. Now, if I render this, you'll see it actually renders both. So what I have to do in this case is actually go through and either hide this, so I can actually just go display, hide that particular object, and then it'll render smooth. Or I can set stuff up in layers. There's all sorts of ways to hide this before you render. Or what you can do is you can also go into the attributes editor for this particular object, and you can go into your render stats and just turn off all the rendering cues for that. And so you can actually still see it in your viewport. You don't have to hide it, but when you render, it just shows up as invisible. Now, the more important thing about this is that the head and the proxy of the head are connected using this modifier here called Poly Smooth Proxy. Now, I can see it here in the channel box, or if I go into my attribute editor, I can find the little node here that says Poly Smooth Proxy as well. And what this does is allows me to set the number of division levels. So how much is this smoothed? So do I smooth it once, twice? Okay, now you got to be careful. You don't want to really dial this up too much because every time you go up a level, you quadruple the number of polygons. So for example, if I go to 0, that's one big polygon. If I go to 1, it divides it into 4. And then it divides that 4 by 4, and you get 16, where I originally had 1. And then you go up one more, you get 64. So you can see how you can very easily get a lot of polygons. And something like this would be almost impossible to manipulate in real time if you're doing something like facial animation. But when you go to render, it looks really smooth. So the key for this number of division levels is to set a number that basically renders smooth. So I'm looking here at this edge, and I can see that that looks pretty smooth. If I go down to, say, level 1, you'll see I still have a little bit of jagginess. So you can just basically go by my rule of thumb, which is if it looks good, it is good. So I just turn this up until it looks good. So that's generally how I work with this sort of stuff. Now, there are additional tools that Maya has for managing these. So I just wanted to show you how Subdiv Proxy works for those times where you do want to do organic modeling for subdivision surfaces. Now, the second method for doing subdivision surfaces involves the Mental Ray renderer. It's actually pretty simple the way that this works. So let me go ahead and select this head again. And again, we're going to go with our subdivision of 1, 2, which shows the cage and the object, and 3, which just shows the object itself. Now, if I render this, I'm going to hit this button here, which is the Render Globals button. And I want to make sure I'm in the Maya software renderer, okay? Because I'm going to show you how it works with that renderer. So I'm actually going to just leave this up and just position this so I can see it. So if we render this, I can actually hit this little button here to do rendering, just a quick render. And I render it, the smoothing doesn't come up. Now that's because the Maya software renderer doesn't automatically smooth the model. But if we go over to Mental Ray, which is the second renderer in Maya, and I select that, make sure that that's the active renderer, and then I just hit a render again, you'll see it automatically picks that up. So with that, you have an automatic workflow for subdivision surfaces that you really don't even have to pay attention to. All you have to do is make sure that you've smoothed it in the viewport. Okay, so if I actually hit the number 1 and unsmooth this and render it in Mental Ray, you'll notice that it actually renders unsmoothed. Okay, and if I hit 2, which shows the cage, it'll remove the cage and still render the smooth version. The really cool thing about Mental Ray is that it will calculate the subdivision based upon the camera position. So the closer it is, the more it will smooth it. So you actually have kind of an adaptive smoothing system, so you don't even have to worry about dialing up your subdivision levels or dialing them down. Now let me show you a little bit more about how the subdivisions work within Maya. So let's go ahead and select the head, hit 1, and then let's go to the attribute editor right here, or you can hit Control A. And then let's go down to, let's go ahead and select our head neutral shape, and let's go to Smooth Mesh. Now when I turn on Smooth Mesh, notice when I hit the 2, it actually checks that button which says Smooth Mesh Preview, and it actually is just changing these options. So these options are actually set on a per object basis. So I can show my cage, my smooth mesh, or both, or I can just show my smooth mesh. Now if I go down one more level here from smooth mesh to subdivision levels, I can actually change the number of subdivision levels it displays. So for example, I go cage and smooth mesh, I could actually display those subdivision levels, and I can dial those up and down for how it displays in the viewport and also how it renders. Now we also have some extra controls here which shows how it smooths in terms of continuity, so in other words the angle of smoothing, and as well as do you want to smooth the textures and that sort of stuff on the object. For example, in between his hair and his skin there's actually a border where two textures overlap, and how do you want to smooth that sort of stuff. So those are some of the basics for using subdivision surfaces with Mental Ray. I would highly recommend this workflow for anybody who's using subdivision surfaces. It does involve using Mental Ray as your renderer, but that's actually not a bad thing because it is a much more robust rendering system. So now let's go through some of the modeling tools within Maya. Most of the modeling tools are contained here in the polygon menu set, and we have Mesh, which controls anything that affects an entire object. And then we have edit mesh tools, and those affect components such as faces, vertices, and edges. We're going to play with the first one of these edit mesh tools, which is extrude. So let's go ahead and do that. We're going to start with a box. I'm just going to go here to my polygon shelf, create a box, or I can create polygon primitives cube. I call it the box, but actually technically the name is a cube. And then I'm going to create that cube and shade it. Now, if I'm in my channel box, you can see in my inputs here, I've got my poly cube is set, and I can go ahead and ramp up the number of divisions if I want. Now, extrusion works on faces, edges, and vertices. So let's go ahead and play with faces first, because that's probably the most common way to extrude. I can right-click above my model, select face, and just select one face. And then I can just go ahead and do an extrude. Now, when I do that, up comes this little gizmo. Now, this gizmo has arrows, which allows me to move it up and down. So if I want to make a hole, I just move it down. And if I want to create a protrusion, I just move the arrow up. Now, also notice here, in my channel box, I have a poly extrude face node, which actually changes. Notice how this local translate changes as I move this. And I can also scale, and you can also notice how these affect that as well. So we can scale these, we can move them, we can rotate them. And in addition, we also have options for, if we move down here, number of divisions. So I can, for example, ramp up these divisions as well. Now, in addition to move and scale, I also have rotate, so I can actually rotate that extrusion here as well. And what I'm doing here is I'm just middle clicking and dragging left and right to change those values. Now, in addition to extruding faces, we can also extrude edges and vertices. So let me show you how to do that as well. I'm going to go ahead and select this face, and I'm just going to delete it so I have an open edge. And then I'm just going to go right-click over this, and I can either go to Multi or Edge. I'm going to go to Edge here and just select this edge. So then I'm just going to extrude that. Now I can do that in one of two places. I can just go back to here, or I can do one of my favorite little tricks, which is to just hit the space bar and go to Recent Commands and just pull up the extrude command from there. Now, once I do that, I can extrude the edge. Now, when you extrude an edge, obviously you're just extruding a flat face, but you still have all of the same controls. And I can actually go down here and again create divisions if I want to. Okay, so this actually can be a real handy thing if you want to create a plane, or if, let's say, you have a hole or something like that and you want to bridge that, you can just extrude the edge over the hole or something like that. Now, the third way you can extrude is you can extrude vertices. So I'm going to right-click above this, go to Vertex, and just pick a random vertex here. And then let's just go ahead and extrude. And when you extrude a vertex, notice how what it does is it actually creates almost like a point type of object. So this could be kind of cool if you want to make like spikes on something. Probably here's a really cool, real simple trick here is just take a sphere, select all the vertices, and extrude them, and you get a pointy sea urchin type of thing, which is basically just extruding every individual vertex. When you're using Extrude or any other tool that creates new geometry, you have an option in Maya whether you want to keep faces together or not. And now this can really affect the way that your modeling works, particularly when you're doing subdivision surface type modeling. We're going to go ahead and build a hand, and I'll show you how this works. So let's go ahead and draw out a box. And I'm going to go ahead and shade that. And then I'm going to go to my inputs here in my channel box, and I'm just going to go ahead and middle click and drag to set the width and the depth to about 4, because what I want is I want 1, 2, 3, 4 fingers, and then a thumb at the bottom of this. Think of this as the palm of the hand. So let's go ahead and do an extrude and create, for example, the thumb. And before I do that, I'm actually going to go ahead and smooth this. So I'm going to hit the number 2 so we can see how the cage affects our subdivision surface here. Okay, so we're kind of doing subdivision surface modeling. So when I do an extrude for the thumb, you can see how that affects the mesh. Now I do an extrude like that, and then I want to go ahead and go over here to divisions and just add 1 or 2 divisions to create that thumb. Now for the front of this, the first instinct is to just go ahead and extrude the faces along the front because I've got 1, 2, 3, 4. I can create 4 fingers just like I created 1 thumb. But what Maya does is it, by default, actually keeps faces together when you extrude them. So let's just go ahead and do that. I'm going to hit my space bar here and just go to recent commands and just go back to that extrude that we did. And when I extrude these, what it does is it extrudes these as a block, and it just extends my palm, essentially. It extends this box, and it doesn't give me individual fingers. Well, that's not really what I want. So I'm going to hit Control Z and undo that a few times. And what we have in Maya is we have an option here. And this option is to keep faces together. Now, by default, that's checked because typically when we do an extrusion, we want to keep those faces together. But in this case, we don't. So let's go ahead and uncheck that. And when we do that, what it does is it actually makes individual polygons. Well, here, let me show you how this works. We're just going to go ahead and hit the space bar, go back to extrude. And now when I extrude, it actually extrudes these as individual objects. In fact, let's go ahead and just take one of these and just move it. You can see that now what it does is it actually creates individual faces rather than making them all one block here. And if I want to, I can go back to my object, go into my extrude face, and just add some subdivisions to create the fingers. So those are the basics of creating a hand. Now this keep faces together, it's a toggle. So for example, if I left it off and I wanted to do some other type of extrusion, in fact, if I want to, I could paint select all of these faces and do an extrude. What it does is it makes them individual. And that's not really what I want for this case. So if I click this over to keep faces together and then do the extrude, it extrudes them all as one block. That's the big difference between that. So just be sure you know that this option exists and that you have it checked appropriately for the type of operation you want to do. One of the things that always trips me up is that I check it off when I'm doing one thing and I forget to turn it back on when I do another thing, and I accidentally create additional polygons because I haven't kept my faces together. So now that you understand the basics of that tool, let's go ahead and move on. Now let's talk about edge loops. Edge loops is a very important concept in polygonal modeling because it really allows you to control the detail as well as the curvature of a subdivision surface. Now I'm working with 2 coffee cups here. Now let's go ahead and just work with the regular cup here. I'm going to go ahead and move the coffee cup off to the side. I'm going to use the one without the handle and just zoom in. Now if you notice, this is essentially a cylinder that's been extruded to create the cup shape. But the edges of this object, in fact, I'm going to right click here and go into edge mode. You have a series of vertical and horizontal edges. It's almost like latitude and longitude on a globe. So if you notice, this edge goes all the way around, so it's called an edge loop. By controlling these loops, we can actually control where the detail is on our model, as well as how the model smooths. Now we can work with edge loops in Maya simply by using the arrow keys. If I press the right arrow, it selects the entire loop. So all I have to do is click on one edge, hit the right arrow, and it selects that entire loop. Now if I want to, I can just move that loop to reposition that detail. If I select the left arrow, I can step through different types of loops. So I can just go, that one goes up, or if I press the right arrow, once I have a loop selected, I can also move counterclockwise and step through all those loops. Now this also works for the vertical loop. So if I select, for example, that edge, hit the right arrow, it will select everything up until the pole of that cylinder, and then I can just hit right or left and go around and select individual loops. This is a very handy way of selecting things. Now, if you hit the up or down arrow, let's go ahead and select a horizontal loop and hit the up or down arrow. It'll go ahead and select what's called, I believe it's called a ring, which is all the loops parallel to that loop. And then again, I can hit right or, once I hit up or down, I can hit up or down to step through all of those as well. And the same works for the vertical edge loops. So for example, if I take that one there and I hit the up arrow, notice how it selects that, and then up and down will go ahead and step me through all of these. So for example, if I wanted to create a bulge here, I could just scale those edges and bulge that out. So those are kind of some handy select tools. But the real power of edge loops comes in how it controls smoothing of the object. So I'm just going to go ahead and select this object, and I'm going to hit either the 2 or the 3 button on the keyboard to show how that smooths. Now let's go ahead and hit the 2 button, and notice that smoothing happens. Let's go down to the bottom here. The smoothing happens along the edge. So it starts smoothing where the edge starts, and it ends smoothing where the next edge starts. So for example, this corner, it's smooth between this face and this face. In fact, I'm going to turn off my grid here so you can see this a little bit better. So this face and this face are what controls the smoothing. And the size of this face is determined by where this edge loop is. So if I can select one of these edges, right-click, select edge, select one of these edges, and then just hit the right arrow key, I can actually move this edge loop up and down. And what that does is it shortens that corresponding polygon and makes that corner either tighter or rounder. So where the edge exists determines how that corner is smoothed. Okay, so that's very important for polygonal modeling. In fact, let's just take a look at this in normal mode here. So I can just move this edge up and down, but when I actually go to smooth it, moving that edge makes it either a sharper or a more narrow corner. As you can see, the edge loops control where the detail is on the model as well as how it smooths. So let's go ahead and move on from here. So let's go a little bit further with edge loops. We're still playing with that coffee cup file, and this time I want to play with the one with the handle. So I'm going to move this one out of the way and move this one in towards the center here. Let's zoom in so we can see this. Now, we were talking about edge loops and how they control smoothness. So let's go ahead and just select this coffee cup and hit either 2 or 3 to subdivide that so we can see what that looks like. Now, one of the things I'm noticing with this is that that handle is kind of blobby. It doesn't really look like a nice handle. Now, in order to get that to smooth better, though, let's take a look at this model. We actually need additional edge loops in order to control that smoothness, because I really can't move this loop here. Let's go ahead and take this edge here. So for example, if I take that edge and I move it in, I'm actually affecting the shape of the coffee cup. I need to actually add in edge loops in order to control that smoothness. We can do that with a number of edge loop tools that are included within Maya, and those are insert and offset edge loop. So let's go ahead and just do insert edge loop and see how that works. If we go insert edge loop, what happens is your cursor changes to this little diamond, and all I have to do is click on an edge loop and I can insert a loop right there. So now when I go ahead and smooth this, you can see how that smoothing actually gives it a tighter curve. So you can see it's tighter here than it is there. If I want to, I can insert another edge loop. Just again, left click. Now what you're doing is we're left clicking on the edge that's going to be perpendicular to my new edge loop. In this case, I'm left clicking on a vertical edge. And then I can just move that edge loop wherever I want, and notice how it changes the curvature of that. I can do the same for here. I'm going to click on this horizontal one, and I can bring one in a little bit more. By inserting edge loops, I can actually insert detail, which then affects how the object is going to be smoothed. Now I have an additional tool here, and that's called offset edge loop. And that's actually a little bit different. And what it does is you actually select a horizontal loop and it just creates an offset on either side of that. So for example, if I select this one, it creates 1 or 2 loops. In fact, let's go ahead and do that, the basic model here. So let's go ahead and go insert edge loop. I'll insert one here. And now when I use the offset edge loop tool, I click on this one and it just gives me a pair of edge loops that bracket that initial one. So that's really just a way to add more detail so you can actually control the curvature of this again. And again, these control how an object smooths. Now you can also just add detail to create places to model. Let's go ahead over to this other cup and let's say we wanted to add in enough detail to make a handle. All I have to do here is go insert edge loop, and I can insert enough for a handle, or I can do offset edge loop, click on the horizontal one, and again, I'm just going to add enough detail. And so that gives me a little bit of extra detail here. So now I can go off to the faces and shift select those. And if I want to, I can extrude those to start making the handle of a new coffee cup. So as you can see, edge loops have a lot of power, and some of these insert and offset edge loop tools can help you to refine your model in very specific ways so that you can add detail where you need it. One more tool for manipulating edges is the slide edge tool. Now what this does is it's a little bit different than move in that the slide edge tool actually tries to maintain the consistency of the model. So for example, I have this head model, and if I want to, I could actually just select edge and just move the edge. But when I move the edge, I may or may not move it on the surface. If I wanted to, for example, reposition this detail, it's very hard for me to just move this without creating, for example, like this little crease here. See, so watch, when I reposition this, it's very easy to create creases and to make the surface non-continuous. But the slide edge tool allows you to actually slide the edge along the surface, and it tries to maintain that continuity. So it's a different way of moving edges around. So I can select an edge or multiple edges and slide them. So I just go Edit Mesh, Slide Edge Tool, and just middle click. It says drag with MMB. MMB means middle mouse button. So drag with the middle mouse button. And then when I slide those, notice how it maintains that continuity. So notice how it maintains that continuity, and I don't get nearly as much creasing. Now, obviously, the surface will change a little bit, but it's trying to maintain that curvature. So this is just another way to manipulate edges within Maya. Another way to add detail to an object is to cut or split the faces of an object. Let me show you how that works. I'm just going to draw a simple cube so we can just see how this tool works. And I'm going to shade it. So in our Edit Mesh menu, we have two options. One is called Cut Faces. The other one is called Split Polygon. Let me show you how Split Polygon works first. All you have to do is select the tool, and then your cursor changes to this little delta shape. And then all you have to do is just click on an edge, and it will split the polygon. You can just hit Enter. And now I've split that polygon in half. So if I go, I actually have two faces here. Okay, now the one thing this can do is that can create what's called a five-sided, or can create an n-gon, which is a more than a four-sided face, which can induce problems when you start smoothing the object. But this will split the polygon. So let me show you how this works again. So let's go Edit Mesh, Split Polygon. Now you don't have to split straight across. You can certainly split corner to corner. And you can split multiple times. All you have to do again is just click on these edges and then just hit Enter when you're done. So for example, I created a diamond there. If I want, I can select that face, and I can use that as a base to, for example, extrude if I need to. Okay. Now the other tool, in fact, I'm just going to go ahead and select this and delete it. and just draw a new box so we have a fresh slate here. Now, the other tool I want to show you is called the Cut Faces tool. Now, this works kind of the similar way, except it kind of gives you almost like a knife. And so all I have to do is click on this and drag. And wherever this is dragged, it will cut the faces right along that line. Now, I'm in a perspective view, so it's going to cut it from a perspective standpoint. It's almost like I'm tossing a wedge through that polygon at the direction that I'm looking at it. So it just cuts it along that edge. So a lot of times when you use this cut polygon tool, it's better to do it in an orthographic viewport. So let's go into, for example, the top viewport and again use it. So just go ahead and do cut polygon. And this way I can, for example, cut it right down the middle because you can see it kind of snaps to 0 degrees there. And when I do that, you can see how it actually has cut it. Since I cut it from the top down, it cuts that way. Or if I want to, in fact, let's go ahead and leave this view up. You can see how I can cut it from the side. You can see how, again, I can cut that from the side. So those are two ways to create additional detail in your model. Another two tools for adding detail to a model are poke and wedge face. And let me show you how those work. I'm going to go ahead and create another box. And I'm going to shade it by hitting 5. And I'm going to go over here to Polycube, and I'm going to select all of these, middle click, and drag until I have 3 subdivisions for height, width, and depth. Now I'm just going to go into face mode, and I can just select any face or any number of faces, and let's go ahead and use poke face. It's really very self-explanatory. All you have to do is just select a face, go poke face, and watch what happens. What it does is it cuts the face diagonally both ways and then adds another vertex. So you can actually basically create a peak there. Now, if you do this for a triangular face, go poke face again, it will just bisect those 3 angles. Okay, so you don't have to do this on a 4-sided face. It's really any side you have, it will go ahead and find the center point of that and then draw a line to each vertex. Okay, so basically it takes each vertex on the face, in this case 1, 2, 3, 4, connects them all and gives you a center line. For a 3-sided face, it would go 1, 2, 3 and give you the center. Okay, so that's poke face. Now the next one is called wedge face, and this is actually kind of a handy little tool. So I'm going to go ahead, and in this case I have to select 2 things. So this is a great use for the multi-select option. So I'm going to right click over this, go multi-select, select the face, shift select an edge. So I want a face and an edge selected. Then I go into edit mesh and I go wedge face. And watch what it does. It takes that face and it rotates it around and creates, I consider it like the corner of an air conditioning duct or something like that. But if I want to, I can go over into my channel box here and open this up and see that I can actually give it an angle and a number of divisions. And I can also do that in my attribute editor. So I would go into poly wedge face. I can give it an angle and a number of divisions as well. Okay, so this is the angle. So you can actually make this 360 degrees, whatever you want, and give it any number of divisions. So those are pretty simple, but you can see there you have a lot of interesting uses if you need to add some very specific types of geometry. So let's go ahead and move on to some more tools. Now let's take a look at the Poly Bevel tool. And what bevel does is pretty much as described. It bevels edges. In other words, it whittles them away. So let's go into Edit Mesh, and we have a tool here called Bevel. But we have to bevel either an edge, a face, or a vertex. Let's start with a face. So I'm actually going to click off of this, right-click over the cube, and select that top face. Let's go Edit Mesh, Bevel, and just do a default bevel. And what it does is it basically cuts that corner by 45 degrees. If it's a 90-degree corner, it cuts the corner in half. So if it was a 30-degree angle, it would cut it 15 and 15, so on and so forth. But I can go back to, if I go into object mode and select my object, I can actually go back to my bevel control, and you can see I have all sorts of options here. One is the offset. How much is it beveled? The other one is the roundness of this. Well, that doesn't make any sense unless I have more segments. So I can just take the number of segments, and again, I'm middle clicking and right and left dragging and add more segments. Then if I want, I can take the roundness up or down. And then you can also have some additional options here. Now, these options are also available in the attribute editor, and they're also available in the bevel options. You can certainly give it number of segments right there, and also the width. Now, I like doing this afterward. That's kind of the way that I work. I like working with it in the channel box because I have more control over how it looks. Now, you don't have to bevel just faces. You can also bevel edges or vertices. So let's go ahead and take some edges. Let's go ahead and take this edge here and bevel that. Edit Mesh, Bevel. Now, what it does is it bevels that edge. And again, I can give it an offset. I can give it a number of segments and give it some roundness. Let's go ahead and undo that. Turn off the grid here, and I'm just going to go ahead and go to the bottom here. Edit Mesh, bevel that bottom. And if you do that, select all of those edges, you get basically the same effect as if you had beveled the face surrounding those edges. So it's pretty equivalent for edges and faces. Now, if I want, I can also bevel vertices. In order to do that, let's just go ahead and I'm just going to create a new box. And I'm going to give it a little bit of subdivisions. So let's go ahead and select the vertex here on the corner. And if I bevel that, you can see what happens. It's not nearly as interesting when you bevel vertices, but you can see you can probably use that for some sort of modeling thing, but it actually adds a lot of detail, a lot of triangles there. So you can actually add more segments. So you can see how beveling vertices works as well. Typically, I do faces and edges, but you can certainly do vertices as well. Let's take a look at the chamfer vertex tool. It's really very simple in the way that it works. Let's go ahead and just create a simple box and shade it. And I'm going to go ahead and just add some subdivisions here. Now, chamfer is a lot like the bevel tool, but it's for vertices. So let's select a vertex, right click over here with our marking menu and select a vertex and just go edit chamfer vertex. And it basically just cuts the corner there. If I want to, I can also chamfer vertex on a face and notice how it works a little bit differently. Now, what chamfer does is it takes every edge that comes into that vertex and it just extends new edges out along there. So you can see how this works for this becomes that and this becomes that. Now, if I right click here, go into object mode, you can see each of these chamfers also has a width value and also a number of divisions if you want it. So that's just the basics of that tool. It's a very simple tool. Now let's take a look at the bridge tool. What this does is it allows you to bridge or create a connection between polygons or edges in a polygonal model. So let me show you with this coffee cup file. And let's start off with the cup with the handle. And let's just go ahead and rebuild that handle. So what I can do is just go into face mode, select the faces of this vertical part of the handle, and hit delete. And then I can right click over this and go to edge and select the open edges. Now, when I deleted those faces, notice how I have an open hole here and an open hole here. I can use bridge to connect those holes. But what I have to do is select the edges bounding that opening first. So there's 1, 2, 3, 4, 5, 6 edges here. And I also need to select 1, 2, 3, 4, 5, 6 edges here. Now, bridge is pretty smart. You don't have to select these edges in any specific order. All you have to do is make sure they're selected and then just hit bridge. And when you do that, it actually connects the two. It creates a bridge between those two open edges. If I right click and go into object mode, you can see I've got poly bridge edge, and I can go ahead and change the number of divisions or whatever. Now, bridge also works from polygon to polygon, so you don't need an open edge. You can just select a polygon face. So let's go ahead and put a handle on this coffee cup. In fact, let's just go ahead and rework this a little bit. I'm going to go ahead and move this edge loop up just a little bit. Select this edge loop, hit the right arrow, and move it down so we have a little bit more of a space to make a handle. And then I'm just going to right-click here and go select this face and this face. And then we're going to extrude them. And then maybe just extrude them one more time. Now let's go ahead and make this into a handle. All I have to do is select this face and this face under here. And then once I do that, I can again do bridge. And that just bridges those automatically, so I don't even need the open edges there. So what's really cool is that you can bridge any two or any group of faces to any group of faces. So for example, I could just select this one here and this one here and just go edit mesh bridge, and I can create a bridge between those two faces as well. Of course, that doesn't make much sense, but you can certainly do it if you want. Another popular way of modeling is using Booleans. Now, Maya does support Booleans, and let me show you how that works. What Booleans can do is they can use one object to cut holes or append to another. So I'm going to go ahead and create a simple box here, and I'm going to create a cylinder. And now I'm going to use this cylinder to cut a hole in this box. So I'm going to place the cylinder. In fact, let's go ahead and go into X-ray mode so I can see how this works. So I'm going to go ahead and take that cylinder. In fact, I'm going to go wireframe unshaded as well so we can really see how this works. So I'm going to take this cylinder and position it so it's over the box like this. Then I'm going to select the box and shift select the cylinder. Now here's a little hint. The last thing selected in Maya is always highlighted in green. So in these cases where you have to select multiple things, always know that the last thing that you've selected is green, okay? And once we do that, we can go mesh, Booleans, and we have three options here. In fact, I'm going to tear this off. Union, difference, and intersection. So let's just go through all of these. If you do union, in fact, let's go ahead and turn off X-ray here. What it does is it creates them both as one object. It basically fuses them together as one object. If I undo that, so now I've got this separate again. So that was union. And now we can do difference. So we select the box, shift select the cylinder again, and go difference. And what that does is it cuts a hole in the box. Okay, now I'm going to go ahead and undo that again. And let's just do intersection. What intersection does is it only leaves those parts that intersect. So it's essentially just the top of that cylinder because that's the only part of those that really overlapped. In fact, if I show that in X-ray, you can see this would be intersection. And in difference, the last one cuts a hole in the first one, and union, both of them are combined. So those are some of the basics of Booleans in Maya. Now, one thing I do want to advise you about is that Booleans as a form of modeling really only works for objects that are static. If you're going to animate the shape of an object, let's say it's a character or something like that, you really don't want to be using Booleans, because what Booleans does is it can create rough edges that really don't smooth well. In fact, let me just go ahead and do a difference here and create that, and then just go ahead and shade this. And if I smooth this, you can see how it smooths really weird. And that's because this isn't giving you a clean edge on which to smooth. So Booleans are really great for mechanical objects, objects that really aren't going to deform, be smoothed, or change shape. So just be aware of that if you decide to use Booleans. Now I want to talk a little bit about combining and separating objects. Now, typically when we've been working with objects, we work with them separately. So, for example, I have this head model up here. This is actually head.mb. And if we look at it in our outliner, you'll see it's actually a bunch of different objects. I have the head itself, which I can move, and I also have the eyes and the gums and the teeth, and they're all separate objects. Now, this may be good if I want to animate it this way, but a lot of times you want everything to be part of the same model. Let's say you model the teeth and the gums, separately, and then you want to bring it all together as one mesh. You can do that by using a feature called Combine. And let me show you how that works. All you have to do is select the objects, and these all have to be polygonal objects that you want to combine, and then just go Mesh, Combine. Now watch what happens. Is when I do this, if you look at it in the outliner, all of these go blank, and all the geometry goes into this one node called Poly Surface. And basically what happens is they all become part of the same polygonal object. And even though they're not physically connected, they're still part of the same object. So for example, if I wanted to, I could select the faces of this eyeball. And if I wanted to, I could grow that selection using, in fact, let's show this in wireframe here. I could just grow that selection using the greater than sign and just go ahead and grow that. Now let's go ahead and shade this. Once I have that selected, you can see it's actually still a separate object, but it's just separate faces within this surface. Now, if I want to, I could actually separate out these objects one at a time, or I can separate the whole thing all together. If I want to separate them out one at a time, all I have to do is just pick a face on any one of these objects and go separate. And when I do that, it actually creates a separate surface for, in this case, the eyeball. So now the eyeball, again, is just a separate object. If I want to separate the whole thing, all I have to do is just select either the model or every face within the model and just go Mesh, Separate, and then that just puts it back to the way it was. Obviously, the pivots change and the names of the objects change, but it's pretty much all separate again. So that's a way of combining and separating objects within polygonal surfaces. Now let's look at the merge tools within Maya. I have a file here that's open. It's called hand.mb. And what it is it's a hand and the wrist that it's attached to. So this is a subset of a character modeling issue that you'll probably encounter, which is taking different body parts and connecting them together. So oftentimes you'll model the hand separately from the character and you'll want to attach it, or you'll steal the hand off of another character so you don't have to model it twice. But there still exists the problem of connecting them together. And we do that by using the merge tools. Now, in order for merge to work, these two objects have to be part of the same polygonal object. So we connect them together by using combine. So all I have to do is shift select or rubber band select both of them, and then just go mesh combine. Now they're part of the same mesh. Now, in order to connect these two, though, we still have a hole, and we need to connect this side to that side seamlessly so it all connects together. Now, we can do this using one of three different tools. Under Edit Mesh, we have Merge, Merge Vertex, and Merge Edge. Now, I'm going to go through Merge first. Now, Merge typically works on vertices, so let's go ahead and right-click and go into Vertex Editing mode. And what we have to do is we have to get this vertex close to that vertex. It's best if we get them exactly coincident, which means one on top of the other. So what I can do is I can just hit my move tool and move that in and hope for the best. But probably the better way to do this is to use snapping. So what I can do is go up here and click on Snap to Vertex, which is this little magnet with a dot underneath it. And then I can just snap these vertices together. So I can just snap, snap. I'm not going to do all of these because I'm going to show you some of these other tools here. So I'm going to snap, snap, snap. I'll snap three of these together. So now the vertex on this side is exactly on top of the vertex on the hand side. Now I'm going to turn off snapping and then just select each of these 3 points, which are basically two vertices on each side. And then I'm going to go Edit Mesh, Merge. But let me go ahead and show you the options here. So I'm going to go over here and just bring up the options. And there's actually only one option here, and that's Threshold. And that means that if the two vertices are within 0.01 in terms of distance together, then they will merge together. And since we've snapped these, they're actually at 0. So let's just go ahead and go Merge. And when I merge those together, what happens is they're stuck together. Now, 2 become 1, and I have that part of the surface is merged together. Now, there are some other tools within Maya that you can use to merge as well, and these are probably a little bit easier to use. So I'm going to go back into vertex mode, and we're going to use the Merge Vertex tool right here. All you have to do is just click on that tool, and notice how your cursor changes, and also when I move over vertex, it highlights in red. So all I have to do is left-click on that and drag, and I drag it to the vertex I want to merge it to, and then snap, bingo, it's merged. So this is kind of a lot easier than snapping and merging. There we go. Now, before I completely close this up, let me show you the other tool. Let's go ahead and go Edit Mesh, Merge Edge Tool, 1, 2, Enter. And again, let's go ahead and just stitch up the rest of this guy here. So just go Merge Edge Tool, and there he is. So now this is completely stitched up, and I have a completely together model. And now when I go to smooth it, it all smooths perfectly. Okay, so those are some of the methods for combining open edges and vertices together within Maya. For those of you who are doing subdivision surface modeling, the crease tool can actually be a real help in adding sharp edges to a model. Now, I have this particular character up, and when we smooth him, let's go ahead and hit the 3 button. I'll select his head and hit 3. You'll notice that it smooths pretty much everything. Now, if we look, for example, at his lip, we've got a very smooth lip. Now, sometimes you want a little bit more of a crease. You don't want things to smooth out. Now, we can affect that by using the crease tool. Now, how we do that is we select the edge. In fact, we can just go ahead and go to edge mode, select that edge, and I'm going to hit the right arrow to select the whole loop of edges. And then we go into Edit Mesh, Crease Tool. And all I have to do now is my cursor changes, and it says drag middle mouse button to edit crease value. So I middle mouse click, and notice I can decrease it or increase it, but notice how that edge on the lips gets sharper. So you can actually sharpen an edge. So that rounding that automatically gets put in when we do subdivision surfaces can get taken away. So you can actually make sharp edges. Now, this is good in character modeling. It's also good in a lot of other areas. So, for example, here, where his nostrils hit his cheek, a lot of times there is a crease. And this is getting a little too smoothed out on this particular model. So again, I can select those edges, middle mouse click, and crease them up a little bit so you have a little bit more realism without having to add additional detail to get that crease. Now again, this is when this renders. Let's go ahead and change this over to Mental Ray. So when this renders in Mental Ray, you can see how we get a really nice crease and a little bit of sharpness to define that lip. So those are some of the basics of the crease tool in Maya. The last thing I want to talk about is object history. Now, this is important for all areas of Maya because what Maya does is it creates a history of everything you do and attaches it to the object. Now, this is really important for modeling, but it affects pretty much every area of Maya. So let's go ahead and create some history so we can play with it. So I'm just going to go ahead and create a sphere. And let's just do some modeling tasks here. I'm going to go into face mode. I'm going to shade this, go into face mode, select the top part of this sphere. Let's just do an extrude. And maybe a scale. Maybe move that down a little bit. Okay. And then maybe I can add in some edge loops or something like that. Go insert edge loops. Okay. Now notice as I'm doing this, it's creating all of this history. So I started with a sphere, I extruded it, then I moved some stuff around and I tweaked it. And then I added 1, 2 edge loops. Now all of this history is held onto this model. So if I go into my attribute editor, I can see all of these nodes and all of the things that I've done to create this object. So I can go into my original sphere, change the radius. I can go into my extrude, change the number of divisions. Now notice how when I'm changing the number of divisions, it affects what goes above that. Because what I've done is I've tweaked and I've added edge loops. So what happens is that when I add some divisions, the edge loops get affected. So you have to be a little careful about how you work with this history. But I also have a list of everything that's done to the object. Now this history also shows up in our hypergraph. Now we've played with this a little bit. We go into hypergraph connections and we can see everything that we've done to this object. These show up as nodes. In fact, if I zoom in here, you can see I've got a sphere. I extruded the sphere. I tweaked the sphere. I did insert edge loops. And then at the very end, we shade it. Okay. Now, if you do a lot of modeling, you're going to get a ton of history. And sometimes that's not a good thing, because if you have a lot of history, what happens is that if you keep this history around, Maya recalculates it every time you load the object. So if I click on this object, it says, okay, I'm going to take a sphere, I'm going to extrude it, I'm going to tweak it, I'm going to add 2 edge loops. And every time you select that object, it goes through and it essentially rebuilds it. You know, sometimes that gets a little much, and if you have a lot of history, it really slows down the system. So what you can do is under Edit, you can delete the history. Now there's a couple of ways of deleting history. One is just to delete the history on the object. So if I do that, all the history goes away, and now it's just a mesh that's that shape. I'm going to go ahead and undo that by hitting Control Z. If we want, we can also delete what's called non-deformer history. Now, this is really applicable to character animation because a lot of times with character animation, you have deformers applied. So, for example, the skin of a character will deform. So you can delete everything but those things that are deformers. Now, if you have a really big scene, we can also do delete all by type, and you can delete all the history on every object in the scene if you want, or all the non-deformer, or you can also delete all sorts of other stuff. You can delete all the lights in the scene, all the cameras, and so on. That's some of the basics of history. So I guess the big point here is to just keep track of this. If it starts getting really long, then go ahead and delete it. And one of the things I do is that once I finalize a model and I know it's complete, I'll go ahead and save out a version with history, and then I'll go ahead and delete history and save a new version so I kind of have a clean copy for when I go ahead and texture it or do something else. So those are the basics of history, and let's go ahead and move on from here. The second type of modeling in Maya is called NURBS, and NURBS stands for Non-Uniform Rational B-Splines. And that's just a fancy word for patches. And what a patch is just a curved surface. And the file I have open is called DecoCar00. And this car is built pretty much entirely out of NURBS surfaces, or NURBS patches. And let me show you how these work. A NURBS patch is essentially kind of a whole flexible object. Okay, it's almost like a subdivision surface, but it's actually composed of four-sided patches which are bounded by curves. And so by modeling with NURBS patches, you can create very curved and very smooth surfaces. Now, NURBS originally came from the automobile industry, and they use it a lot for designing car bodies and stuff like that. And that filtered into Maya through a company called Alias, which created a lot of the original technology used in Maya. So all of the NURBS tools are located under the Surfaces directory. And NURBS are basically composed of curves. So we have an Edit Curves tool here. And we also have surfaces, which allow you to create surfaces. And then we have another menu set here called Edit NURBS, which allows you to actually edit NURBS surfaces as well. So we're going to go ahead and be going through all of these tools in the next 2 chapters. One way to start modeling in NURBS is to just use NURBS primitives. Now we have a number of primitives here under the Surfaces tab or under Create NURBS primitives. In fact, let me go ahead and tear that off. So a lot of these are contained on this shelf as well. So NURBS primitives pretty much cover the standard range of the primitives that we would normally expect. One is the sphere. Now notice how the NURBS sphere is a little bit different than the polygonal sphere. In fact, let's go ahead and draw a polygonal sphere right next to it so we can kind of see the difference. And the big difference is that the NURBS surface is smoother with less detail. In a polygonal surface, each face has an edge, and the edge is a straight line. So you can see that's a straight line from there to there and from there to there. Now with a NURBS surface, the edges of the patches are curves. They're not straight lines. So we have an infinitely curved surface. So we can actually calculate the curvature wherever we are at the surface and have a perfectly smooth result, which is one of the really good benefits of NURBS objects. Now with a NURBS sphere, we have a number of different parameters. Now these are actually different than what you would have for a polygonal sphere. Of course, we still have the radius, which is the same for both. But with a NURBS sphere, we also have sections, which are your radial subdivisions. And we also have spans, which are your vertical subdivisions. But in addition to that, we have what's called a sweep. We have a start and an end sweep. Okay, now here, let's take a look at that from this side here. And notice how one of these latitude lines is actually a double line, and that's where the NURBS surface seams together. And the thing with NURBS surfaces is that each of these primitives is composed of rectangular patches. So a sphere is essentially one rectangular patch that's looped around and kind of bunched up at the poles, almost like if you took a big piece of wrapping paper and wanted to wrap a basketball, you would wrap it around and then scrunch up the poles. That's basically what happens with a NURBS surface. So this is all one surface that's just been deformed into a sphere. Now that's the same for a lot of these other primitives. So let's go ahead and look at some of these other ones. I'm going to skip over the cube for right now. Let's just go to the cylinder. The cylinder, in fact, let's take a look at these parameters here. Again, we have radius, we have a start and an end sweep, and again, look, this is a patch. Now, the thing about NURBS surfaces is that every NURBS patch is a four-sided surface. So for something like a cylinder, it's actually made up of 3 separate NURBS patches. So let's go to the outliner and take a look at this. We have our NURBS cylinder, but that's actually a group that contains the cylinder, the bottom cap, and the top cap. Now, each of these caps are actually separate patches. So if I do this, I get an exploded view of what comprises this cylinder. I have the cylinder itself and then both of the caps. And you can see how the cylinder is actually composed of a rectangular patch that's just wrapped around. It's almost like the label on a soup can or something like that. So this is one thing you have to be aware of when you're dealing with NURBS surfaces, especially with primitives, is that when you create these primitives, you actually can be creating multiple pieces of geometry. So if I don't want, for example, the caps on the cylinder, I can just select them and delete them, and then all I have is the original cylinder. Okay? So now that brings me back to the one that we skipped over, which is the cube. Let's go ahead and create a NURBS cube. And when I do that, you'll realize very quickly, in fact, let's take a look at this. This is actually a group containing 6 separate patches. So in a polygonal cube is all pretty much stuck together, but a NURBS cube is just 4 separate flat patches that are just grouped together. In fact, we can add detail to each of these patches separately if we want, or we can add them to the whole group. So let's take a look at some of the rest of these primitives here. We have a cone. And again, a cone is very similar to a cylinder, except it doesn't have a top cap. So it's a cylinder that's kind of bunched up at the top with a bottom cap here, right there. So we can select those and delete them. And then we have the plane. Now, actually, the plane is the most pure in terms of what a NURBS surface is, because a plane is a basic NURBS patch. In fact, I can give you a little bit of detail here. And so this is essentially what all NURBS surfaces are composed of, is just a four-sided patch. And the last surface is called a torus. Now, a torus is composed of one patch. In fact, let's go ahead and select that, and we can actually unwrap this. Now, we have a sweep that goes radially, so you can see that this is actually a cylinder that's been spun around into a donut. And if we want to, we can also unsweep it in the minor direction, so you can see that this is actually 1, 2, 3, four-sided patch that's swept into a cylinder and then swept again into a donut. Okay, and then again, we can certainly change the height ratio and the parameters of that donut. Now, there are two additional things in this NURBS primitives menu, and one is called a circle. And that's pretty simple. Now, that's actually just an actual curve. It's not a surface. And then we also have a square. Now, a square is very similar to how it creates a cube. We actually have 1, 2, 3, 4 straight lines that create the square. So that's kind of almost like a bogus square, because it's really just 4 lines. It's not actually all connected. So you got to be aware of that when you create those. Now, another way to create NURBS surfaces is by starting with curves. So Maya has a number of curve tools that allow you to draw and create curves that you can later use to construct surfaces. So let's go over some of these curve tools. We have under the Create menu a couple of them: CV curve, EP curve, pencil curve, arcs, and then text. We also have a curves shelf, which has a lot of these tools. Now, we've already seen the circle tool, which basically just draws a circle. And we've seen the square tool as well. Now, probably the most common tool for creating a NURBS curve is called the CV curve tool. This is probably the most popular. Now, with NURBS curves, I typically like to draw them in an orthographic viewport, like a front or a side viewport. So let's go ahead over to a front viewport here. And the reason we draw curves in an orthographic viewport is because generally you want to draw them along a flat plane. So we can go create CV curve tool, and that brings up this little cross-haired cursor. And then all we have to do is left click to lay down our curve. So if I left click, it lays down what's called a CV, or a control vertex. And notice how the first vertex is a square. And then we can lay down a second vertex, which is a U. Now, this gives us the direction of the curve, but we're not seeing the curve yet. All we're seeing are the points. In fact, if I lay down a third point, I still don't see the curve. For a NURBS curve to be visible, in fact, for a NURBS curve to even be defined, you need at least 4 CVs. So when I lay down my 4th CV, you'll see the curve. And then I can continue to draw. So you need a minimum of 4 CVs to create a curve. And then once I've laid down my curve, all I have to do is hit enter, and that ends my mode. And here I have my CV curve. So let's go ahead and do that one more time. CV curve tool, 1, 2, 3, 4, and then you can continue to draw. Now there's another way of creating a curve, and that's using the EP curve tool. And let's show you how that works. Select that tool, and again you get the cross-haired cursor. Select your first one, second one, and by the time you hit your third one, you're starting to see the curve, but it actually draws that curve between the first 2 points automatically. So you can just draw. Now notice how the curve goes through the points. This is actually very different from the CV curve tool. So this actually draws the curve through the control points. When you do the CV curve tool, the curve is always off of the points. Notice how the points always lie outside of the curve. So with the EP curve tool, it's just an input method. They both create this exact same type of curve once you go to edit it. Now there are additional tools here. We have the pencil curve tool, and this is just a freehand drawing tool. Okay, and then if you want to, you can go back and edit this. Now the one thing about this type of curve is that it creates a lot of data. Okay, so this is not really a curve that you can edit all that easily. And typically you want to use the other types of curves because you can actually define them more succinctly and not have to have so many points to edit. But that's there. And then we also have what are called arc tools. So we have a 3-point and a 2-point circular arc. Let's go ahead and start with the 2-point arc. So basically we lay down 1, 2 points. And then all we have to do, you can go up to a semicircle with this, and then you can go angle and radius as well. And then just hit enter, and that defines that curve. And then we also have what's called the 3-point circular arc. So you go 1, 2, and then the third point. So this is for curves that are more than 180 degrees. So those are the basics of creating curves within Maya. Another way to create curves is by creating text. Now, text actually can create more than just a curve. Let's go ahead and do create text and see how this works. So when I create text, it just brings up some rough text. Now, if I want to actually input the text, I have to go over here to the tool options box here and click on that. And that gives me the text that I want to type in. I can also select the font right here, bold, italic, whatever, font size. And then I can also output this as curves, which is one way to create a curve. You can also output this as polygonal objects. You can also output it as a polygonal object with a bevel or as what's called a trimmed surface. I'm just going to output this as curves right now. And what this does is it creates outlines or curves that you can use for modeling or whatever. And if we go into the outliner, we can take a look at how these work. Each of these is grouped, and then every letter and every shape within the letter has its own curve. So for example, an A would have 1, 2 curves, and so would the D. Now, if you do want to create solid text, I'm going to select these and delete them. You can create them as a trim surface, which basically creates them as a flat NURBS surface, like that. Okay, so that's basically just a patch that's been trimmed away. You can also create text as a polygon. Now, once you do that, you get all sorts of operations here. Okay, do you want to bring them out as triangles, quads, all sorts of options here. I usually use quads and standard fit, and you can just go create, and that creates that as a polygonal object. Or we can do text as what's called a bevel. Now what a bevel does is we can actually give it a width and a depth, and then also an extrude distance. In addition to that, you also have, let's go ahead and bring this down. We also have, do you want the bevel to be straight out, straight in, concave, and so on. You have all sorts of different bevel styles. So you've got a lot of options here. And if you create that, then you can see I've actually got nice extruded text, which is actually probably what a lot of the motion graphics people want, is they want some depth to their text. So that's how you do that. So those are some of the basics of text. Now that's a way to create objects or curves. Now, sometimes I use text to actually create a curve that's a rough shape of what I want, and then I just go ahead and remodel that into the shape that I so desire. So let's go ahead and move on to some other stuff. So now let's take a look at how to reshape and manipulate NURBS curves. I'm going to go into my front viewport and just draw a curve. I'm going to use my CV curve tool and just sketch out a number of points here and then just hit enter. Now, if I want to edit this curve, I have a marking menu that's available. All I have to do is right click above this curve and I've got a number of options here. The most important one is Control Vertex. If I select that, all of the CVs show up for the curve, and all I have to do is just select one of those, and I can move them wherever I want. Now, I can move them also in 3D if I want as well. Now, notice that all of these CVs are dots except for the first two that I drew. The very first CV of the object is always a hollow box, and that tells me that this is CV number 1. The second CV is always shaped like a U, and that tells me that this is the direction of the curve. So it goes CV 1, 2, 3, 4. Now, for most modeling tasks, we really don't need to concern ourselves with the way that the curve is drawn. But for something like an animation path, you actually do need to understand the direction of the curve, because if you're animating something along a path, it needs to start here, go along the path, and end here, rather than the other way around. Now, in addition to these CVs, we also have things called curve points. Now, what a curve point is just a point on a curve where we do another operation. And we'll get to that in a little bit, but just know that that curve point exists. We also have what are called hulls. And what a hull is almost like an edge loop for a curve. Now, hulls are probably more important in editing NURBS surfaces than they are in curves, but we do have that option as well. And then we also have what's called an endpoint. And that allows us to edit the curve like an EP curve tool. Okay, so if I edit it with endpoints, that means I'm editing it almost like I draw it when I use the EP curve tool. And then I can go back to object mode. Now, in addition to this, we also have, under Edit Curves, we have what's called the Curve Editing tool. And what that does is it allows us to edit the curve at any point. So I've got a couple of operations here. I've got this box, and if I move the box, this center box that's on the curve, I actually can reshape the curve. If I move this little box here, this little blue box above it, I can actually slide that. So this box here is where we're actually doing the action, and we can slide this box wherever we want, and then either reshape the curve, or if I click onto this handle, I can also affect the direction of the curve as well as the sharpness of the curve. So this is almost like a Bezier handle. So I can actually make a really tight curve, a really broad curve. I can make it pointing this way, and then I can move it, and then move that point of action as well. So that's a really handy way to edit these curves. And when you're done with that, you can always just hit enter. So that's how you edit curves in Maya. So now that we understand the basis of creating and editing curves, let's go ahead and do some more operations to curves within Maya. I'm going to go back into my front viewport, and I'm going to draw a CV curve. Now, one of the more common things that people want to do when drawing a curve is to draw a closed curve. Now, typically, the first thing people want to do is just draw that CV over the first vertex, and hopefully it just creates a closed curve. But that's not the way that Maya works. You actually have to explicitly open and close the curve. So I'm going to hit enter and end creation mode, and then I'm going to go into my Edit Curves menu. And here we have an option called Open Close Curves. And when I select that, what it does is it actually closes that curve. In fact, let me undo it here. When I redo that, Open Close Curves, that's what it does. This is actually a toggle. So if I have a closed curve and I do Open Close Curves, it opens it up again. This is where curve direction becomes important, because if I look at my control vertices, I have this vertex as my first vertex. This is always where it will open the curve when I open a closed curve, between this vertex and that one. It will never open it here or here. So that's one of the most important ways of creating that first vertex. Now, another thing we can do with curves is we can break them in two. We can do that using the Detach Curves tool. Now, in order to break a curve in two, it needs to know where that curve is going to be broken. And that's done by using a curve point. So I can right-click over here, bring up my marking menu, and go to Curve Point. And then I just left-click and drag this little red dot, and wherever I drag it, that's where it will perform the action. And in this case, the action is Detach Curves. So I click on that, and next thing I know, I've got two curves. In fact, I've got one curve here and another curve here. Now, if I want to, I can reattach these. All I have to do is select them, go Edit Curves, and Attach, and it'll go ahead and attach those two curves. Now, in this case, it leaves the old curves behind. Now, one of the nice things is that it does retain history. So if I go through and I edit the original curves, the attached curve will follow along. This can be kind of handy. Now, if you don't want that to happen, all you have to do is just delete by type history on the brand new curve, and then that will no longer be affected. Okay, so I'm going to go ahead and delete these. And let's go back to this curve. Now, another tool that you can do is called Insert Knot. Now, that allows you to add detail within a curve. So let's say we've got this curve here, and I want to add some detail in here because I want to sculpt out maybe another bump or something like that. So in order to do that, again, we have to use what are called curve points. So I just move my curve point to where I want to add in my detail, and then I go Insert Knot. And what that does is that inserts a new CV right at that curve point. Another way to cut and manipulate curves is by using one curve to cut another. So in this case, I'm just going to take two circles that are overlapping. And I'm going to select both of them and go Edit Curves, Cut Curve. Now what this does is it takes each circle and it cuts it where the two overlap. Now I can use this to create new curves. So for example, if I take that kind of teardrop in the middle, I can actually attach those two curves and create a unified curve. I can also use these to do things such as fillets. So if I go Edit Curves, Curve Fillet, what it does is it actually creates a semicircular curve that bridges these two. And again, I can use that curve to cut the other curves if I want. And then I can have all of these together and make them into a unified curve if I want. So as you can see, there's a lot of different ways to use these cut tools to build new curves out of existing curves. The Offset Curve tool allows you to create a copy of an existing curve. So let's go ahead and go into our front viewport and just create some text. I'm going to go here and click on this little box, and let's just create the text M, and I'm going to create that as curves. So just go ahead and hit Apply. And so now I have the letter M as a curve. Now if I want to, I can use the Offset Curve tool to actually make a copy of this or to make an outline. Now, if I go over to my channel box, you can see I have a distance value here. And I can extend that or make it either big or small and create an outline there. Now, this works for any curve. It doesn't work for just text. So I can actually create just a standard CV curve, hit enter, edit curves, offset, offset curve, and then again, you can give it a distance, positive or negative. Now, in addition to offsetting curves, you can also extend them. So go edit curve, extend, extend curve, and what this will do is it will extend the end of the curve by a specific distance. So basically it finds that tangent and it just continues to extend. In fact, you don't have to extend at the end. You can also extend at the beginning. Let's go to the attribute editor here and say we don't want to start at the end. We could start at the start or both. And again, this is where that initial vertex comes in handy. So for example, if I look at this one here, the first vertex was here, the last vertex was here. So when I extend this curve, it's going to go from either the start, the end, or both. And then, of course, I can certainly give it a distance. And also I have an additional option here for whether you want to go linear, circular, or extrapolate the curvature that was already there. Let's take a look at some basic NURBS surfaces and how to reshape and manipulate those surfaces. I'm going to go over here to the Surfaces tab, shelf. I'm going to go over here to the Surfaces shelf and select the NURBS sphere. Just drag that out and shade it. Now, if I right-click over this, I will get a marking menu with all the different components for that object. Now, NURBS surfaces have control vertices. NURBS surfaces have control vertices, which are a lot like the vertices in a polygonal object in that you can move them around to reshape the surface. They also have what are called hulls. Now, a hull is more like an edge loop. Now, notice how when I click on a hull, it selects all of the control vertices for that hull. So see how it's kind of got this cage around it, and by clicking on any one of these wires, I select the hull, and then I can just move all of those vertices. So those are two ways of reshaping a NURBS surface, but we also have some additional components here. One is called an isoparm. Now, an isoparm is a lot like the curve point on a NURBS curve. It's a point of action. So what I can do is I can select an isoparm on a NURBS surface, and then at that point, I can actually perform an action. We also have what are called surface points, which again are very similar to curve points, and they're again points of action on the surface. And the last one is surface patch, and that just allows you to select each individual patch on the NURBS surface. But for most editing, we tend to work with control vertices and hulls because that's the best way to reshape these surfaces. Now let me show you one more thing about a NURBS surface. I'm going to go ahead in object mode and just delete this. And I'm going to draw a NURBS patch. And I'm just going to drag it above the grid here. And then I'm going to right click and go Control Vertex. Now what I want to show you is that just like a NURBS curve, a NURBS patch also has a direction. If we zoom in here, you'll see that we have a square vertex, which is very similar to the square vertex on a NURBS curve. And then off to the right, I have, if you can see this, I'm not sure, let's go into wireframe mode. So off to the right here, I've got this U. And what that U is the U direction. So I have a curve going in this direction defining that surface. But I also have a curve going in the opposite direction to define that other edge, and that's actually called the V direction. So while a curve really basically has one direction, a NURB surface actually has two directions. So it has a U and a V direction. Now these become very important when you go to apply texture maps to the surface as well as do other sorts of actions. And again, once I've got this, I can certainly reshape the curve and reshape the surface. Now we're going to start creating surfaces from NURBS curves. Now most of the tools for creating surfaces are in the Surfaces menu, and these allow you to turn NURBS curves into different types of surfaces. Now we have Revolve, Loft, Planar, and so on. Now the first tool we're going to use is Revolve. So let's go ahead and do that. So first of all, let's just do the classic exercise for Revolve, which is to make a wine glass. And let's just show you how this tool works. I'm going to go into my front viewport and zoom out a little bit. In fact, I'm going to turn on grid snap so I have a little bit more accuracy here. And I'm going to draw a CV curve. So I'm going to start at the origin at 0, 0, snap to that, and then I'm just going to snap out the outline of a wine or a champagne goblet. Something like that. And then once I have that selected, I can zoom out and I can revolve this into the actual object. So all I have to do is do surfaces revolve. Now there's a problem with revolve in that it actually works around a specific axis. So in this case, I revolved around the wrong axis. So I'm going to go ahead and undo that, and let's make sure we have everything set properly. So I'm going to go revolve, and I'll go ahead and click this box here. And that brings up my tool options. And so here I have my axis. Now this is going to be preset to whatever you had it set for before. And in this case, I want to set it to the vertical axis, which is Y. And then I also have some additional options here for the type of object that I can create. But the most important thing for right now is the axis. So let's make sure that that's at Y, and then we just hit revolve. And there we go. There's our goblet or chalice or whatever you want. Now, once I've done this, I can certainly go back and modify the options. I can either go into my channel box or into my attribute editor, find my revolve, and I can adjust the parameters. So for example, I can adjust my sweep, and I can adjust the number of sections or whatever else I want. Now let me show you another way of doing revolve. In fact, let's use this in a more practical application. I'm going to go ahead and open a scene, revolve.mb, and this is our little car that I showed you. And so I'm going to show you how to make one of these tires. Now the tires are made out of NURBS, and they're actually made out of this outline, which has been revolved. So if I do a revolve right now, let's go ahead and take a look at this. I'm going to turn off snap here. Now if I take a look at this and actually just do a revolve, you're going to see it's not really going where I want, because it actually revolves around the center or around the pivot point of the object, and that's not really what I want. So I'm going to undo this, and what I have to do in order to get this to revolve properly is I need to center this pivot, or actually put this pivot in a place where the center is right where the center of the tire needs to be. So I can go modify center pivot, and that centers it to the geographical center of that curve, but I actually need to move it up a little bit higher. So I'm going to hit insert or home and move that up about there maybe, and then just end that mode by hitting insert again. So now that I have that, all I have to do is hit revolve. But again, I need to make sure I'm revolving around the right axis. In this case, you can see it's the red arrow is where I want to revolve. And of course, red is X. So I just make sure that that's X, and I hit revolve. And there's my little tire. Now notice that this creates a second surface. So I have this tire. In fact, let me show the grid here. The actual origin of this is at 0, 0. So anytime you revolve a surface and create a new surface, it's always created with the pivot point at 0, 0. So in other words, if I want to move this, I move it from there. And that means if I want to spin the tire, it's going to spin around that axis, and that's not really what I want. So I simply have to do center pivot, and then that works. And then I can just go ahead and position that tire. Now the other thing is that this is dependent upon where this outline is. So if I start moving this outline, because I have history turned on, I can still affect the shape and characteristics of this tire. If I take this curve and actually edit the control vertices, I can still edit exactly how the tire looks. So if I want to get rid of that, simply select the actual NURB surface, edit, delete, history. Now sometimes you don't want to delete history on these things because you can actually edit the curves or animate the curves to create shape animation in your NURBS object. But in this case, we really want this tire to be pretty solid, so we don't need that sort of history. The next tool I want to cover is Loft. And what Loft does is it actually takes multiple curves and it connects them together to make a surface. Let's go into my side viewport, and I'm going to create a CV curve. It really doesn't have to be any specific shape. I'm just going to make it kind of like a little undulating shape here. And once I have that curve, I can go ahead and duplicate it. Now, I don't know if I've covered this before, but duplication is just Control D, or you can go Edit, Duplicate. And when I do that, it just creates a copy of that curve. In fact, we can see it here in the outliner. So if I do Control D, I can create a copy of the curve. So now I have 3 curves. In fact, if I want to, I can go and I can actually edit those curves and reshape them if I want. And let's go ahead here, right click, Control Vertex. And I'm just going to vary up these curves just a little bit so we have something to work with. Now that I have these curves, I can loft them together to make a surface. Now, there doesn't have to be 3 curves. It can be as many curves as you want to define that surface. So all I have to do is select the curves in order. So I can select them, hit the Shift key, 1, 2, 3. Now notice the last one I select is highlighted in green. So if, for example, if I rubber band selected them, you could see that one selected in green. And if I selected them in maybe a different order, they may get selected differently. Okay, so again, you want to make sure that you select them in order because this is important for Loft. And then I can just go Loft. And what that does is it creates a surface that's bounded by those curves or defined by those curves. In fact, if I go back to any of these curves, I can certainly move those curves and change the character of the surface. In fact, if I want to, I could even edit those curves or do whatever I want. Now, the reason you want to pick these in order is that it does remember that order for when you create the loft. So if I did this one, then this one, then this one, and did a loft, it's going to create a different loft. It's going to go from here to here to here, rather than over the top. It's going to kind of go under and over. So you really do need to be careful about how you select those curves. Now, rubber band selecting them is usually okay, but I always tend to be extra cautious and just select them individually in the order that I want. Now, if you want, you do have a few options here with this, and one is called section spans, which really just gives you a little bit of interpolation here on this particular surface. Now, let me show you a little bit more of a practical application for this, and we're going to be playing with that car that we're working with again. So let's go ahead and open a scene, and we're going to open a scene called, of all things, Loft. And that's basically the fenders of this car. So all I have to do is just select the curves that make up the fender. So I'm defining the fender by drawing curves that go over the wheels, and that way I can very easily define how that shape is. It's much easier to draw these curves than it would be to actually take a flat NURBS plane and deform it into this shape, particularly because I can get these nice tight corners here. So all I have to do is select those and again, just do loft. And now I have a very nice set of fenders for my car. The extrude tool is another way to create a NURB surface from curves. Now what the extrude tool does is it creates basically a tube or a hose using two curves. One curve is called the path, the other curve is called the profile. So let's go ahead and draw a path here. I'm just going to go ahead and create a CV curve. And I'm just going to go ahead and sketch out just kind of an S shape here. And then I need to create what's called a profile. This is my path. This is going to be, for example, the length of my garden hose. And then I need to create something that shows the diameter of that. The easiest thing to use is a circle. So let's go ahead and do that. And I'm just going to go into my front viewport and draw a circle. And if I want to, I can move that close to the path, but it's not critical that these two actually be aligned. And let me show you how this works. We start by selecting the profile, which in this case is a circle. Then we select the path. Then we go surfaces extrude, but I'm going to go ahead and open these options here because we have two options. One is, do we want the result position at the profile, which means at the circle, or at the path? Let me show you how that works. If I do it at the profile, then it takes that path, moves it to the circle, and extrudes it from there. Let's do this again. Circle, then the path, surfaces, extrude, and let's go to options here. If we go to the path and extrude, then it takes that and it tries to align it to the path. Now, it may not align it perfectly, but we can also go into our creation options. We can go back to this option here, or we can actually go into our attribute editor here, and we can define how that works. One of the things we can do is we can actually make it aligned to the component pivot or the center of the bounding box of the pivot. So sometimes you just have to play with these options to get it right. Now, once we have this, we also have some additional options. We could actually rotate that surface, and we can also scale it. So if you want this to go to a point or something like that, you can also do that. Now, the nice thing about this is that this allows you to animate things like hoses by just animating this path. So if I go into my outliner and I select that original curve, I can actually go in and modify it. So if I go into component mode here and select my curve, if I have history turned on, I can actually animate that path and animate the curve as well, or just reshape it if I need to. Now let's go ahead and look at this in a more practical application. Let's go ahead and show it on that car that we were playing with. Let's go ahead and open extrude.mb. And in this case, I have the car. Now, this isn't quite done, but I want to create the outline or the little rubber gasket around the window. Now, in this case, I've got something a little bit different. So instead of an actual curve, I have what's called a trim edge, which is essentially a curve that's locked to the surface of this car. And we'll show you how to do that in a little bit. But just know that this is a curve, this outline here. So I select my outline, and again, it's just a circle. Now, this doesn't have to be a circle. It can certainly be in any open or closed curve. And then here, I right-click, and instead of curve, I select trim edge, hold down the Shift key, and select that. Okay, now this is just a curve, but it's called a different thing. It's called a trim edge. And again, I just go surfaces, extrude. And that creates my window grommet. And if I want to, I can go back into my attribute editor and I can adjust this as required. Now, the really cool thing is that because this is using what's called a trim edge, it's actually locked to the surface of this car. So if I go in and actually readjust the vertices of this car, the grommet goes with it, which is kind of nice. Okay, and I'll show you how to create those trim curves in just a little bit, but just see how that works. That's pretty cool. So those are the basics of extrude, and let's go ahead and move on from here. Now let's take a look at the planer tool. What this does is it takes a flat curve and it trims out a NURBS patch. It's like a cookie cutter for NURBS patches. Let me show you how this works. We need to start by drawing a curve. In fact, I'm going to do this in my top viewport, and I'm just going to create a CV curve. In fact, I'm going to create it in kind of a heart-shaped here. Now this curve needs to be closed. So I'm going to go ahead, edit curves, open close curves. And the other key item is that the curve needs to be flat along any plane. It can be vertical, horizontal, left or right. It doesn't matter, but it has to be flat along a plane. So I can look at that and I can see that it's flat. And once I have that flat curve, all I have to do is just go surfaces, planar. And what that does is it actually projects a NURBS plane along the outside of this and then trims out all of the excess. Okay, so let's take a look at how this works. If I actually turn on, for example, control vertices of this new object, you'll see I actually have vertices that are way out to the side, because what it does is it fits the plane to the bounding box of this curve and then uses that to project. In fact, you probably see this better if I do hulls. You can see that's my plane. Once I've got this completed, this plane is actually trimmed out. So I can modify the control vertices of this plane to actually deform it. But the key is that because I'm projecting on a plane, this curve still needs to be flat. If I do anything to make it not flat, I can certainly move this way, but if I move it up or down off of the plane, instantly I create an error condition and that planar goes away. So you have to be very careful with that. So once you create it, go ahead and either hide or delete those curves. Now, another thing you can do with planar is cut multiple holes. I'm just going to go ahead and do new scene here. Let's not save this. And let's just go to the front viewport and create some text. I just want to create a letter that has a hole in it. So I'm just going to create an O, the letter O. And so what we have is we have two curves. We have two curves. And if I select them both and go planar, in fact, let's go ahead and look at this in perspective. What it does is it uses the outside and the inside curves to define the hole. So if you have multiple curves selected, it will be smart about it and actually trim out the holes. So that's pretty cool. Now, the one really neat thing about this is that you could actually use these curves again to create, for example, a loft. So if I select these outside curves, hit Control D and move them back, I actually can create duplicates of these curves. So if I select this edge curve here and this one, then I can also just use the loft tool to actually start building something a little bit more 3D. So you can kind of see how that works. I've got the two curves creating a trim, and then this outside curve is working with its duplicate to create the sides, and then on the inside we've got the same thing happening here. So that's one of the reasons why you would use a planar, is that if you want to kind of extrude some text or create a shape similar to this. Now, in addition to creating surfaces from curves, we can also refine existing NURBS surfaces using the Edit NURBS tools, which are all right here, and these work on existing surfaces. So let's go ahead and work with some of these. I'm going to go ahead and create a NURBS sphere and shade that. And the first tool I'm going to use is the Detach Surfaces. Now, this works very similar to the Detach Curves. Right here we have Detach Curves and we have detached surfaces. Now remember, with the detach curves tool, we had to set a point at which to detach that curve. We have to do the same thing with the NURB surface. Now on the curve, we used what's called a curve point. Well, of course, we don't have that on a NURB surface, but we do have a thing called an isoparm. So I can right-click over my sphere, select isoparm, and then left-click to define that point. So this would be my cut point. When I let go, you see I have this yellow dotted line, which defines my isoparm. And this is the point at which I'm going to perform my action on this surface. So if I go Edit NURBS, Detach Surfaces, bingo, there we go. I've got two separate surfaces. And you can see I can pop the top there. So this is a great way to refine and cut surfaces in half, or, do these sorts of tasks. Now, just like with the detach curves, we also have an attach. So in addition to detaching surfaces, we can also reattach them. So all I have to do is select both surfaces and go Edit NURBS, Attach Surfaces. And once I do that, I get a third surface, which is linked to the original two. So I can certainly move that and move that. And I have my history of these two surfaces. And I can certainly delete that if I want. So those are the basics of attaching and detaching surfaces. So let me show you a little bit about how to use this in the real world. We're going to go ahead and open a scene called Detach. And this is the car. And what we're doing is we're going to use a detached sphere to make one of these hubcaps, one of these little baby moon hubcaps. So I'm actually going to go into my side viewport, and I'm going to draw a NURBS sphere right over that tire. Now, when I draw it over the tire, it actually comes in at 0, 0, so it's actually going to be kind of under the car here. So I'm going to move it out to the side so I can see it. And then I'm going to right-click, go isoparm, and I need to find the point at which I want to cut off that hubcap. So again, I'm doing almost the exact same operation I did before. I find that cut point, Edit NURBS, Detach Surfaces, select the back one, delete it, and there's my hubcap. And I'm going to just go ahead and put that in the tire. So there's some practical applications for detached surfaces. Now, as we've seen, we have the ability to take curves and generate NURBS surfaces. But we also can go the opposite way. We can take a NURBS surface and extract or duplicate the curves off of a surface. Now, this can be really handy when you're building complex objects and you need to connect different surfaces together. Let me show you how this works. I'm just going to create a basic NURBS sphere, and I'm going to shade it. In fact, I'm going to go ahead and actually deform this a little bit so it's not a perfect sphere. So I'm just going to go ahead and select these control vertices and just kind of put a little dent in the side there. Then I'm going to go to Object Mode. Or actually, I'm going to go to isoparm mode, and I'm going to select an isoparm around the edge of this sphere. Then all I have to do is go Edit Curves, Duplicate Surface Curves. And what it will do will take the isoparm that I have defined and turn that into a curve that exactly matches the surface of this sphere. So this is actually a separate curve. Now, the great thing about this is that this curve is actually matched to the surface. So if I modified the surface, the curve would follow along with it if I have history selected and I have history turned on. Now, I can use this to actually create additional surfaces that attach to this sphere to create more complex objects. So let me show you how that works. In fact, I'm just going to go ahead and select all of these objects and delete them. And I'm just going to go ahead and create another sphere. Now this time I'm going to right-click over the sphere, select isoparm, and go about a third of the way down, and then just go Edit NURBS, detach surfaces. And I'm going to cut this in half like I've done before. Delete the top, and let's just take a look at this. Now this looks like a really nice little eggshell, but the problem is that we really don't have any thickness along the edge. We can do that by using curves and duplicated curves. I have my outside surface. I actually want to create an inside surface. I can do that by duplicating the surface once. So I just go Control D to duplicate, and then just scale that down. So now I have two surfaces. I have the original surface and the inside surface. And I'm going to go ahead and move this until it's right about at the same height. But I still have this gap that I need to fill. So I've got kind of a hole here that needs to be filled. Now I can fill that by using duplicate surface curves and a loft. Let me show you how that works. I right-click over the outside surface, go isoparm, and I set that to the very top edge. Edit curves, duplicate surface curves. In fact, let's go ahead and open the outliner so we can see what's being created here. I've got NURB Sphere 1, Sphere 2, and the duplicated curve. Now I'm going to create a second duplicated curve on this inside edge. And again, it's the exact same procedure. Isoparm, go up to the top edge, duplicate surface curves. Now remember, these curves are still attached via history to these surfaces. So if I redefine the surface, if I change it, if I edit some control vertices, they still stick. Okay, but I also have two curves. And if I have two curves, that means I can create a surface from those curves. And so in this case, I'm going to create a loft. So I select both curves, and then I go loft, and now I have an edge for my little object. Now, if I move any of these, the duplicated surface curves move with them. And so the whole thing kind of just hangs together. It's kind of neat. If I want to, I can select control vertices and deform it, and I still have that edge. So you can see now how by duplicating surface curves, you can make more complex objects by creating multiple surfaces. Another way to affect NURB surfaces is to open and close them. Now, just like we can open and close curves, we can also open and close surfaces. So let me show you how that works. Let's just take the most basic NURB surface, which is a NURBS plane. And I'm going to give it a little bit of detail and just go ahead and move it up above the grid here so we can see what's going on. Now, if I want to, I can just go ahead and take some of these control vertices along one edge. In fact, I'm going to be very specific about this. In fact, let's go ahead into wireframe mode. You can see here, this square one is the first vertex of the patch. We have two directions. We have a U direction, which goes along here, and we have a V direction, which goes along here. Now, what I can do is I can close it along either direction. So I can close it this way or this way. So let's go ahead and do the first direction. And I'm going to just take some of these vertices along this U side and move those straight up. Go back to object mode. And let's shade this so we can see what's happening. Then we go Edit NURBS. Open, close surfaces. Now I'm going to go over to the options here and show you what we have. Now we can open or close it along either direction, U or V. Now let's make sure that we're doing this in the right direction. We move the U vertices up, which means that this edge here is the V direction, and this is kind of how we want to close it. So let's go ahead and do that. Make sure this is on Preserve and do Open, Close. And when I do that, it preserves this shape and then draws a whole new patch that closes off this surface. In fact, if I go into control vertices here, you'll see it didn't add any new vertices. So I can actually take these and move them up. And what I have now is a nice loop. I have kind of like a little conveyor belt or whatever you want to call it. Now I can go back to this surface. And again, it's just like open and close with curves. So if I open it again, it just gets rid of that option. So again, I can go into my control vertices, and let's go ahead and move these ones back down, and let's just do this the other direction. So I'm going to take these V vertices, and I'm going to go ahead and move them around and get those ready. Go Object Mode, Edit NURBS, Open Close Surfaces. Now this time we're going to do it along the U direction, and go Open Close. And there we go. And again, I can undo that or whatever. Now, if we want, we can also do this along both directions. So let's go ahead to both. And what this does is it actually creates, you can kind of see it, almost creates kind of like a folded surface. And sometimes this isn't a very practical surface to have, but you can create it. And so there it is. So those are the basics of opening and closing surfaces. Now, these can be really handy when you are creating things such as tank tracks or treads or any sort of belt or loop. You can very easily create a surface that's closed using these tools. Now let's look at some advanced modeling tools. One of the first ones I want to show you is curves on a surface. Now what this does is it allows you to take a NURBS object and draw a curve on it. So that way you have a curve that's actually locked to the surface. Now we've seen how you can actually extract curves from a surface, but those are curves that are actually locked to isoparms, the latitude and longitude lines of a surface. But with drawing a curve on the surface, you can really draw it in any direction. So let me show you how to do that. We're going to create a NURBS sphere. I'm going to make it a little big so we can see it, and then just shade that. Now I'm going to keep this selected, and then I'm going to hit this magnet button here. And what this does is it makes the surface live. So any curves we draw stick to the surface. So notice how that changes color a little bit. And then we can go create CV curve. And once I do that, anything I draw sticks to that surface. You can see how that sticks to my surface. Once I have this on the surface, I can click live again to make the surface normal, and then just select the control vertices of that surface, and I can manipulate them. Now notice how these are stuck to that surface. Now the curve can be moved around if I want it to. You can also use a lot of the curve tools. You can, for example, open and close the curve, or you can do things such as offset. For example, if I want to offset this, I have to select offset curve on surface, but the functionality is pretty much the same. So now I have two curves, one's offset. And again, no matter how I deform this surface, those curves stay stuck. Now let me show you a little bit about how this works technically. I'm going to delete this. I'm going to do this one more time. Now how it works is that, remember that a NURBS patch is essentially a two-dimensional flat plane, or actually more like a sheet of rubber. And you can think of it almost as a piece of paper. And what we're doing is when we make that surface live, we're drawing on that paper. So when I create a CV curve, and now that curve is actually stuck to the borders. Now, no matter what I do to that surface or what I do to the paper, the curve is basically stuck to it. And just remember that any NURBS object, such as a sphere, is essentially a four-sided NURBS patch that's just been deformed. Another way to create curves on a surface is to project them. Now, we've seen how to draw curves directly on a surface, but you can also take existing curves and project them onto a surface. Let me show you how that works. I'm going to start with a NURBS sphere. Let's go ahead and shade that. And then I need a curve. In this case, let's just go ahead and create some text. So I'm just going to go ahead and go create text, and then just give us the letter O. Let's go ahead and create that. Now I can't see it because it creates it at 0, 0. But if I select it here in my front viewport and move it, I can see it here. And I'm going to go ahead and turn off the grid on this view here. Now, in order to project it, what has to happen is the system needs to project it in a perpendicular direction, or basically what it does is it projects in the direction of whatever viewport you select. So if I want to project this at a right angle, I do need to do this from the front viewport. So let's go ahead into the front viewport, select my curves, select my surface, go Edit NURBS, Project Curve on Surface. And what that does, as you can see in the perspective window, is it takes that O and it projects it right onto the surface. Now, if I want to, I could actually select the original one, and I can move that around if I want, because I have history turned on. Of course, if I delete history, that will go away. Now, the great thing about having curves on surface is that you can use them to create additional surfaces that attach two surfaces together. So, for example, with this O, if I selected this curve and shift selected that curve, so I have these two curves selected, I could actually build a surface such as a loft. And I could do it again for that curve and that curve. Now, if I want to, I could even select the curves in the front and then just do a planar to create kind of a little O on that sphere. Now, if you notice, the planar is essentially exactly what we've been doing here. It's a curve that's on a surface, projected onto a plane, and then those areas outside of the O have been just cut away or trimmed away. So that's how you project a curve on a surface. And let's go ahead and do some more stuff with curves on surface in the next lesson. Now let's talk about trimming surfaces. I'm going to use an actual example here from this Art Deco car. In fact, we need to set our project. So let's go ahead and go Project, Set, and let's set this to O5 Advanced. Hit OK. And then the file itself is called cartrim.mb, and you'll find it in that project. So here we have that Art Deco car, but this is actually a more primitive version of it. It doesn't have any windows yet. And we can create those windows by using what's called a trim surface. So what we can do is we can actually project a curve on this surface and use that as a tool to trim away the windows. So I'm going to use this. It's basically just an oval. I took a circle and just squashed it, and I'm going to project it onto this car. So I need to do that from, in this case, the front viewport. So let's go into the front viewport, select the curve, select the body of the car, go Edit NURBS, Project Curve on Surface. And what that does is, like we've seen before, it projects that curve onto the surface. Now what I can do is I can use this as a way to create the windows of the car by trimming away all of the area within those windows. In fact, I'm going to do a little trick here. I'm actually going to duplicate this. I'm going to hit Control D and duplicate the body. And when I actually duplicate a NURB surface that has curves on a surface, the curves actually go with it. So I'm just going to hold this up here for right now, and we're going to bring this back a little bit later. So I'm going to zoom in, and let's just work with this surface. So in this case, I want to trim away the holes for the window. So we go Edit NURBS, and we use what's called the Trim tool. Now there's a nice handy help down here on the bottom here, and it says click button 1 on the surface to select the region to keep. So I'm just going to go ahead and left click, and it creates a little dot there, and I'm going to keep that one. Or if I want to, I can actually select multiple regions to keep. In this case, I just want to keep the body, so I'm just going to hit Enter. And what that does is it actually trims away those parts of the surface that are inside those projected curves. This is actually just a rendering trick, because the surface itself actually is still there. In fact, if I go into Control Vertex mode, you'll see I still have the CVs for the entire body of the car, like, for example, right here. So what this does is it just does a rendering trick, and that it doesn't render that area within the trimmed surface. So basically, it's just saying, don't render those pixels. Now, if you notice, we have a little bit of an error here. You can see I've got a little bit of this kind of straight line here. That's just because of the way that Maya is calculating the surface in the viewport. If I actually did a render of this, you would actually see that it's perfectly smooth. So don't get freaked out when you see little artifacts like that. They don't show up in rendering. Now, the reason I copied the body of the car was that we can also use those exact same trim curves to make the windows themselves. And all I have to do with that is just trim it again. So I go into Trim Tool, and in this case, I'm going to click on Window, Window. So I have actually two surfaces I'm keeping. I hit Enter, and I don't keep the body. Now I select that, and you'll even see if I go into, for example, hulls, you could actually see that the surface really is there, and all that's being kept is just those parts for the window. So let's go back into object mode, and I'm going to do a little trick here. I'm actually going to my rendering tab. I'm going to click on a blend surface, and then just add some transparency to that just to make it look a little bit like a window. And then I'm going to select this surface and move it into place. And there we have windows that fit perfectly. In fact, I can just render that. You can see how that fits. So as you can see, I can use those curves to create both the openings for the windows and the windows themselves. And you can see the benefits of how to use the trim tool. Now we're going to look at another way to connect surfaces together in NURBS, and that's called the Fillet Blend tool. Now, I'm using a file here called, obviously enough, Fillet Blend, and it's in our 05 projects. And what this is it's just a real simple setup. I've got a sphere and a cylinder. And the cylinder, the end curve of that cylinder was extracted and projected onto that sphere. So essentially what I have is I have a curve on surface here, and that's matching my cylinder. Now these two don't have to match, but this actually will make a nice object here. So let me show you how this works. Now what I want to do is bridge these two with a surface that is seamless to both. I can do that using the Fillet Blend tool. So all I do is go Edit NURBS, Surface Fillet, Fillet Blend. Now this tool works a little bit differently than a lot of tools, and it actually prompts you through. If you go down to the bottom right, you'll see the prompts here. It says select curves for the left edge. Now I have to select the curves that are on that edge, okay? Select that, and I hit Enter. Then I select my curve on surface and hit Enter again. And bingo, there you go. Now what this has done is it's created a bridging surface, a fillet blend surface. In fact, we can take a look at this actual surface. It's actually a third surface. So we have our sphere, our cylinder, and then our derived surface, which is the fillet blend. If I go into my attribute editor, I can see my fillet blend surface node right here. And you have some controls here about where it starts and where it ends and that sort of thing, whether or not it anchors. And if it comes up backwards or it's kind of like twisted in half, you can reverse one side or the other. And you have some control here as to how it creates that surface. Now, the really cool thing is that the surface is dynamic. And so no matter what you do, that surface is always going to stay attached. Now, this is because I have history on this surface here that connects that circular curve on surface to the cylinder. Now, another thing you can do is you can actually use this to create flexible joints. So let me show you how to do that with this cylinder. I'm going to select the cylinder and duplicate it. So I'm going to go Control D to duplicate, and I'm just going to move that out beyond the cylinder there. In fact, I'm going to change the pivot point. So I'm going to hit Insert or Home, and then just move that pivot point here. And you'll see why we do this later. And then just Insert. Now, the most important thing is that I want to create a blend surface between these two openings. So all I have to do, again, is just go Fillet Blend tool, and then I select this, Enter, this, Enter. Now it's created a bridging surface that actually looks like I have one solid cylinder, but it's actually two cylinders. And so I can actually move this and create kind of like this elbow joint that's always connected and always flexible. So you can see a lot of possibilities for how you could use this in animation. Now, the one key with this is that when you select these surfaces, you have to be very careful about what you select. Let me do this one more time, and I'm actually going to do it wrong on purpose so you can see a common error that I see a lot of people do. One is that you actually, instead of selecting the forward edge, you select the perpendicular edge, and that will create all sorts of weird stuff. So you got to make sure that you select exactly the right edge. Now, another thing you can do is you can actually select multiple edges. So I could, for example, select this edge and one of these edges, as well as one of those, and I would still get an error. So be careful about that. You have to be very careful about what you select when you use this tool. But if you get it right, you can do a lot of really, really cool things. So now we're going to talk about another way to attach surfaces together, and this is called stitching. Now, this is actually very similar to stitching a garment together. Remember that a NURB surface is really just a flat patch. In fact, we have a file up here called stitch.mb, so just so you know. But remember that a NURB surface is just a flat patch. And in order to make a more complex surface, you need to be able to connect those edges together and essentially stitch them together. You could almost think of like how you would stitch together a shirt, where you would take flat pieces of cloth and then stitch them together to make more of a 3D type of garment. So there are three types of stitch options here in Maya. We have stitch surface points, stitch edges, and global stitch. So we're going to start with stitch surface points. Now I have layer 3 in this file highlighted, and that just simply has two planes. And what we can do is we can just stitch together the surface a point at a time. So what I need to do is select both of these and put them into control vertex mode. So I right click over the first one, go control vertex, right click over the second one, go control vertex. And now they're both in control vertex component mode. Now all I have to do is just select two of those points, and then I can go Edit NURBS, Stitch, Stitch Surface Points. And notice how that sticks those two together. So those 2 points are stitched. And if I move this surface, they're both stuck together, which is kind of nice. So let's go ahead and do another one. Control Vertex, make sure we're both on the same page for these, and then select these two, and then just go Stitch Surface Points. Now I've got these two connected. So now I've got almost like an edge that's connected as well. So that's the first way of doing it. Now you can see how that, if you're doing it a point at a time, it can get kind of tedious. And actually this is kind of more for like a touch-up kind of operation. Probably the more global way to stitch things together is by stitching edges together. Now I have just a couple of planes here, and we can actually stitch together the edges of the plane. This is in layer 2. So all I have to do is go Edit NURBS, Stitch, Stitch Edges. Now notice my cursor changes, and I select the first edge and then the second edge, and it stitches them together. Now I get a little zipper here, which allows me to control where the stitching starts on that second edge. Now how this works, I'm going to hit W and go into move mode. Now what this does is it actually stitches those edges together. Now what this does is it takes the second selected edge and just moves it to match the edge of the first object. So remember, I selected this one first and then the one facing us. So that way I move this one and that edge is always stuck to this one. So we can do the same thing over here. So all I have to do is go Stitch Edges, first edge, second edge, and they're stitched together. And I can just keep doing that. Stitch edges, 1, 2, and 1, 2. And that stitches them all together. Now, if I go into object mode here and move those around, you can see I've got all of these kind of stuck together, which is kind of nice. So now you've got kind of a continuous edge, so you don't have a box that breaks apart. Now the last way to do this, I'm going to go ahead and highlight layer 1, is by using what's called global stitch. Now this is probably the easiest way to do this. Now I've got actually an object that's fairly similar to what we were playing with before. I've got a sphere, two spheres with the tops cut off, and then a loft surface that goes between them. If I want to, I can connect these. Now, I had these connected before by extracting the curves from the surface to create the loft, but another way to do this is with a stitch. So I don't have to place these exactly perfectly. I can just kind of get them roughly aligned and just select all three, and then I can just go Edit NURBS, Stitch, Global Stitch. Now what that does is it just stitches together everything that's close. In fact, let me give you a look at the options for Global Stitch. It's very similar to Merge, which is it gives you a maximum separation, and so anything within that separation gets stitched together. You also have some options here whether you want to stitch corners, edges, types of smoothness, and so on. But the really cool thing is that it's all stitched together, and it all becomes basically almost the same as one surface. So you can take that top surface, move it, and you have a really nice connected surface. Now, this is great for things where you have non-square types of objects, like I've seen a lot of things like human faces or animals modeled out of flat NURBS patches and then just stitched together. So these are some of the options you have for stitching objects together. Another more advanced way of editing surfaces is by sculpting them. Maya has a very powerful sculpt tool for both polygonal and NURBS surfaces. So let me show you how this works. I'm going to go ahead and create a NURBS sphere, shade it. In fact, I'm going to turn off my grid here. Now I'm going to go over to my channel box where I have my sphere, and I'm going to ramp up the detail a lot. I really want a lot of detail here so I can have some stuff to paint on or to sculpt with. And then all I have to do is go to Edit NURBS, Sculpt Geometry Tool, and I want to make sure that I click this little box which brings up my paint interface. Now this interface probably looks a little familiar to you because it's what we use to do Paint Select, but this also has a number of additional tools. This interface is used a lot in Maya for all sorts of things that require painting, but sculpting is probably one of the more powerful ones. So let me show you how this works. You have a brush, and you can size this brush here. We can make it really big or really small, and again, holding down the B key and dragging will change that value as well. We also have radius and an opacity, which is kind of a strength value. And we also have a profile. Do we want this to be heavy at the center and then fade off, or whatever? We can make this any shape we want as well. Now, in addition to this, we have our sculpt parameters, which is, do we push the mesh? Do we pull the mesh? So, for example, if I want to push the mesh, I can certainly do that and make a dent. I can pull the mesh and pull it out. I can also smooth the mesh, which kind of just tempers it a little bit. I can also reorganize the detail. Now what this does is it kind of just makes things a little bit more rational in terms of just where the detail's going. And we also have what's called an eraser, which basically just puts this object back to the way it was. In fact, if I just erase everything, I can go back to my normal sphere. All of these tools work off of what's called a reference vector. Now, typically, this is the normal of the surface. Now, if you don't know what a normal of the surface is, it's really just the point on the surface that's always perpendicular to where you are. So, for example, if I'm on this side of the surface, the normals are going to point to the right. If I'm at the top, then the normals are going to point up. So it's always pointing away from the surface at a right angle. But I can also change this. So, for example, if I wanted to go around the X, Y, or Z axis, for example, if I'm sculpting on the Z axis, you'll see when I'm doing it at this angle, it's pushing. But if I'm at a 90-degree angle, it's actually just going to push it back to the side. So it's always pushing in that direction. Typically, I keep this on normal because that's probably the most rational way to do this. Now, I also have a feature here for how much is this displacing. So if I put it up high, I can pull out a lot of surface at once. Or if I make it low, then it's just gently tweaking it. And then I also have what's called a flood. And what the flood does is it just takes that value, whatever this value is, and it adds it. So essentially what it does is it makes my sphere a little bit bigger. So for example, if I flooded it with negative, it would actually make it a little bit smaller. Or if I flood erased it, it would just automatically go to 0. In addition to this, I also have what's called stroke parameters. Probably the most popular one is to use reflection. And what this does, you can see it right here, is it reflects around an axis, so I can actually sculpt symmetrically. Now I can reflect around X, Y, or Z. Now in this case, I'm going to do X. Here, let's go ahead up here, and I'm going to pull out the surface so you can see how I can create something that's very symmetrical. So for example, if I was modeling a character or something like that. In addition to this, we have stylus pressure. So you can actually tie this to the pressure of a stylus, which will give you a lot more fine control over how this tool works. Now, typically what I do is I don't really sculpt things from scratch using this tool, but what I do is I get my geometry roughly to where I want, and then I use the sculpt tool to kind of fine tune and tweak it. Now we've been working on a NURB surface here, but let me just show you very quickly how to do this with a polygonal surface. So I'm going to go ahead and delete this, and then I'm going to go to polygons and create a polygonal sphere. And then let's go ahead again and just ramp up that detail. And then when I'm in the polygons menu, you'll see I have mesh, sculpt geometry tool. It's the exact same tool. In fact, all of the parameters are remembered from the last time I used it, so you can see I can do the exact same thing to a polygonal surface as well. Another way to model in Maya is to actually use some animation tools. Now, Maya has a number of deformers that it can use to change a surface. Now, typically these are used for animation, but you can also use them as modeling tools. So let me show you how to use them. Start by creating a cylinder. I'm going to make this fairly tall so we have some room to work with. And then I'm going to click over here and I'm just going to give it some more subdivisions in height. And now let's open up the deformers. So I'm going to the animation menu set, create deformers, and there's ones here called non-linear. In fact, I'm going to tear off this menu. We have a couple: bend, flare, sine, and so on. And just move that over here. Let's just go through these. These are actually very self-explanatory. So all you have to do is select your object or faces or components within an object. Okay, it doesn't have to work on the entire object. This makes it a good modeling tool because you can actually put these deformers on parts of a model. But let's just use it for the whole model so you can see how it works. The first one is bend. And if you put that on there, you can see here an input comes up here which says bend. And it's very simple. In fact, you can even see it here in the attribute editor as well. We have a curvature and then also a high and a low bound. So for example, you could say, where does that curve start? Is it just at the top or is it all over? In fact, let me go ahead and undo out of here. So another way you can work with these, let's go ahead and reapply this bend, is by using what are called manipulators. Now over here on the left, you have this little icon here, and this brings up a manipulator, which allows you to actually manipulate how this works. So all I have to do is grab one of these handles. For example, this affects the curvature, and these two affect that upper and lower bounds. So I'm going to go ahead and undo out of that just to get back to normal. Now we also have other ones. We have flare. Now I've got my manipulators turned on, and you can see now what flare does is it basically flares the object. And you can also give it a curvature again. Let's see the parameters here. We have curve, we have start and end flare, and again, high and low bound. So these are some of those options. The next one is called sine, and that pretty much creates a sine wave. Squash. Squash is great because it does squash and stretch. So it keeps the volume of the object and then just squashes or stretches it. The next one is twist, which is actually pretty simple. In fact, let's go ahead and turn on wireframe on shaded so we can see that. And essentially what it does is it twists the object left or right. Now, you don't really see it on the cylinder, but another object, you'd definitely be able to see that. And the last one is called wave. We have amplitude and drop off, minimum, maximum position, and so on. In fact, if I want to, I can go to these manipulators here and change this. And what this is doing is it's actually creating a wave from left to right. So we actually don't see it here on this cylinder as much because of the way that the wave is going. But those are the basics of the nonlinear deformers. Now you can certainly use these as animation tools, but I find them very valuable as modeling tools as well. The next deformer I want to show you is called a lattice. But what a lattice does is it allows you to globally change and reshape an object. You can also use this in animation, but I find it to be a very powerful modeling tool as well. But because it's a deformer, we will find it in the animation menu set and under Create Deformers. Then go down to Lattice, and I'm going to select the tool options here. Now, in this case, I'm going to add some divisions here. I'm just going to make it 5, 5, and 5 so that I have enough detail to edit my model. And then I'm just going to go Create. Now, I've selected my model, and it puts a lattice around that model. Now, if I go to the outliner, you'll see that I actually have a separate object here called a lattice. And that lattice actually is a separate object that can be moved and rotated and whatever. Now, by moving this, I'm actually moving the lattice, not the head. But the lattice, because it's a separate object, it also has its own marking menu and its own types of components. A lattice really only has one component, and that's the points on the lattice. So if I select those, then I can use them to reshape whatever I want. So for example, if I want to make his head a little bit smaller, I could do that by taking down these corners. I could make him a low brow. I could make him a high brow. It looks like a troll there. And we could also take his nose, move it out, push it in, give him a little bit more of a chin here. All of this is just by moving these vertices. And you can move, rotate, and scale. It's just like modeling a cube or something like that. But of course, these have lattice points that are inside, where a cube would just be the shell. As you can see, we can actually do a lot of stuff with a lattice. Now, the other thing you can do with this is you could actually add a lattice. In fact, if I want to, I can just go ahead, edit, delete by type history, and that gets rid of my lattice. Now, if I wanted to do some more modifications, I can actually place this lattice on just a portion of the character. So if I right-click over this, select, for example, vertices, select just the nose, I can create a lattice that is just around the nose, or just around what I have selected. I seem to have selected a little bit more than just the nose, but you get the idea. And then I just go to lattice point, and now I can really fine-tune and tweak the nose of the character. And I'm sure you can see a lot of the benefits for doing things this way. Because what you can do is you can push a lot of detail around, especially if you have a high resolution model. It might be better to use a lattice than to actually try and model the surface itself. Now I want to show you how to move between NURBS and polygons. Now, we've been doing a lot of NURBS modeling, but you can actually take a NURBS surface and convert it to polygons. This gives you some of the benefits of the smooth surface modeling of NURBS, but you can also go down to polygons for your final output. Now, you can't go polygons to NURBS because polygons are actually a lower order surface. But I have this Deco car, and let's go ahead and convert some of these surfaces to NURBS. Let's go ahead and play with this fender. In fact, I'm just going to lift this fender up so we can see it. And then I'm going to go Modify, Convert NURBS to Polygons. Let's go ahead and see some of the options here. Now I'm just going to go with the defaults in Maya, which is Standard Fit and Quads, and just go Tessellate. And when that happens, what it does is it actually creates a second surface here called NURBS to Poly, and that tries to fit it exactly to that surface. Now, the thing you'll notice is that it's not a regular polygonal surface. As the surface gets more curved, it adds more polygons. This is good because what it does is it gives you the minimum number of polygons needed to create that surface, but it's not a surface that can be deformed. So if this is something just going to be a rigid object, it might be okay. But if you are going to animate it or do something like that, you may want a more regular polygonal surface with more regular edge loops. So I'm going to go ahead and delete this first conversion here, and I'm going to go ahead and select my lofted surface again. Now I'm going to go modify, convert NURBS to polygons, and this time we're going to change the way that it converts. In fact, there's a number of different ways to convert. First of all, the output can be either triangles or quads. So let's take a look at what triangles does. Triangles basically makes your surface into a triangular surface, which some people like, particularly for some certain types of game engines and that sort of thing. But let's go ahead and do this again. And I'm going to keep it at quads. We also have a tessellation method. One is called general. The other one's called count. Now, count just says, I want this to be no more than 200 polygons or whatever number you dial in. If I apply that, you can see that this actually reduces that to no more than 291 polygons, and it keeps it that way. If I make this a much larger number, you're going to get a more detailed mesh. Okay? Now, for general, this is actually the one that I tend to use the most, and this actually gives you how do you want this to create polygons per U and V direction, remember U and V direction, in the surface. So basically what I do is I do it per span. So basically in this case we're doing 3 per span, and what that does is it gives me 3 polygons per span of this surface. So that's a great way to dial in a nice surface that has edge loops that you can actually work with. I like that per span. It's the one that works the best for me for a lot of things that I do. But in addition to that, we can also do what's called control points. And what that does is, again, it just converts exactly what we have here to polygons as well. So it's a very simple one. Now with the general one, we also have what's called the secondary tessellation controls, which allow you to give additional tessellation here. So let's go ahead and do an apply on that. And that actually gives you a lot more detail. And also notice how it actually is adding detail when the surface gets more curved. So again, you're not getting a regular tessellation here when we're using this chord height. Now the last thing I want to show you, I'm just going to go ahead and move this back down, is that this does work on things like trim surfaces. So I have this window. I can also create NURBS to poly on this window. So I'm just going to go ahead and do a standard fit on this and just do tessellate. And now I have those windows are actually built in polygons. So there we have it. Okay, so those are some of the tools for moving between the different geometry types. So now we're going to start building this little robot here, and this is the completed version. And over the next couple of chapters, we're going to add parts to this robot as we go through the modeling exercises. Now, in order to model something in Maya, it's always a great idea to have reference. Let's say you're modeling a human, you might want photographic reference or a car or something like that. Or if it's something that you've designed, you may want hand-drawn or Illustrator-drawn reference. For this robot, I actually just did a simple pencil sketch. In fact, I'm just going to go ahead and open this and show you the sketch that I did. File, View Image, and then we go into our project, Source Images, and I have one here called Robot 00. Let's just take a look at that. So what I did was I drew an orthographic view of this robot. So I drew a exact front view and an exact side view. Now, if you're doing photography, you basically need to do the same thing, which is take an exact front version of your subject, an exact side version, maybe even a top version. And you want to take those with a very long lens so you have as minimal amount of perspective. So what I did was I brought this into Photoshop and I just made sure everything lined up. And then I'm just going to show you two more. I broke those in two. I broke it up into a front and a side view. Okay, so I have two separate images, one for front, one for side. And I just want to make sure that they're aligned and pretty much the same size. So I'm going to go ahead and close this. So in order to model against reference, we need to bring those images into Maya. There's actually two ways of doing it. I'm going to show you the first way. I'm just going to go File, New Scene. And the first way of doing it is to actually create what are called image planes in the viewports that we want. In this case, I have a front and a side view of the robot. So I'm going to start with the front view. I'm just going to go expand this viewport. And then on the view menu, I'm just going to go down to image plane. And then I'm going to import that image. So go image plane, import image. I go to my source images directory, which is where I have these particular ones stored. And I select robot front 00. And there it is. And if I go out to my viewports, you can see I've actually got this image already in Maya. And now I can do the same for the side view. View, image plane, import image, and in this case it's robot side 00, and there's my image. Now the real key here is you need to make sure that these images are the same size. So they're the same height in terms of number of pixels, so that way they pretty much line up when you come into Maya. Now this is one way of doing this. I actually like doing it a different way, so let me show you that as well. I'm going to get rid of these by going into my hypergraph connections. So what I'm going to do is I'm actually going to go into my camera views here, and I'm just going to go View, select Camera, and it brings it up, and I can just select that image plane and delete it if I want to. And the same for here, View, select Camera, and that brings up the camera, and then I just regraph that by hitting this button here, select the image plane, and delete it. Now what I like to do is I like to actually build these against real planes because it gives me a lot more flexibility in the way that I model. So let me show you how to do that. I'm still going to go into the front view, and now I'm just going to go and create a NURBS plane. So I'm going to go Surfaces, hit Plane, or I can go Create NURBS Primitives Plane. And then I'm just going to sketch out a NURBS plane, which is roughly the size of that image I created. Now, the reason I'm using a NURBS plane is because I'm actually going to model most of this in polygons. And so if I put the image on a NURBS plane, I can set my selection masks so that I don't accidentally select my NURBS object. It just makes it easier to have them as different types of geometry because then you can make it so you don't select one or the other. Now, once I have this, I still need to put, in fact, let's go ahead and shade this. I'm going to go into my perspective view and shade it. Now, here's the little trick. We're going to do a little bit of rendering stuff, but I just want to show you how to quickly add a texture to this. So I'm going to go to my rendering tab. And I can do this one of two ways. I can go to my rendering tab and add what's called a Lambert, which is a non-shiny material. Or I can right-click over here, assign new material, scroll up to Lambert. Now, the reason I'm choosing Lambert is because it doesn't reflect. It's non-shiny. So once I do that, it brings up my attribute editor for that material. And then I have to just basically put that image into the color channel. So I'm going to go ahead and into color, hit that little checkerboard there, and this brings up Create Render Node. Now, we're going to go through this a lot more when we actually go through rendering, but I'm just going to show you this very quickly. And so I want to make sure that this is clicked as normal, and then I'm just going to go ahead and load File, Image Name, and then Robot Front. A little bit of a procedure, but once you get it, then you can just turn on hardware texturing, and that robot image will be there. And so I can just scale this and make it about the right size, okay? Now I can do the same for the other robot. In fact, I can just take this one, duplicate it, so you can just go Edit, Duplicate, or hit Control D, and then rotate it. In fact, if I use my channel box, I could actually just rotate it exactly 90 degrees. So I can rotate around Y 90 degrees. Okay, so now I've got two planes at 90 degrees to each other. Then I select this second plane, and again, apply a Lambert texture. In fact, I'm just going to do it here from the rendering shelf. In the color channel, normal, file, and then select the file name, and this is going to be robot side 00. Now, this is a little bit more of a procedure, but you get a lot more flexibility with this. Watch what you can do. You can actually take these planes and you can scale them. You can move them around so that they're exactly aligned. It's harder to do with image planes. So I find this a much better way to create my roughs for modeling. Also, the other nice thing is that you actually can see this on both sides. In fact, one of the things I'm going to do is I'm going to go ahead and turn on the grid here and make sure that His feet are flat on the ground right there. So now that I have this, I can go ahead and start modeling. But before I do that, I'm actually going to start working with my layers a little bit. So I'm just going to go ahead and select both of these. And then I'm just going to go create new layer and right click, add selected objects. In fact, I'm going to go ahead and double click on this and just call this templates. So now I can turn these on and off very quickly when I'm modeling. If I want to see my templates, I can turn them on. If I don't, I can turn them off. Very simple. So those are the basics of how to set up your reference for modeling. So let's go ahead and start modeling. So now that we have our templates set up, let's go ahead and start modeling. And this is my robot. Now with this template, the first thing I want to do is set it so I don't accidentally select it. I can do this in one of two ways. The first is I can set a selection mask and just right click here and turn off NURB surfaces. That way I don't accidentally select it. But eventually I will be adding a few little NURB surfaces on this model, so that's not going to work for my whole process. So I'm actually going to turn that back on. I'm right clicking here. But actually I have this set up on a layer. So if I want to, I can click on this button here, and if I click on R, that means it's just reference, and I can't select it, but I can see it. So now I can model over this and not worry about accidentally selecting my template and moving it. Now let's go ahead and take a look at this from the front view. I'm going to turn on shading, and I'm going to turn on hardware texturing. And let's go ahead and zoom in a little bit. Now, one thing I'm noticing is that this is actually not centered. Here's the center line of my scene, and that's really off to the side of the nose of this character. So I'm actually going to turn off R here, select my NURB surfaces, and move them so that they are pretty much centered. I want to build my robot around the center line of the scene because that'll make him a lot easier to build. So once I do that, I can deselect and then just go ahead and switch that back to R. Now that we have this, we can actually start building the robot. Now I'm going to start with his body, and that's basically going to be a box or a cube, and I'm going to build most of him out of polygons. Some of this is going to be NURBS, but most of it will be polygons. So all I have to do is go to polygons and select cube. But the key here is that I really want to see what I'm drawing. So I'm going to do one more step before I do that. I'm going to turn on X-ray for this, and then just select my cube, drag it until it's the size of the body of the robot. Now I still need to drag to set the height, so I'm going to hit my space bar, go into my perspective view, and then drag this out. I don't really know exactly how deep this is because I'm actually dragging this out in the perspective view. And also, this starts at 0 and his back is actually behind 0. So I am just estimating it, and then I'm going to go ahead and position it. In fact, the best way to position this is in the side view, and we're still going to turn on smooth shade, hardware texturing, and then I'm going to turn on X-ray, and let's go ahead and position that. Now he's a little bit thin, so I can go into my polycube here, and I'm just going to center this in the drawing, and then I'm just going to go ahead and adjust my height until that's about the right size. Okay, now we still have a little bit more to go on this body because we do have these curved and beveled edges. Easiest way to do that is to simply bevel the edges. So I'm going to right-click above the box, select edge, and then I'm just going to select all the edges in my model. In fact, I'm going to turn on X-ray here as well so we can match it to the model. And then just go into my polygons menu, edit mesh, bevel. Now that bevels it at 45 degrees, but I've got my controls right here. So first thing I'm going to do is add a few segments, maybe 3, maybe 4. And then I'm going to select my offset, and again, I'm middle clicking and dragging so that I get a roundness that's about the same as what I have in the drawing. So I'm just going to estimate that, but that looks pretty good. Now we can do the same for the character's head. So I'm going back into my front view. I'm going to draw another cube right there. It's just slightly below the body so that it interpenetrates just a hair. Let's go into the side view here. Drag this forward, and I'm estimating. This is almost the exact same procedure. Hey, look, I was pretty close. Now with this, I actually want to bevel just the top and front edges but I don't want to bevel the bottom. I don't want to bevel that edge that's against the top of the body. So I'm simply going to right-click above here, select just the ones above here, mesh, bevel, and then again, I'm just going to add 3 segments and affect the offset here so that it's about right. Let's go ahead and turn on normal shading here. So now I have the body and the head. So now that we have the body blocked out, let's go ahead and do the arms and legs. Now I saved this out in a file called robot01.mb, so if you want to follow along, you can. Now I added one little thing to that file, and that's just 2 NURBS curves. And those actually allow me to make the legs. So we're going to start with the legs and the feet and then move on to the arms. So if I want to, I can just select both of these curves and go Surfaces, Loft, and that creates, in fact, let's go ahead and shade this. Let's go into hardware texturing there. That creates one of my legs. Now, if I want to, I can actually select that surface and just create another leg from that first leg. So I can create the mirror opposite of that leg. And probably the easiest way to do that is with Duplicate Special. Let me show you how this works. If I go to Duplicate Special and click on this box here, I have all sorts of options. Now, the option I want to show you is that I can scale as I duplicate. So if I want to, I can scale at -1 in the X direction, which is right down here. And when I do that, it actually takes my leg, duplicates it, and then adds a -1 to the scaling, which actually just mirrors it, which is exactly what I want. And that's how I make that second leg. Now let's go ahead and make the foot. Now the foot is easy to make. It's very similar to what we did with the body. We're just going to take a box and we're going to bevel it. Drag it out so that it's the size of the foot, and then drag to set the height. There we go. In the side view, I can certainly see this and move it, and I can also, again, affect the height of this so that it's about the right width. Now I can also just bevel that top edge just by going Edge, and then just, probably in my perspective viewport here, just select 1, 2, 3, 4 polygons, mesh, bevel. Okay, but of course I need to make my offset a little bit less, and then just add a few segments to round that off. So there's my foot. And then all I have to do is just select the foot itself, duplicate with Control D, and then just move that over here. Now, as I go, I probably should be naming these, but I'm just going to continue on right now so that we can see just the process. But typically I would be, as I create these, I would name them right and left foot and so on. Now for the arms, we probably should start with the shoulder there, which actually is kind of a box shape on this side. But if we look at it from this side, we see it's actually circular, more of a cylinder shape. So we're just going to take a default cylinder, and I'm going to drag that to make the rough outline of that arm. And then I need to again drag this out. So I'm going to go into wireframe mode so I can see this. Now when I drew it, it started at 0, which is inside the body of the robot. So I just need to drag that out. And again, I'm just going to estimate the width. I can always adjust that later. Let's turn on my shading here, and I can move this out to exactly the size I want. Now I can certainly change the size here by changing the height, so it's about the right width. Now the other thing is I just need to change the subdivisions in terms of height. So 1, 2 subdivisions. I've got a little bit of space here, a little bit of space here, and then the extrusion for the arm. So basically I want to be able to extrude that arm out. So this gives me the amount of detail I need to do that. So I'm just going to select these vertices and scale them. Now I have my detail in the right place to create that arm. Now all I have to do is select these faces underneath. In fact, let's go through here. To match what I have here. So I need these faces to be from here to about here. In fact, we can probably take a look at that in the side view here. In fact, if we turn on X-ray, we can kind of see how that works. So basically I want this to match this and this to match this. I need to take one of these away here. There we go. So that's what I'm going to extrude. So let's go ahead and do that. So I'm going to go Edit Mesh, Extrude, make sure we have Keep Faces Together on, and then I'm going to extrude this. Now the problem is that it's just extruding out according to what the normals of this are. So we need to kind of squish this back together. But I'm just going to extrude it at this point and then come back and fix it. I can do that by selecting these vertices, and the first thing I want to do is flatten them out. I can do that by scaling. Just scale them down so that they're flat, and then scale them together. Now I've got the sort of detail that I want. So sometimes when you extrude, it's not going to be exactly what you want, but you always can model it back in later. So now I'm just going to hit E for rotate, and rotate this around and move it so it's pretty much in how I want it. Maybe even scale it just a little bit. So there's my basic arm. Now if I want, I can also bevel those edges again. So let's just go in my edge here, select that one, hit the up arrow to give my edge loop, edit mesh, bevel, and then again just offset. So I can bevel that edge just a little bit. Same for this one. Bevel, and again fix my offset. So now I've got my top version of that. In fact, let's go ahead and see this in non-X-ray mode. So that's my top part of my arm. Now I just need to do the same for the lower part of the arm. I've already have the basic structure that I need. So all I have to do is just take this and duplicate it. So I'm just going to go ahead and do Control D, duplicate this part of the arm, and use it to make the lower part. Now this is a little bit bigger, but what I can do is I can certainly scale this down just a little bit. And then rotate it so that I have my second arm, and then select these vertices and again move them over. And maybe rotate them and so on and so forth. Now the only other issue that we have here, in fact let's go into object mode here. Now I can certainly move this over. Now the one thing is I do want to create kind of like a little notch for this top arm to fit into the bottom arm. And I can do that by just selecting some faces. So for example, these faces along here, and I can do another extrude. Just extrude those down. If I hit the blue one, I can extrude them down, and then I can scale them in just a little bit. So now I have kind of a notch for that other one to fit into. Go back to object mode and move that into place. Now there's still a little bit of fitting to go here. In fact, I can just make that a little bit wider, just like that. And there we go. So now that pretty much fits. So now I've got the arms and I've got the legs. Now all I have to do to create the other arm is select both of these and then just duplicate them and move them over. So let's go ahead and do some more robot modeling in the next lesson. So now we have our robot pretty much sketched out. I've got this saved to robot02.mb, and then I just added in 2 additional cylinders for the hand. Now let's work on the face of the robot. Let's take a look at what his face looks like. I'm going to go into the front viewport, and let's take a quick glance at that. And we have 3 things that we need to build. One is these eyes. And the other one is this kind of nose brow shape. And then we also have this grill for the mouth. Well, the eyes are basically just spheres, so we can knock those out very quickly. All I have to do is just create a sphere, and that's it. Just make sure it's the same size. And then just go ahead and move that so it's right at the front of that body. And then just duplicate it. And there we've got my eyes. Now let's work on this mouth, which is kind of a grill shape. We can start by creating a box, and then we need to have enough detail in here to create each one of these little details. Now these are divots or indentations in this grill. So we can start with a box. So I'm going to draw a box that's pretty much the same width. Go into my side viewport and drag out that box so I have a little bit of depth, and then just move that up to the front of his face. Now with this box, I still need enough detail to be able to extrude in each one of these divots. So I need a series of edge loops on either side of these. Now I can do this in a number of ways. One is I can do insert edge loops, but that's going to get a little tedious and I might not be as accurate as I want to be. Probably the easier way is to just use my subdivisions. So for example, for my subdivisions in depth, if I put that at 3, I know I'll have enough detail for the top, the middle, and the bottom. Then I also need to change my subdivisions width to a number that allows me to create 6 of these. Now I know from experience that that number is actually going to be 13. So I have 1, 2, 3, 4, 5, 6 places to create those divots. Now all I have to do is position my top and bottom vertices right here and here to border that. And again, this is just a little rough. This drawing isn't exactly accurate. And now that I have that, I can just do an extrude. So I'm going to go into my perspective viewport. In fact, I'm going to turn off my templates here, so that way I can see this a little bit better. And then I'm going to go into face mode. I'm going to select this face, every alternate face, right like that, and then just do an extrude. I'm going to extrude just a little bit, and then extrude again a little bit more, because what I really want to do is create an edge. Remember how smoothing works? I'm actually going to smooth this. So we're going to create a little bit of an edge. In fact, if you want, you can see how this works just by hitting the number 3. And that gives us a good idea as to how this will smooth. Now, if I want, I can also position this. It looks like it was a little high. There we go. Now, the next one is going to be his little nose, his little brow. So I'm going to turn on my template again. And what I need here is these, again, are divots, but these are hemispherical divots. They're made out of spheres. So I'm actually going to have to use a Boolean to create these. But first, I need the rough shape. Well, this is going to be done using a box. So I'm just going to go ahead and create a simple box. And again, just the same procedure here. I'm going to drag this out, move this out to the front here. And I also need this T shape. So I can do that by just adding 2 subdivisions in width, scaling these in, and then selecting this face on the bottom and extruding it out. I'm probably going to have to do this in perspective view. So select that little face there, and then just do recent commands, extrude, and extrude that out. And turn on my template. Hey, I was pretty close. Okay, so now I need to create a number of spheres to cut out my Boolean. Okay, so I've got the template here. I've got the thing I'm going to cut. Now I need the things that will actually cut this. So I'm going to create some polygonal spheres. I'm actually going to create one. And move that out. Now what I need to do is figure out how deep this needs to go in order to create that sort of hemispherical divot. So I kind of need to position this in front of it so that it makes the divot, but the divot's just big enough. Now once I get one, I need to duplicate these. Now I can do that in a number of ways. I can just hit Control D and move it. That might be the easiest way to do it. I could also use Duplicate Special, which would allow me to position them precisely, because what Duplicate Special does is allows me to do a number of copies with a translation per copy. But this is small enough so I can just copy all of these, and I should be pretty close here. So now that I have all of these cutters, these are essentially going to cut out the little holes for this nose bridge. There's 11 of these. Now I don't want to have to do 11 Booleans, so the easiest thing to do is just select them all, select all the spheres, go Mesh, Combine, and that combines them into one sphere. In fact, I can do Modify, Center Pivot, and now I can basically move those in and out as one. So now I select my T shape, then I select my spheres, and I do Mesh, Booleans, Difference. And there we go. It's cut the little holes there. And that looks pretty cool. Okay, so that's the basics of his face. So let's go ahead and move on to some other cool stuff. So now let's keep working on our robot. In this lesson, we're going to build the front parts of this robot. So let me go ahead and turn on these templates and show you what we're going to work on. We're going to work on this little shield here and the dial. Now, I've done a few things with this robot. One is that I've organized stuff into layers. So I've created a templates layer, a robot layer, which is all the geometry, and then a layer for curves. Now, I've already pre-drawn some curves here, so we don't have to go through that process. And we're going to use those curves to create this front shield. Okay, so we've got this shield here, which has kind of a round button here with this center part and then another round button on the side. And then the dial is pretty much self-explanatory. And what I've done is I've just traced that outline as best I could with the curves. Now let me show you how I created this shield. Okay, so I'm going to actually turn off the templates for right now. And let's just take a look at these curves. This first curve here, that's just for that button. So it's just the outline of that. And then these curves create the ridged shield. Okay, so in order to do this most effectively, I like to start with one curve, and in this case, I drew this curve here. And if I go into control vertices, you can see that this is actually made up of a number of CVs. I could have actually drawn this curve with probably just 4 CVs and it would be just fine. But the reason I drew it with multiple curves is so that I could do this sort of detail here. So I can take that one curve and just reshape it. So if you can see it from here from the top, let me turn on hulls here. So when you can see it from the top, you see I've got this sawtooth arrangement, and that gives it kind of that ripply effect. So I've duplicated this curve here, and then I also have one curve on each side of that base to kind of give it a nice flow. So in order to create this, it's very simple. All I have to do is just go from top to bottom and just select all of these curves. And we've done this before, surfaces, loft. And now you can kind of see this. So you can kind of see how we get that nice ripple effect here. Now for the side one, for this little button, we're going to do a revolve. In fact, let's take a look at this with the template behind it. We're actually going to do a revolve to make that detail. So let's go back into our perspective view. And in order to do a revolve, I do need to have that pivot centered at the center of the revolve. So I'm just going to hit the W key just to see where that pivot is set. And it looks like it's set in the right place. So let's go ahead and go surfaces, revolve. But before we do that, we need to make sure we're revolving around the proper axis. And in this case, it's the blue axis, which is the Z axis. So go ahead and do the revolve. And there's that detail. Now I still have to create a couple more things. First of all, I need to create the opposite button here. So I need to create this side. Well, because I've created this surface from a revolve, its center is actually at 0, 0, 0. I can use that to work with duplicate special to actually create an exact mirror. So all I have to do is go duplicate special, put -1 into scale. Watch what this does. Bam. There we go. So now I've got an exact opposite of that. Now all we need is a fillet blend that connects these 3 surfaces. So let's go ahead and do that for one side and then the other. So I'm going to go ahead and turn off my templates. And then I'm going to select my lofted surface, right-click, isoparm, select the isoparm at the very end, duplicate surface curves. If I go into my outliner, you'll see all the way down here, I have this duplicated curve. Now I can also select my revolved surface and then just go into the side viewport. I don't have to maximize it. I just have to make sure that that's the active viewport. And then just go edit NURBS, project curve on surface. And so now that curve is on the surface there. And I can use these now to create the fillet blend. So I go edit NURBS, surface fillet, fillet blend, select the end isoparm of the loft, hit enter, select this curve on surface, hit enter. Now this is actually flipped around, but I can change that by just keeping this fillet blend surface selected and going into my attribute editor. Now I can basically reverse this, but actually I have to reverse two things. I have to turn off auto normal, and then I have to flip and reverse one of these sides. And then that just makes it perfect. So let's go ahead and do this for the other side as well. So let's go ahead and go isoparm, select this, duplicate surface curves, go into the side view, make sure that's active. It has a little blue line around it when it's active. Project curve on surface, and then go back in my perspective, fillet blend tool, select that, hit enter, select that curve, hit enter. And this one actually didn't need to be reversed. So there we go. So there's the shield. Now let's very quickly do the dial. Now the dial is built from two curves that were actually how I drew this. Let me just go very quickly through how I drew it. Because I wanted this to be symmetrical, so I actually drew half of the curve, flipped it, and then merged the two curves together to make sure they're exactly symmetrical. But for this, all we really need to know is that these curves exist. So let's go ahead and select both of these. Now these have to be exactly on the same plane. You cannot have this at any angle here. And then just go surfaces planar. That makes the original face. And if I want, I can turn off selection for NURB surfaces so I'm not constantly selecting this surface. So I can select just the curves. So if I select both of these curves, duplicate them with Control D, and move them back, in fact, I can turn on my robot here so that I make sure that these are right on or just slightly behind the surface of that robot. And I can use that to make the sides of this dial. So let's go ahead on the inside surface. So I select the inside one on both of these and just do a loft. Now for the outside one, I want a little bit of a bevel. So actually what I'm going to do is I'm going to take this end one and I'm going to scale it up just a little bit like that. So that's actually a little bit outside of that dial. Duplicate it again and move it here. So that way I'm getting kind of almost like a little bit of a bevel. In fact, I can just duplicate it one more time and then scale that third one down just a little bit. So now all I have to do is select all four of these and then just go loft. You see I've got a little bit of a bump there. So all I have to do is select that curve and just adjust it so that I've got something that's pretty close. There we go. Beautiful. Now this dial, I'm going to move this forward here so we can just see it. And that would be just a planar. So all we have to do is go surfaces, planar. And then what I do is I always center the pivot there. In fact, I'm going to go ahead and move the pivot so it's right down there. I'm going to hit insert or home, insert again, and just move the surface itself in there. So now when I turn on the robot, so I dial back a little bit. I've got my dial, I've got my shield, and I'm getting very close to where I need to be. Now we're going to make the rest of the stuff on the robot. I'm working with a file called robot04.mb, and I just rearranged that file a little bit and just put everything in the proper place. But we still have a templates and a robot layer. Now, I'm going to work first on this side, basically his ear. The drawing really isn't exactly the shape that I want, so I'm just going to freehand this, and I'll show you a really cool way to make like a knobby shape, which is basically what his ear is supposed to be. So I'm going to start with a cylinder, and I'm going to start in my side viewport and basically center that cylinder over his ear, and then go ahead into a front viewport and drag that up. Then I need to position that over where his head would be. In fact, I should turn on the robot layer here. And then I'm going to go into my inputs here for my cylinder. First of all, I'm going to change the height. So I select the height, right click and drag, and move that so that the height is where I want it to be, somewhere around there. And then I'm going to give it one subdivision in height, and then one subdivision for the caps. Now, the most important thing here is the number of subdivisions around the axis, which is this number here. I'm going to be changing this. Now, the way I'm going to draw this knob is I'm going to do every third vertex, I'm going to smoosh it in so that it makes kind of a knob shape. So that means I have to have this in multiples of 3. So in this case, I'm going to make it 18 subdivisions in the axis. And you'll see why this is important right now when I start modeling this. So I'm going to right-click over this, select vertex, and then I'm going to select the top one. I'm going to skip 2, 1, 2, shift select the third one, again, 1, 2, 3. Every third axis here, I'm selecting. This is why I had it as 18, which is a multiple of 6, so that way I can get 6 of these selections. Now, when I hit R and scale this in, you can see how I can get a nice little knobby shape. So this is almost like a knurled type of knob. Now, when I scale these in, I'm using the master scale here, and what that does from the side, in fact, let's take a look at this from the side, is it also scales it. So it's basically I'm scaling it this way. So I do want those indentations along the top, but the bottom I don't want it to be so knurled, so I can either move those in, or the better way to do it is just to select these vertices here. In fact, we could probably do this better in wireframe, is if I just rubber band select, I can very narrowly grab those and just move those back. So now I have this kind of knurled knob shape. Now I also want to make kind of a divot in the center of this. This is why I put more than one subdivisions on the caps as well. So I'm going to select faces. In fact, I'm going to use paint select, right click, make sure I'm on faces, and I'm just going to paint out those particular faces. And then I'm going to go to extrude, and I'm going to extrude those in a bit, then scale, and then I'm going to extrude again. And one more time, scale it in a little bit more to kind of make more of a bump on the top. And then if I want, I can select this middle vertex here, right in the center, and pull that out just a little bit. So I can get kind of almost a curve here. Now when I go to object mode, you can see this will work pretty well. In fact, if I hit the number 3 to subdivide it, you can see exactly how this will subdivide. That's kind of nice. Now, if I want to, I can force the subdivision on this and just bake it in by doing a mesh smooth. In fact, let's go ahead and do that. Let's just do mesh smooth, and that automatically smooths that. And then I just need to move that in. And then in order to make the other one, all I have to do is duplicate it and then flip it around. And I flip it around by scaling. In this case, scaling over -1, and then just bringing it in. So there's his ears. Now let's just make the top of his head, and we'll be done. So if we look at the template, the top of his head is basically a dome with a ring, or I like using a tube or a torus around that. So let's just go ahead and freehand this. I'm going to actually go, in this case, into the top view. You can see here, this is the top of his head. In this case, I'm actually going to create a torus. It's about the size of the top of his head. And that'll be like the rubber gasket that contains, so I need to move that up. And then I need to center that as much as I can. And then make a sphere. In fact, in this case, I'm actually going to make a NURBS sphere. That's about the same diameter. And again, just move that up. Now for the sphere, actually, I want to cut that sphere in half and kind of squash it. I can do it one of two ways. I can either just clip it with the isoparm like we've done before, or I can just unfold it. I think probably the easiest way to do this is under NURBS sphere, just sweep it 180 degrees. But that sweeps it in the wrong direction, so all I have to do is just rotate that 90 degrees. And then just scale that down a little bit. There we go. Perfect. Okay, so there's the basics of our robot. Looks pretty cool, huh? So that's the basics of modeling the robot. We're obviously going to texture and render the robot in the subsequent lessons. Now we're going to talk about materials and textures in Maya. And the best way to look at materials and textures is as a coat of paint on the model that you've created. So for example, this deco car that we've created, in fact, let's go ahead to our project. Let's make sure we have that set. We're actually in 06 textures, and the file is called decocar.mb. Now I've stripped this of all of its textures, and this is basically how it will be when you first model it, which is kind of just this gray tone. Now, if you think about it, if you built this out of clay, it would also be kind of a similar grayish kind of non-colored tone. And we can add color by adding materials, and then we can add texture within those materials. So first of all, let's go through the basics of these materials. All of this rendering stuff, materials and textures, is in the rendering menu set. There's also a rendering shelf here, and I tend to use the rendering shelf a lot. But in order to create a color on this, let's go ahead and just select the body. We can apply what's called a material. So we do assign new material, and we can give it any one of these materials. Now, some of these, especially these ones in the lower section, are ones that are only available to Mental Ray. Okay, so if you're using these textures, like for example, there's one here called Car Paint, which would be perfect for this, but those are specifically for the Mental Ray renderer. They won't render that well with the Maya software renderer. So let me go through some of the basics here. We've got a Blinn, Lambert, Phong, Phong-E, and anisotropic. Okay, those are the main shaders that we use, and those are the same as you'd use in most 3D packages. Now let me show you the other ways of getting to these main shaders here. If we go to our rendering shelf, we have a bunch of little shader balls here, and those are your anisotropic, Blinn, Lambert, Phong, and Phong-E. We can also select an object, right-click over it, and go all the way down here, and we have assign new material. You can get right to that menu here and go anisotropic, Blinn, and so on, any one of these shaders. Now, the most common shader I like to use is called a Blinn. So let me just show you that. I'm going to select my surface and then hit this button. Now, when I do that, it brings up the parameters for the Blinn material. Now, this material is applied to the object itself. So if I click off of this and click back on, you'll notice that these are all of the operations I used to create this car body. If you go to scroll to the very end, you'll see we have a Blinn shader here. So these are all the different operations. This is basically my object history, and there's my Blinn shader. Now, the shader allows you to assign a number of parameters. Now, the types of parameters depends upon the shader. A Blinn is a really good example. So we can see here we've got some of the main parameters here, which are color. So all I have to do to change color is just click right here, and I have a color picker. And I can just choose whatever color I want. Now, the color picker can go in hue, saturation, or RGB, and the RGB can go 0 to 1 or 0 to 255, and that just depends on if you want to match to Photoshop or some other program that uses a different color model. So you can basically select whatever color you want and hit accept, and that color will go into this slot. We can also do stuff like transparency. So for example, these windows, if you select them by default, they have the default texture on them, which is called Lambert 1. Now, Lambert 1 is always applied to whatever object you create. So I would not mess with this, and you want to keep it gray so you know it's just a standard Lambert material. But for something like the window, we want to apply a new material. So we want to apply something like glass. Probably one of the better ones that look like glass is called Phong E. So let's go up here and apply Phong E. Now what Phong E does is, again, it allows you to do color. And in this case, because it's a window, we want to do some transparency. So we can actually play with the transparency of this. So you can see it's almost looking like a window already. But we also have some additional parameters. Now, these are the same for a lot of the shaders. We have what's called ambient color. Now, some of this won't show in the viewport. Some of this will only show here in the material sample. So take a look here when I go ambient color. In fact, here, let me turn this down. What the ambient color does is it's almost like a self-illumination parameter. We also have incandescence. So ambient color allows it to illuminate but also have highlights, where incandescence kind of blows out the highlights. We also have bump mapping. We also have diffuse, which is the shadowed side of the object. In addition, we have what's called translucence, which is kind of almost like a back glow with a depth and a focus. Now, the real difference between all of the main shaders is in how it handles specularity. So let me go ahead and turn this up and give it a little bit of transparency there. So we've got that. So the big difference between these is how it handles what's called specular shading, which is this highlight. So if I want, I can give it a roughness, I can give it a highlight size. In fact, let's go ahead and make it less transparent there. So I can change my highlight size. I can change how white this is. I can also change the color of the specularity. In addition to that, I can change reflectivity. So if I actually want this to reflect like a mirror, I can turn this from 0 to 1 to make it reflective. Now, one thing I want to show you is that each one of these has a different specular model. That's the main difference between the different shaders. So let's go ahead and scroll up here. And if we want to, we could actually change the type of shader here. Instead of actually having to apply a new shader, I can just select my object, find my shader, and change it. So for example, if I want to do a blend, and if you scroll down here, notice that the specular parameters are different. So it has different specular shading, specular roll-off, color, and so on. Now, a Lambert actually has no specularity. It's kind of a matte material. It's great for rubber or cloth or things that aren't shiny. Then we have Phong and Phong E. Now, Phong has what's called cosine power, which determines the shape of that specular highlight, in addition to a specular color. And then Phong E, which is what we just used, it has what's called a highlight size and whiteness. So it's a little bit different than Phong. So let's go ahead and turn up the transparency there. Now, all of these are just simulated here in the viewport. The way to really see these is to render them. Now, we're not getting into hardcore rendering just yet, but let me show you some basics about rendering here. So if we go to this button, that brings up the render globals, and we can determine what renderer we use. And then if we're using the Maya software renderer, we can also change our quality. Now, typically I use production quality, but we could also use preview quality if you don't want the renders to take too long. But let's go ahead and turn on production quality, close this, and then I'll just hit this button to do a quick render. And so we can see how that works. Now, for example, this body, maybe we want this to be a little bit shinier. So I can select this, go to my material, and then just play with my specularity here and just maybe make it a little bit more shiny, a little bit brighter. And again, we can play with this. So those are the basics of how to apply and adjust materials in Maya. Let's go ahead a little bit deeper into these windows in the next lesson. In the last lesson, we looked at how to create materials and apply color. But the color of a material can also be derived from what's called a texture. So let me show you a little bit about that. Let's just create a simple surface. I'm going to create a NURBS sphere, and I'm going to shade it here. And I'm going to turn on hardware texturing. Now let's go ahead and apply a new material to this. Let's just create a material. So I'm going to go to my rendering tab, and I'm just going to apply a blend material. And that brings up the blend attribute. And I can certainly do stuff like change the color if I want to. Very simple. But this color here is just solid. This particular box has just a solid color. If I go over to the right, you'll see that on all of these, there's another box that's checkered. And that means that you can insert an image or a procedural texture into that to create a non-solid color. So let's go ahead and click on this, and what comes up is called the Render Node or Create Render Node window. Now this has a number of different options, but let's just look at what the default is when you click on this button. It comes right into what are called 2D textures, and it gives you three options. The one we're going to play with right now is called Normal, but we also have one called as Projection, which we'll describe later, and as Stencil. But Normal is mostly what you want to do, so make sure that that is checked. Then it gives us a list of all the different types of textures that we can apply. For the 2D textures, these basically are the same as like a bitmap or something like that. So we could, for example, select any one of these. I'm going to select this one called Cloth, and there we go. You can now see how the cloth texture is applied to the color channel of the material. Here's the cloth attributes. Now we can certainly play with this. We can give it all sorts of color if we want, U and V color, which means just the different types of threads here. And we can also change stuff like width, and you can play with this all you want. But we're not going to get into that right now. I just wanted to use this as an example. The real key here is that this map is providing the color for that channel. And the way you navigate this is through these up and down buttons here. So if I go up, that means I go up to the channel that is using this node. So in this case, it's the color channel or in the shader. So if I click the up arrow, it brings me to this blend shader. And you can see now that this has changed. The color attribute actually has the down arrow, which is the same as this, which connects it to the cloth texture. So if I click this, I go back to cloth. I click this, I go back up to the thing that's referencing this. And I also have a little tab here for the cloths as well, so I can just switch between them here. Sometimes this isn't available, but you can always get to them with the up and the down arrows. Now I can map a lot more than just color. I can map transparency, I can map incandescence, specularity, anything I want with one of these little checkers, I can map. So let's go ahead and map transparency and see how that works. So again, I'm going to click here, and now we're going to select something else. Let's go ahead and select the checkerboard, and that'll be my transparency. So if I go up here, you see that it's not really showing. But if I turn on high quality rendering, you can see now that this is actually using the checkerboard as the transparency. In fact, if I go to blend on this object and go down to transparency, you can see I can actually even change the colors here. So black is solid and white is transparent. So I can actually play with that in real time if I want. And if I go up, you can see now I have two channels that are mapped. So those are the basics of how to put maps into an image. We just saw how to apply basic procedural texture maps, which are ones that you can actually create within Maya. But you can also use image maps or bitmaps to create textures as well. And that's probably one of the more common ways of creating textures within Maya. I'm going to open up Photoshop for just a second here. I have a file here with just kind of a rusty sort of texture, kind of grimy, rusty texture. And let's go ahead and apply this to the robot first. So I'm going to select his body, and we're going to apply a new material. In this case, I'm just going to apply a blend. And then in the color channel, I'm going to select this, make sure it's set at normal. And then in order to bring in an image file, we can do it a number of ways. We have File, which brings in a standard flat image file, such as a JPEG or a TIFF or a Targa. We can bring in movies, which are like a Targa sequence or something like that. We can also bring in Photoshop files, and the Photoshop node actually recognizes layers within Photoshop. But let's just go ahead and play with a simple JPEG. So I'm going to go ahead and select File. And what this does is it brings us into a whole new node. Now notice how the texture changes, and the texture sample goes to black. What we have to do here is select the actual image. So I select the File node, then I put the image into that node. Now, if we set our project correctly, we should be in 06 texture source images, and there's a file there called rusty.jpg, and that brings it up. Now, if this isn't showing up, make sure you turn on hardware texturing. Now, once that's in, you pretty much see it pop up on the robot. Now, we've got a couple of options here. Well, first of all, I want to show you how this connects to that blend shader. Again, let's just go ahead and press the up arrow here, and you can see that it's connected here to the color channel. In fact, one of the things I like to do is as I create shaders, I like to name them. So in this case, let's just call this Rust. Now, if I want to go back to that image map, I just click here and I go back to my file. Now, we've got a couple of options here. One is the ability to filter this for rendering. I usually leave it on quadratic. We can also change or reload the image. We also have some effects down here. So you can actually change the color. One of the more important ones is color gain. So you can actually have a brightness control here with color gain and color offset. That allows you to kind of tweak the texture in terms of how bright it is. You can also change the alpha channel if you want. You can also invert it here, and if you actually want to remap the colors, you can actually use a second image map or texture to do that. Now, in addition, we have what's called the Place 2D Texture node, and this shows how this particular texture is applied to the object. So again, let's see, we've got a File node here, and then we've got the Place 2D Texture node. Now, what this does is it basically controls the mapping and how much this repeats. So for example, if I go repeat UV and I put in a much higher number, like for example 6, you'll see that it's tiling much more closely. Now this particular texture is set to tile, so if I do an additional repeat on my UV coordinates there, you're not going to see the seams between the textures where they repeat. Now we also have an option here for coverage. Now what that means is how much of that bitmap is shown. So if you have a coverage of less than 1, then part of the bitmap is shown. You can see there's a dark thing here. Now this is actually for the entire thing. It goes UV and then coverage. So how much is this UV covering? If we go 1, it covers the whole object. If we go higher than 1, let's say we go 2, you'll see again it starts repeating. So this is another way to repeat this more, is just to give it more coverage, and that will increase again the number of repeats if that's the way you want to do it. So now that I have this repeated 8 times, let's go up to the texture sample so we can actually see it, and you can see exactly how many times this is tiling. So those are some of the basics of how to apply files into an image channel. Now, when you work with materials, we can certainly edit our materials in the attribute editor, which is one way to do it. For example, I've got this robot here called robotfinal.mb, and we can certainly manipulate the textures and stuff within the attribute editor. But we also want to have a better global view over all the textures in the scene. Now, the textures are not attached to specific objects. The textures actually live separately in Maya, and then they're painted on. So it's almost like you're having separate buckets of paint. We can view all of the materials in a scene by going into Window, Rendering Editors, Hypershade. And that brings up what's called the Hypershade window. Now this contains a list of all the different materials that are currently used in the scene. So, for example, this robot, he has his eyes made of this red texture. He's got a color for his body, and so on and so forth. Now, each of these I can apply to any object I want. So, for example, if I actually created a new object in the scene, I could simply apply an existing texture to that. Either I right-click, go apply existing material, or I can go into my Hypershade window and select one, right click and just go assign material to selection. And so that assigns that particular material. All I have to do is select it, assign material. In addition to this, the Hypershade window allows you to actually manage all of these materials and do a lot of other things as well. You could actually create a new material here that's not attached to any specific object. All you have to do is just go create Maya nodes, and for example, I could create a new Phong shader right here, and that would show up here, Phong 9. And if I double click on any shader, it brings up the attribute editor for that particular shader. So for example, this Phong, I could change it to any color I want. And then once I have the shader that I like, I could select an object here and just assign it. I'm going to undo that. Now, in addition, we can see how a shader is built by graphing it in this work area. So for example, if I selected this dial material, which is the actual, let me zoom in here. This is actually the texture here on the dial that says volts. I could just right click and go graph network. Now what this does is it actually shows me how the network is constructed. So we have a material called dial case, and the color is coming from a node called file 6, and that texture is controlled by this place 2D texture for number 6. So you can see how this is completely graphed out, and we can actually visually understand how our shader is built. Now, as you get working into more complex shaders, you can also have many, many nodes going into the shaders. You could actually have very complex networks. Now, this window also has a number of different options. We can certainly import textures from other Maya scenes. We can do some editing functions here, such as delete. One of the nice ones is delete unused nodes, which kind of just cleans up anything that's not attached. So for example, if I did that, it would get rid of that Phong that I added in. We could also delete what are called duplicate shading networks, which again just cleans up the window. Now we could also select objects with the materials applied. So for example, if I have this material applied, and let me move this over here. So if I want to, I could select objects with those materials applied. If I do that, it selects the objects containing that material. In addition, this work area can be navigated just like a viewport. So you hold down your Alt key and then use your middle and right click to zoom and pan. Obviously, because it's a 2D viewport, you can't rotate. Now, in addition to this, we have a number of other options here. We have Create, which allows you to create any sort of material. This is basically just a master create menu here. You can also create tabs to organize things. You can obviously change the way you graph your connections. And we also have some additional options and help for this window. Now this here controls how big these shader balls go. And then in addition, we have all of these tabs along the top. So these are the materials. But we also can look at textures, which is every texture file that we have. In this case, we have a lot of image files. We also have utilities, which are the place textures. And we also have lights and cameras, as well as what are called shading groups, and so on. So this is kind of a central place for organizing a lot of your rendering tasks. It's not only for creating materials, but also lights, cameras, and a lot of other things. Another way to look at the materials and textures in Maya is using the multi-lister window. Now this is actually a fairly simple window. It's here under Window, Rendering Editors, Multi-Lister. And when I bring this up, it's kind of like the Hypershade window, but it has a little bit different layout. It has some tabs along the top for General, Materials, Lights, and Cameras, but it doesn't have all the other tabs that the Hypershade window has. And along the bottom, it has a separate Textures tab, which I find kind of handy. You can select any texture and double-click on it to get the attribute editor for that. And I can also do that in this window as well. Now, this window is actually fairly simple. You can certainly right-click over this, and we have a number of options. Import, if you want to import. You can also assign this to a selected object. You can also delete any ones that are highlighted or unused. We can also select anything that is using that assigned material. So for example, if I right click here, again, this is just very similar to what's in the Hypershade window. You can also change your display a little bit. So you can actually do an alphabetic display, which is kind of nice. And you can also do small, medium, and large if you want. And there's a number of menu options along here, most of which mimic those right-click windows. One of the nice ones is called filter. Now, if you have a scene with a lot of materials in it, the filter can come in very handy. So for example, if I have these objects selected, I could show only the materials applicable to the selected object. So that will reduce the amount of clutter that I have on the screen. And it will show me exactly what materials are used for what object. So if I just selected one object, I could go show selected, it would be that. If I do this one, show selected, and so on. So those are some of the basics of the multi-lister. I tend to use this when I want to work quickly with just assigning and editing materials. And then if I want to get deeper, I go into the Hypershade window. So now that we know how to create materials and put textures in the materials, we also have to understand how those textures map to specific objects. Now, how you map a texture to an object depends a lot upon the type of geometry that we have for the object. Now, we're going to go ahead and start with NURBS-based geometry. And I've opened up this decocar.mb. So I'm just going to go ahead, and one of the things I'm going to do is just select this body and go display hide, because I really want to look at this undercarriage. Now, when we apply a texture to a NURBS surface, the texture is usually a rectangular bitmap or a texture. So for example, here I have this rust texture that we've been playing with, and I can select the car, and let's go ahead and create a material for that. I can just go to my rendering tab, select one of these. I'm going to select a blend. It's really not important which one we select. And then in the color channel, I'm going to just add a render node. Make sure this is set to normal. And we're going to do File, and I'm going to load up Rusty. I'm going to make a Rusty car. Now, you're not going to see this until you turn on hardware texturing. Now, once I do, you see that rust is applied to the fender. Now, let me show you how this maps. On a NURBS surface, you have basically a flat patch. In fact, let me show you this on a NURBS plane. I'm going to go ahead and just draw a NURBS plane and then right-click over it and go Assign Existing Material, Blend 1. So this is my image map. In fact, it's the exact same image map I have here in Photoshop. So this image maps corner to corner on the four-sided NURBS patch. And if I deform the patch, the texture sticks, because it's really just mapping the X and Y coordinates of the bitmap, or the width and height coordinates of the bitmap, to the U and V coordinates of the patch. Now, it's exactly the same for this fender of the car. We have a corner and a corner here, and the surface does have a U and a V direction. Now, it's just shaped a little bit differently, but the underlying geometry is basically the same. You could even imagine this being stamped out of a single sheet of metal. So what we can do is take this bitmap and we can change how it's placed onto the object. So all I have to do is double click on my object, go to the blend node, go to color, and then I find this place 2D texture node here. Now, we've played with this a little bit. We can certainly repeat if we want, but the most important one is coverage, particularly for a NURBS surface, because right now we're mapping the height and width of this image 1-to-1 to the U and V coordinates of this object. So if I take the coverage and change it, let's say I want the coverage to be 0.5, then it shrinks the texture. And the same here. If I make it, say, for example, 0.4, it's going to shrink it this way. So it's only going to cover 40% of this. Now, I can also rotate this frame if I want, and I can translate it. Now, translation works on a one-to-one basis. So if I translate it 1, you're not going to notice any difference, because basically it's gone 1 over and is wrapping around. So I need to do this in a fraction, say 0.2 and 0.4. But we can also use what's called interactive placement to place this a little bit more precisely. So if I click on this, notice how my cursor changes. And the key mouse stroke here is middle mouse button. So all I have to do is middle mouse click, and I can change the positioning of this. Now, when you middle mouse click, notice how there's little grab points, little tabs here. Sometimes you have to grab those. Now, if you grab the middle one here, you can position it. See that little dot there? That's the positioning node. And so I can just go ahead and position it by moving that. So for NURB surfaces, this is a great way to position and align textures. And NURBs are really kind of nice in terms of texturing because one NURB surface basically equals one bitmap image. And so it makes it very easy to stick bitmaps to a NURB surface. Another way to apply texture mapping to an object is to project those textures. Now, what projection does is it actually uses an external object as a projector to apply the texture. So this works for either NURBs or polygonal surfaces because the actual texture mapping object is separate from the geometry itself. So let's go ahead and open up robot05.mb, and I'm going to select the face of this dial here in his stomach. And then I'm just going to create a material. So I'm just going to go to my rendering shelf here, create a blend, go color. Now, typically we have this set as normal, but I want to go one down here to as projection, select the file, and then here we have what's called image. So I'm actually going to go down one more and then load the image. Now I'm in my source images directory, and I'm just going to load this one called dial fg.jpg. Now you can see that maps to the object. Now we're not seeing this mapping exactly because I should turn on high quality rendering, which will give me a little bit better view here. I've got this word volts, which needs to be here, but you can see the little tip of it's up here. I can change this by manipulating this texture mapping object. Now it comes in down here, and it's called place 3D texture. Now if I move that throughout the scene, you can see how it moves the texture. In fact, if I want, I could actually fit that to the group. So if I just go fit to bounding box, it automatically fits, and then I can go in and I can adjust it. So I can move this around, I can adjust it, and I can do whatever I want. So this is how I'm placing my texture onto my object. Now this Place 3D texture node is actually a separate object in Maya. If I go to my outliner, you'll see I have it highlighted. Here it is. If I go to my dial is actually in here somewhere. And then if I select this object, I can change that mapping anytime I want. Now this is really good if you want to animate a map, but it's also good if you want to also project a texture onto multiple objects. Now in addition to this, right now we're doing a planar mapping, but we also can do other types of mapping as well. So if I go to my actual object here, I click on the face of this dial, I go to my blend, go to my color mapping here, you can see I have what's called a projection, and this tells me how that texture is being projected. Now in this case, we've got a planar projection, but you don't have to use planar. You can use any one of these. So for example, you could project it spherically. Okay, now this doesn't really work for this particular object, but you can see how you do spherical, cylindrical, and so on. One of the nice ones is called triplanar, which basically projects it from 3 different sides. You can also do cubic, which projects from 6 sides. But I'm going to keep this one at planar for now. But you can use these to map just about any object within Maya and also control the mapping from outside of the object. Polygonal objects have several different ways to apply mapping coordinates. So we've got this robot open, robot 06, and we've already mapped the dial here. But let's go ahead and map the body of the robot. I'm going to hide everything else. I'm just going to select the body of the robot, and I'm going to go Display, Hide Unselected Objects. We can also hit Alt-H if we want. And let's just go ahead and apply the texture map. In fact, I've got a texture map here in Photoshop, and it's called robotfrontb.jpg. And if I just create a material, such as a blend, and apply this as a normal, make sure we have this selected as normal, File, and select Robot Front B, you'll see that it applies the texture, but it doesn't really map it how I want. I just want this texture to be mapped to the front of this object. Now, I can do that in one of two ways. You can see how this isn't mapped to the front of the object. Now, in order to do that, I can go into my polygons menu where I have these mapping tools, and those mapping tools are under Create UVs. And now we have a number of different types of mapping. We have planar, cylindrical, spherical, and automatic. So let's just go ahead and use planar mapping. So if I take this object and apply planar mapping to it, you'll see that a little plane comes up and it actually maps it, and it's actually mapping it to the side. But I really don't want it to be there. I need to rotate it. So I can go into my polyplanar projection. Now let me show you where this is. I'm actually going to click off of this. If you go into your channel box, you'll see that the actual object itself has a polyplanar projection node on the history of the object. In fact, I can even get to that in my attribute editor. So I select this and I find my polyplanar projection node. I can still affect this. Now, one of the options here is obviously the width of this and the height. But really, we want to play with rotation because we want this projected on the front. So I'm going to take the rotation down. So with a rotation of 0, 0, 0, this is pretty much aligned. But now I still need to scale this. So I can actually just grab the handles here and scale left or right, and then the center one positions it. So there we go. So now I've got this front of my robot. In fact, if I go display, show, last hidden, you can see I've got my robot. Now this little shield is a little high here, but you can see how that maps to the box. In fact, let's go ahead and select the box and just do another Alt-H or hide unselected. And I want to show you another little thing here is that this map is actually smearing here on the sides because it's got a little bit, in fact, if we look at the map here, it's got a little bit of a grain to it. And also, if you go into the back of this object, the mapping is kind of just mirrored from what we have on the front. Now, we can change that. If we want, we can actually apply multiple UVs to it. So, for example, for the back, I could actually right-click, select the face, that face on the back, and go create another planar mapping for that face. And I can unrotate it, and I can scale it. And one of the things I can do is I can just scale it beyond where that texture is and just position it so that I don't have any of that detail in there. I'm just really using a trick in that I'm zooming into this little area in the texture where there is no object. So now I've got a clean back. Now you can do that as well for the sides or the front. And you don't have to do planar mapping. You can certainly select all of these faces and apply whatever other type of mapping you want. For example, if I wanted to do cylindrical mapping, I could certainly do that as well. Now, I'm not going to adjust this. I just want to show you that you can apply multiple types of mapping. So, for example, cylindrical mapping allows you to basically wrap a tin can, kind of like that. And we also have spherical mapping. And another really good one is called automatic mapping. And what automatic mapping does, here, let's go ahead and select these again and go automatic mapping. And what that does is it projects one texture from each direction, which is kind of nice. Now, once I have this, you can actually go back into your channel box or your attribute editor, and you'll see that we've got a number of different types of projections. So every single projection is remembered on the object. So you can go back and adjust those at any time you want. Now, if you have a complex polygonal object, you may not want to apply multiple maps to it. You may want to do what's called UVW mapping, which allows you to take a single map and map it to multiple parts of a polygonal object. Let me show you how this works. I'm going to actually go into Photoshop and just show you an image file here. So for this file, we have actually the front, the back, and the side views of this robot all laid out in one file. So that way I don't have to create multiple texture maps and it all sticks to the polygonal object. Now with a texture like this, I need to be able to map parts of my polygonal object to parts of the bitmap. So let me show you how that's done. I'm going to select the body of the robot And then I'm going to just do a hide unselected. So we can just play with that. Then I'm just going to create our blend material and then apply a file as normal and apply the file called robot UVW. And again, I need to make sure I have high quality rendering and hardware texturing turned on. But now again, we have that same situation where you have this one map that's kind of applied all funky to this object. But we can change that by using what's called the UV texture editor. Now, each one of these represents a side of this cube. And all we have to do is match the proper side of the cube to the proper part of the bitmap. Now, we can do this in a number of ways. One is if we right-click over the polygonal object, you notice you have UV. Now, these are called UV texture coordinates. So, for example, here, if I select one of these, you'll notice that when I go into this window, that UV shows up. In fact, if I zoom in here, you'll see that each one of these UVs shows up in this window. So I actually can position this on a vertex by vertex basis. But Maya, in this particular case, has broken this up into individual kind of surfaces. So I can use another tool here to select the entire surface. So if I click this icon, I can select the entire surface. So for example, I could select these and move them away, and I can select this, which I know is the front. You can see how they light up here, and just move that. You can see how the texture is starting to map in. And then if I want, I can just use my move and scale tools. I can actually scale this to fit. So this exactly fits. And if I don't like where some of these are going, I can select just those vertices and move them, or just those UVs and move them. And then I also can do this for the rest of my objects. So for example, if I want some on the side, I could, for example, select these two, move these out of the way, select this one, and position it as my side one. And I can just select each of these vertices just by hitting W. I can move them, and I can position those as well. And if they're not stretched a little bit too much, in fact, this one needs to be rotated. If you notice, it's stretched vertically because it's in the wrong orientation. Now I can change that just by hitting one of these rotate buttons, which rotates 45 and 90 degrees. And actually, I need to select the entire thing in order to do that. So let's select all of this, rotate it 45, 90 degrees, and then just adjust it. So you can see how very easily you can position on a polygon by polygon basis and actually map this to your object. Let's go ahead and just do one more surface here. Let's just do the back. So where is that back one? Okay, there's the back. So I'm going to go ahead and move this one out of the way. And let's just go ahead and move these all over kind of like the clear area here and select this back and then just use scale to position it. Now in this case, I've got this a little bit upside down. So if I want, I can just rotate it a few times until it's right. And there we go. Now, there's a lot of different functionality here, but what I tend to do is I tend to use these ones here. Now, this one selects the entire mesh and allows you to deform it with a warp. This one selects the shell. This one allows you to unfold things. So, for example, if I have something that isn't already unfolded, I can actually unfold that. Now, I have additional tools here, such as rotate and scale. I can also merge edges. So if I have two shells that are close to each other, I can merge, cut, paste, and there's a whole wealth of other tools. So this is a very popular way of mapping polygonal objects to image maps, and I'd strongly suggest that you understand this if you're going to be doing a lot of polygonal texturing. Another way to use materials is to integrate objects with live action. And typically we do that with the use background material. And let me show you how to use that. We've got a file open called carbg.mybinary, and it's essentially just a car sitting on a plane. In fact, if we want to, we can render this. Now I'm rendering this in Mental Ray, but this technique works for any renderer. It's just a car and a plane with some shadows underneath. Now let's go ahead and place this into a still image. Let me go ahead and open Photoshop. I have this simple background image, and let's go ahead and just bring that in as an image plane. So I go View, Image Plane, Import Image, and in our Source Images directory, we have a file called Background. And we can see that. In fact, it is an image plane, so you can actually see that in multiple views here. And if we move the camera, it's actually stuck to the camera, so the plane is always our background. So we can just adjust this car to be in the scene however we want. Now, if you notice, this doesn't quite fit my image. Now, I can change that just by going Image Plane Attributes, and just change that. Now, if I scroll down here to Placement, you can just click one of two buttons. One will fit to the resolution gate, which is the 640 by 480 that we're rendering, or the film gate. So we're going to click Fit to Resolution Gate, and then let's just do a quick render. So the car is kind of sitting in the scene, but we still have to get it on the grass, so to speak, or on the ground. You can assign it by selecting your plane, going to our Rendering tab here, clicking here on Use Background, or going to Rendering, Lighting, Shading, Assign New Material, Use Background. And when I assign that to the plane, what it does is it actually is going to pick up any image data that's behind this. So for example, all this stuff in the foreground, it's going to use that color to create the color on the plane. So if I render it, you'll see that it's starting to pick up this color. But we have an issue here, and you can see that this object is actually reflecting in our image. And that's because this Use Background can create reflectivity, which is really nice, but for this particular application, we don't need it. So I'm going to just go ahead and slide this all the way down to 0 and do a render. And there we go. Now, this is just a rough idea as to how it works. Obviously, we can do some stuff to make the car fit into the grass a little bit better, but you can see in principle how this works. Now, in addition to this, you can also use this with moving image files. So if you wanted to use a target sequence for your image plane, you could also do that. The next topic we're going to cover is displacement and bump mapping. Now, a lot of times you'll want your surfaces of your objects to have bumps or roughness, and you can do that in one of two ways. The first is bump mapping, so let me show you how that works. I'm going to create a simple NURBS sphere and just apply a blend texture to that. Now, if I render this, you'll see the texture is very smooth. It looks almost like plastic. Now, we don't have to keep that smoothness. We can always add what's called a bump map. So if I click here and add a map into there, I can actually create a bump. Now, one of the more common ones is to just do what's called a fractal or a noise to give it just kind of an overall random sort of roughness. So let's go ahead and just add fractal to this, and then let's just do a render. As you can see, the characteristics of this surface have changed a lot. And if we want, we can actually change the depth of the bump. So if I bring this down here to a smaller value, you can see that you can get almost like an orangey-like texture. In fact, if I want, I can go up here, change the color to orange or orangey, and I have a reasonable facsimile of an orange just by adding that fractal texture. Now, the one thing about bump mapping is that it's really just a rendering trick. In other words, it only affects the pixels of the surface. So it doesn't really bump the surface, it just renders the surface as if it is bumped. So let's take a look at a more extreme example. I'm going to create a brand new material for this. So I'm just going to go ahead and apply another blend. And this time in the bump mapping, I'm going to add a cloth texture. So let's go ahead and render that. When I do, you'll see that on the edges, it still goes to a sphere. In fact, if I zoomed in here a little bit and did that render, you'll see that these bumps actually aren't real bumps. They're just kind of painted on. It's almost as if somebody painted it like it was bumped, but it's still a flat surface, almost like a faux texture or something like that. So in order to create an actual change in surface, you need to do what's called a displacement. So let me go ahead and do that. I'm actually just going to duplicate this sphere and move it over to the side here. So we're going to have two spheres. This one has a bump. This one will have displacement. I'm going to create a new material. Again, I'll just use a blend. And this time, instead of going to bump mapping, I'm going to go up one node. So if we actually go up here, you go to what's called the shader group. Now you can get to it this way, or if you want, you can go into something like the Hypershade window, and you'll notice there are shading groups here. So for example, this one is Blend 3 shading group. And so what this does is it actually has a number of different types of materials. One is the surface material, which actually renders the characteristics of the surface itself. The other one is called volume material, and this is for creating volumetric effects. And the third is called a displacement material, and this actually physically displaces the geometry. So let me show you how this works. We go to the displacement material, add in a texture, and again, we're going to do this as normal, and we'll add in that same cloth texture. Now, when I render this, notice the difference. This one just has a bump map applied. This one has a displacement map applied. Now, the displacement map literally remodels the object and actually creates new geometry to create actual bumps. Now, the problem with this is that we are adding additional geometry to our scene, and that creates overhead. So if you don't need a displacement map, don't use it. Bump maps are a lot faster when it comes to rendering. The other problem with displacement maps is that the surface you see in the viewport is not the surface you see when it renders. For example, if a character was walking across a bumpy ground that was displaced, the foot may go through the ground if you don't know exactly how that's displacing. Now we can control displacement here by just going into our object. So I'm going to select this second sphere here. And if I go into the NURBS sphere shape node, I can actually go down here and control how the displacement map actually adds in that geometry. So if I want, I can actually increase the sample rate. So if I increase it up a little bit, you'll see that it's actually going to create a finer mesh. It's also going to take a lot longer to render. So you have to be careful with this. Now you can probably keep this as low as you can without creating artifacts. And then again, for the actual shader group, if you go into this displacement material, you can affect that particular texture map. So those are the differences between bump and displacement maps. And I really don't find too many places where displacement maps are absolutely needed, but you can use them, and they are definitely very effective when the situation requires. The next material I want to show you is called the ramp shader. Now what this does is it uses gradients or ramps to determine things like color and transparency. Let me show you how this works. I'm going to create a sphere, and I'm just selecting my NURBS sphere. So we'll just start with a sphere. And the ramp shader is here, or you can certainly go into lighting shading, assign new material, ramp shader. When I do that, up comes the ramp shader parameters: color, transparency, incandescence, specularity, and so on. And what these do is they use ramps or color gradients to determine how the color changes on the surface. So let's just start with the actual surface of the object itself. Now, if we want to, we could certainly change the color to, for example, red or yellow or whatever color we want. We can also change it so that the color varies depending upon a number of different inputs, which is right here, either light angle, facing angle, brightness, or normalized brightness. Now, I think facing angle is probably one of the easiest to understand, because what it does is it changes the color depending upon the angle of the surface to the eye. So when the surface is pointed straight at you, it's one color, and when it's away from you, it's another color. So we can add in this second color here just by left-clicking and dragging a new node. And as soon as we select that node, we can change the color. So we can say, I want it to be blue when it's facing me, and here, and I can certainly move this around if I want. And if I select this one, I can say, well, I want it to be red when it's away from me. I don't really see it here. I can certainly turn on hardware texturing and I can see it a little bit better, but you see it the most when you render it. So you can see how part of the object that's facing me is blue and that which is facing away is red. Now this can be really handy. So for example, if I have a blue, I could just make it a light blue sphere here and just fade it to almost a darker blue or even a bluish purple. Now this gives me a much better way to shade things. So I have a richer sense of shadow and form. So instead of it going to just gray, it goes to kind of a dark blue. It's a really nice way to give additional detail to an object. Now I'm going to go ahead into my camera attribute editor here, and I'm going to turn this environment into white. I'm going to turn my background color to white so it renders a little bit better. And now we're going to play a little bit with the transparency in that ramp shader. So I select my object, go to ramp shader, and let's go to transparency. Now, what we can also do is change transparency dependent on angle. Now, this is really handy when you're doing something like glass, because as, for example, the glass on the windshield of a car curves away from you, you actually get kind of more thickness, and actually it becomes less transparent than if you're looking straight through it. Think about a piece of glass. If you look straight through it, you can pretty much see through it. If you tilt it, there comes a point where you can't see through it because you're looking through so much glass. Now we can do the same thing here by just adding a node, changing the color to white or black. So for example, this one here is the angle that's away. So if I make it a darker color, it's going to be more opaque. Lighter colors are more transparent. So I select this one, and I can also bring those in a little bit. And then when I render this, you'll see that, in fact, let's go ahead and put something behind here. I'm going to go into image plane, and let's go ahead and just put this background behind it, so we can kind of see this a little bit better. So you can see that when you're looking straight through it, it's pretty transparent, but towards the edges, you can see how it's a lot less transparent. So this is just because the transparency is determined by the ramp. Now, for example, if I wanted to, I can make this completely transparent. So we can actually make this even a little bit more effective here. So you can see it's very clear through here. So this gives a much better simulation of stuff like glass and transparent surfaces. Now, in addition to this, you can also play with stuff like specularity, specular roll-off, and reflectivity. So one of the nicer things about this is that you could actually define how your specular colors roll off. So for example, if I want a highly specular surface here, I could actually roll that off according to a user-defined curve, which is really nice. So those are some of the basics of the ramp shader. Now, one of the cooler features of Maya is the ability to do 3D paint. You can actually paint on an object and save those files out as bitmaps. So let me show you how that works. Let's just go ahead and paint a simple sphere. So I'm just going to create a sphere and apply a material to it. I'm just going to go ahead and apply a Phong. And once we have a material, we can certainly change the material and add stuff in, such as color. We could add a bitmap into color. Now, once we have applied the material, we can certainly change the color by adding a bitmap or transparency or whatever. But the other way to do it is to actually just paint that texture. So let's go into our rendering menu set, go to texturing, and we have what's called 3D Paint tool. Open that up, and what I get is a brush interface, very similar to the interface we use for Paint Select and for Sculpt Surfaces. In fact, the tool is almost identical here. Well, I can hit B to size my brush, and then I can paint. But you're not going to be able to paint on anything until you assign a texture. Now, we do that by going to the bottom of this menu, and we select what type of attribute we want to paint. Now, in this case, we're just going to paint color, and then we hit Assign Edit Textures. And what this does is it brings up this dialog box, and we can dial in the size of the texture that we want to paint. We can also choose whatever type of file we want to save this as. So once we set the size of the image and the format that we want to save it at, we can go Assign Edit Textures. And then once we do that, we can start painting. So again, let me scroll up to the top here, and you can see that I'm painting this color. If I want to, I can certainly change the color and paint. I can change the size of my brush. And I can also change the size of the brush here. I can also change the type of brush, whether I want a hard edge or a soft edge brush. I can also change the opacity of the brush. So for example, if I wanted to do just kind of a light wash over it, I could just really dial down the opacity, and I would just be tinting this. And you can see how this makes a very easy way to sketch out and draw textures. Now, a lot of times what people do is they'll use this 3D paint package to kind of rough out where everything is on the texture of an object, and then they'll go into Photoshop and actually fine-tune those images. Now, in addition to the painting tools, we also have a flood tool. Now, we can flood this with any color we want. So, for example, if I wanted to flood it with this color, all I have to do is dial in the color and just go flood paint, and it will flood my image. And then I can go ahead and paint on this whatever color I want. Now, once you have your paint done, you need to save this texture out in order to really be using it in Maya. Now, in order to save the textures, you also have to save your Maya file. So I'm going to go ahead and save this scene as 3dpaint.mb. Now, once I've saved it, I can go back and select my object, go to my attribute editor, select my object, and you'll see that it's actually created a scene here called shape1.color.tg. In fact, I can open this up and you'll see that it's actually located in the 3D Paint Textures directory of my project. So now I have an actual image file that I could load up in Photoshop if I want. Now, if I want to, I can go back to the 3D Paint tool and continue to work. And if I've gotten to a point where I really like it, I don't have to save the whole image. I can just save out my textures intermittently if I want to. In addition to just painting color, you can also do stuff like smear. So you could actually smear paint, you can blur, and you also have a clone brush. And you also have an erase brush here, which erases it to the last image that you saved. So basically, it's almost like a paint undo. So it just goes back to the last saved image. So that's the basics of the 3D Paint tool. Now remember, this tool does use pressure sensitivity. So if you have a tablet, you'll get a lot more out of it. Now let's talk about rendering in Maya. It's essentially a photographic process because what it does is it allows you to take a 3D image and snap a picture of that. Now in this case, the picture is a bitmap, but it's very similar to taking a picture with a digital camera. So I've got a file open here. In fact, let's go ahead and set our projects here. Set rendering. Now for this chapter, we're going to be working with the Maya software renderer, which is kind of the default renderer in Maya. I've got this file open. In fact, I'm going to go ahead and turn off these templates. And if I want to render this robot, all I really have to do is hit this little render button. And I've got a nice rendered image. Now rendering is controlled by the render settings window. We can get to that window in a couple places: rendering editor, render settings, or we can click on this icon, which is where I always go. In this render settings window, we have all of the controls for each individual renderer. Now, if I want to, I can change the renderer here, and notice how all of these options change. So the Maya software renderer has these types of parameters, whereas MenoRay has all of these parameters. Now, every renderer here has what are called common parameters. And those are things that are basically common to all sorts of renders, which is the types of file output, the number of frames that we're rendering, which camera renders, as well as the image size. So let's go through some of these. The first one is file output. Now, if you want, you could certainly set it to a specific name. If not, it's going to use whatever your scene is named. In this case, that would be Robot Final. And then the image format. If we want, we can use Maya IFF or any of these. Now, the next one is, how do you want the files to be named? Now, Maya renders in image sequences. So if you have an image sequence, you can name it any one of these. So, for example, it's just the name with the extension, in this case, .targa. Now, if you're rendering animation, you have to tell it where to put the number. So, for example, if you want the name and then the number and then the extension and so on. If you select one of these animation ones, then a couple of new options light up. The most important one is frame padding. So if you look here, it actually gives you a sample of what the file name will be. If we turn up frame padding, that means we have more leading zeros in the number. So for example, 2 leading zeros, 3 leading zeros. Now if you have this at a name.extension, obviously we're not rendering image sequences, so it's just going to be this name. Now if we are rendering animation, what comes up here is the frame range. What are we rendering? Are we rendering 1 through 10, 1 through 100, 28 through 43? Give it your start and end frame, and you can also give it an increment. So if you want to render on 2s or something like that, you can do that. You can also renumber the frames. So if you are rendering, say, in the middle of a sequence, but you still want the first frame to be called frame 1, you can do that here. Now the next one down is probably one of the more important ones, which is the renderable camera. Which camera in the scene gets rendered? Now, if you have multiple cameras in the scene, you will have to set this to be the renderable camera. The next one is image size. How big is our render going to be? How big is the piece of film? Defaults to 640 by 480. You have a number of presets here. You have, square, 1, 2, 3, and 4K. We have 1024, HD 1080, and so on and so forth. And if you don't like any of these, you can certainly create your own custom one where we can give it whatever width and height and whatever device and pixel aspect ratio we want. Now we also have what are called render options, and these allow you to put scripts in before and after something renders. Now with the Maya software renderer, we also have another tab. I'm not going to go through all of these. Let me just go through some of the basics. The most important one here is quality, because these are some presets that you can use just to give you whatever type of quality you want. Now we have what's called preview quality, which is actually kind of a low res quality. It gives you kind of jaggy edges and stuff, but it's great for rendering things fast. So if you just want to do a comp or just do a test, just do it in preview quality. If you want to do full up production quality, then what that does is it increases the amount of anti-aliasing and so on. And that's all of these parameters here. Now, typically, I just use the presets. If you want, you can dig through this and really customize it if you want. We also have field options if you're rendering NTSC. So if you're rendering on fields, you can do that. The next one is called ray tracing quality. And this is where we can turn on and off ray tracing. Now, what ray tracing is reflection. So if, for example, if I turn on ray tracing and do a quick render, you'll see that we have a little bit of a different look because now it's adding reflections here and that sort of stuff. So you can get stuff like reflections, you can get more accurate glass and transparency, and you can also get ray traced shadows with all of that. Then we also have stuff for motion blur, additional render options, and so on and so forth. So those are the basics of the render settings window. So as we work through the next couple of lessons, you may need to change these. So just know where this menu is at and get very familiar with it. Now rendering is like photography, so we are taking pictures. And in order to take pictures, we need to add light. Now I have a file here called robotnolight.mb. And it's exactly as advertised. Now, when I render something without any lights in the scene, what happens is Maya just puts in what's called a default light, and it will render the scene with that default light. So it's kind of just a boring light. Now, I can change that in the render settings window. If I go all the way down here in my common parameters, under my render options, I can turn off enable default light. Now, what happens when I do that is nothing, because there is no light in the scene other than what's caused by the objects themselves. Now, this particular scene, I have a little bit of glow. Here, let me show you where I put that in. I've got a little bit of glow on the special effects of the shader for the eyeballs and a little bit of self-illumination. I've actually got a ramp shader here with a little bit of self-illumination. But those are the only sources of light in the scene, so that's all that renders. Now, we can add in additional light. Now, if I want to, I can certainly turn back on this enable default light, because what happens is as soon as I add in a light to the scene, that goes away, and it just uses whatever the lights are in the scene. In fact, if I want to see default lighting, I can always go into the viewport and go use default lighting as well. Now, let's go ahead and add some lights into our scene. We can get to lights in a couple of ways. We can go create lights and just create any of these lights. In fact, I'm going to tear this off here. Or if we're on our rendering shelf, we have those same lights here as icons. Now the lights are ambient light, directional, point, spot, area, and volume light. So let's go ahead and go through some of these. I may skip around here. The first one I want to show you is the spotlight, because that's actually one of the ones that we probably would use the most often. Now, when I create a light in Maya, it always creates it at 0, 0. Actually, this scene was built so he's actually a little bit below 0. So it kind of comes up around his waist here. Now, if we zoom in, you can see that that's the light. Now, if I want to, I could actually turn on in my viewport, use all lights, and I can actually see how this light affects the scene. So I'm going to zoom out in one of my side viewports, and you can see there's my light. Very cool. Now, if I want to, I can also adjust this light in a different way, and this is actually a way that I like doing it, is using this manipulator. So instead of going move, rotate, I could actually rotate this light. And, you can move and rotate. If you scale it, nothing will happen. But you can also use what's called the manipulator. So if I click here, it brings up two nodes that I can move. One is the target, and the other is the light itself. So actually, I like using this a lot. So I tend to hit this button a lot and then just position the light. So that way you can say, well, I always want to point it at the robot, and then I can just put the light wherever I want. And that way you never accidentally move the light off of there. And let's go ahead and take a render of this and see what it looks like. Okay, so that's what that light looks like. Now, what makes the spotlight unique is that it does cast a spot over a very specific area. So, for example, if I select this light and move it, you can see how I have a cone of light that's cast over the scene. Now, we also can change the attributes of this spotlight just by going Control A. And I can go through here, and these are all the attributes for the spotlight. Well, one of the first things I can change is the color. So if I want it to be a different color, I can change the color. I can change the intensity, how bright or dim is the light. For a spotlight, I can change the cone angle. How narrow is that beam? And I also can create what's called a penumbra angle. So you can see that as the soft edge. So when this is positive, the soft edge goes out. When it's negative, the soft edge goes in. And then you also have what's called drop off, which is enabling the light to fall off. Now, another important one is called decay rate. And what this does is it allows the light to fall off with distance. Now, by default, there is no decay. So these lights don't really work like they do in the real world. If you have a 100-watt bulb all the way across the room in real life, it's not going to illuminate the far corner of the room as much as it's going to illuminate right next to it. But with a Maya light and no decay, it illuminates evenly no matter how far away. Now we can change that to either linear, which is fall off one per distance, quadratic, which is inverse square law, which is real life lights, or cubic, which falls off with the inverse of the cube. Okay, this gets all technical, but just know no decay means the light never changes. Quadratic is real. Cubic is more than real. Linear is somewhere in between. So those are the basics of the light parameters. Now we also have different types of light. So I'm going to go ahead and delete this spotlight, and let's put in another type of light. The next type of light I want to show you is called a directional light, because this works a lot like a spotlight, except it doesn't have a cone. In fact, it's almost like the light from the sun. It really just kind of comes in parallel rays. In fact, if you zoom in on this, you can kind of see how that looks. The light is always coming from parallel directions rather than a point, as in a spotlight. Because the light is coming from all directions, the position of the light doesn't really matter. The only thing that matters is the direction of the light. So if I go into my perspective viewport and hit rotate, I can change that light just by changing the direction. So for example, even though the light's over here, it's still coming from that direction. Okay, so that's the directional light. Now, this is really great for general illumination of the scene, but you may come into problems when you go into things like shadows, because there's no defined area for this light to fall like there is in a spotlight, so it's hard for Maya to calculate the shadow. The third type of light is called a point light. So let's just go ahead and create that. And what a point light is the bare light bulb in the room. It's just a light that illuminates in all directions. And there really is no sense of direction like there is in the directional light or the point light. The next type of light is called ambient light. Now what this is just kind of a general ambient light. It's almost like a wash of light. It's not really anything more than ambient room light. And typically, you want to kind of keep that low. Now, if you're lighting a scene where you have kind of like a bright sunlight and you have light coming from all directions, you may want to toss in an ambient light just to kind of soften the shadows and make sure there's no hard shadows. The next one is volume light. Now, what a volume light is a light that comes from or is contained within a volume. So when I have this light, I can actually do a couple of things. One is I can change what type of shape the light is. It starts with a sphere. I can, for example, make it a cylinder, a cone, a box, or a sphere. I can scale this light if I want to make it bigger or smaller. And the cool thing about this light is that it's actually emitting out from that sphere. Or if I want, this is even a little bit more cool, is I can illuminate inward to that. So for example, if I wanted to, I could only illuminate those things within that sphere. Now this doesn't show up in the viewport. You have to render this. So for example, if I had only this part of the robot in the sphere, only that part will show. This is a really great way to have spot lighting that is tightly controlled. You can just create a volume of light and just put it around something that you want to highlight without having to shine all sorts of lights on it. And the last one is called an area light. Let me go ahead and move that one out. Now what an area light is essentially a light that comes from a specific area. Now if I want to, I can scale this up to create a softer light. This is almost like a soft box. In an area light, it comes from an area, not a point or many directions, but a confined area, which gives you a little bit more of an advantage when you're doing something like soft lighting. Let's see how that renders. So you can see that it's a little bit softer. It's not quite as harsh as the other lights. Now, the other thing with an area light is that as you scale it up, the light gets brighter, okay? So the size of that does matter. So if you scale it up, you're going to get a brighter light than if you scale it down. So you can certainly affect the intensity to offset that, but just be aware of that. So those are the basic lights within Maya and some of the basic parameters. Now let's talk about shadows. By default, Maya's lights actually don't cast shadows. Now this is kind of odd because there's really no light in the real world that doesn't cast a shadow. You know, anytime where there's an occlusion of light, there's going to be a shadow. So that's actually kind of a cool thing with Maya, is that you have lighting that is actually beyond reality. You can simulate reality if you want, but you don't have to. You're not really constrained by the laws of physics as much as you are here on planet Earth. So let's go ahead and take a look at how to create shadows within Maya. I'm going to start with this file, robot.nolights.mb, and we're going to add a spotlight. So this is the spotlight icon here, and I'm just going to go ahead and create that and move that up. In fact, I'm going to turn on use all lights here so I can see where my spotlight is. In fact, I'm going to use my manipulator tool. So I'm going to go into my perspective view and just position this light and position it kind of high, almost like a modeling light, kind of high and to the left. This is the standard Hollywood beauty shot light because I really want to get a good shadow. So now that I have the light selected and I have it positioned, I can certainly do a quick render here. And you'll see that, yeah, the light hits the object, but it doesn't create a shadow. Now, I can create the shadows in one of two ways. The first way is using what are called depth map shadows, and that's what I'm going to cover in this lesson. So if I select the light, and I go to my attribute editor for that light, and I scroll down, you'll see a nice little tab here called Shadows. And that allows me to turn on what are called depth map shadows or ray trace shadows. So let's go ahead and concentrate on depth map shadows first. Let's just turn it on. Of course, I have to have the proper view highlighted, so I make sure I right-click over the perspective window and then do my quick render. And there's my shadow. Looks great. Okay. But we can also affect this. by using a lot of different parameters here. In fact, I'm going to do a little trick here. We have an additional way to render in Maya, and that's called IPR. If I click this button, it will go ahead and render my scene, and it will allow me to do interactive rendering. All I have to do is just left click and drag over the area I want to see, and it will automatically update that. So I can change some of these parameters and we can see them in real time. So one of the first things we can change is shadow color. So for example, if I lighten up or darken my shadow, I can create whatever color shadow I want, which is kind of nice because I can certainly make a green shadow. If I really wanted to make a bright green shadow, I could certainly do that. It's not very natural, but then again, Maya doesn't have to stick to the laws of physics. And one of the things I find the best about affecting shadow color is that you can soften your shadows. You can actually make a shadow that's not completely black. Now, the other thing with depth map shadows is a couple of these parameters. One is called resolution and filter size. Now, what resolution is the size of the bitmap it uses to create the shadow. So what this means to you is that the higher the resolution, the sharper the shadow. The lower the resolution, the more blurry or softer the shadow. Now, this is kind of dependent upon how big you render. If you're rendering 4K, giant images, you may need to change your shadow resolutions to a different value than if you're rendering for NTSC or something like that. So let's go ahead and put this to a ridiculously low value. Let's put this to 64 and we'll see what happens. So when I changed it to 64, I had to re-render because of how IPR works. But when I did that, you can see how the shadow is starting to break up. That's because it only has a 64 by 64 bitmap to calculate that shadow. In fact, if I take this second value here, which is called filter size, this is what blurs that shadow. So if I bring this all the way down to 0, you can see that this shadow is actually composed of this jaggy kind of bitmap. And this filter size, if I go up one, render, you'll see as I go up, let's bring it up to 4, what it does is it starts blurring the edges so that I have a softer shadow. So a lower resolution and a higher filter size will create a softer shadow. Now, if I bring my resolution up very high, the bitmap will have less space to blur. So for example, if I bring this up to 2048 or really high, like a 2K shadow map, then you're going to get a really sharp shadow again, because this is only blurring the outer 4 pixels or something like that. So a higher number here on the filter size doesn't matter as much when the resolution is high. I can certainly push this up to a very high number. If I want to, I could actually type in something like 48, and I could actually get a much blurrier shadow. But again, with a really high resolution, it's still not going to affect it as much. So typically, I keep this actually around in the range of 1, 2, 3, or 4, typically around 3, and I keep this around 5, 12. This is just for standard NTSC work. And that gives me a nice shadow that is not too sharp. The difference between these can create soft or hard shadows. Now, in addition to this, we also have what's called a bias control. Now, what the bias control does is it actually offsets the shadow just slightly from the geometry so you don't have geometry shadowing itself. And then we also have parameters here for fog shadows if we're doing special effects on the light. So for example, if I added some fog to the light, I could add shadows through that fog. So those are some of the basics of depth map shadows. Let's move on to ray trace shadows in the next lesson. The other type of shadow in Maya is called a ray trace shadow. Let me show you how that works. Again, we're going to start with a spotlight. So I'm just going to add a spotlight into the scene, and let's go ahead and position that. Again, I want to just get a nice high kind of angle so I have a nice shadow to play with here. Pretty much over his head, something like that. Okay. So I'm going to go into my perspective window and keep that spotlight selected. Now I'm just going to hit Control A and go into my attribute editor. And what we did before was we used depth map shadows. But this time we're actually going to use what are called ray trace shadows. Now ray trace shadows work a little bit differently. Depth map shadows work off of a bitmap. It actually calculates a bitmap, and they render a little bit faster than a ray trace shadow. But ray trace shadows are actually a really accurate shadow. They actually calculate by bouncing rays of light through the scene. So it actually calculates a very accurate shadow. One of the benefits of ray trace shadows is that you can actually shadow transparent objects. So if you had a glass table, for example, you could cast a semi-transparent shadow under that table, where you couldn't do that with a depth map shadow. So with ray trace shadows, you need to turn on ray tracing in the render settings window. So if I go into the Maya software renderer, and it's the same for Mental Ray, you have to make sure that ray tracing is clicked on. And when I do that, then I can actually render this scene. Now notice how that ray trace shadow is really very sharp, because what it's doing is it's casting rays from a point in that spotlight and making a very, very sharp shadow. Now with ray trace shadows, I can certainly modify the shadow color. So for example, if I made this a little less dark, it would still render, and it would be a little bit lighter of a shadow. But the one thing about ray trace shadows is it's harder to create soft edge shadows. So what Maya does is it gives you some options here, and one is called the light radius and the number of shadow rays. If it's 0 and there's 1 shadow ray, that means we're very, very sharp shadow. More shadow rays and a higher light radius will make the shadow a lot softer. For example, the light is bigger, it's going to actually cast the rays from a wider area, and so it will cast them from different angles and create a softer shadow. But in order to do that, we need to increase the number of shadow rays. So let's go ahead and bring this up to, say, 0.25 and 16 shadow rays, and let's see what that does. Okay, that's a little bit softer. Let's go ahead and bring up that light radius up a lot. Let's make it 2. Now these are in Maya units, so it depends on the scale of your scene as to how big that light radius needs to be. If your scene is modeled in a large measurement scale, you're going to need a larger light radius. So with a radius of 2, you can start to see I get a much better shadow. Now with a radius of 2 and 1 shadow ray, you can see that it's kind of grainy. Kind of gets that almost stippled effect. So more shadow rays kind of fills in the stippling. So for example, if I go up to, say, 8 or 10, it'll modify that effect. Now, the higher the radius of the light, the more shadow rays you'll need. So for example, if I bring that up 8, you're going to get a very soft shadow, and again, you're going to see a lot of that stippling. So again, you can just bring up the shadow rays to, say, 16 or even higher, and you can get a much better shadow. But also notice the more shadow rays you add, the longer it's going to take to render. So it's really a balance. You really just want the minimum number of shadow rays to render the scene so it looks good, because the mantra with CG is that if it looks good, it is good. It's all about how it looks. So basically, you want just enough shadow rays to give you a good, smooth look, because if you go too far, it's going to jack up your rendering times. Up until now, we've been playing with lights, but let's go ahead and take a look at cameras. Now, cameras in Maya are essentially virtual cameras, but they mimic standard 35mm and motion picture cameras. And you can create cameras either in the Create menu under Cameras. There's 3 types: camera, camera and aim, camera, aim and up. There's also in Maya 2009 stereo cameras. You can also create a camera here, and this just creates a basic camera, not one with aim or up. We're actually working in this robotfinal.mb file. So let's just zoom out to a 4 view, and let's just go ahead and create some cameras. The first one is just camera. So when we create a basic camera, it just creates a camera in the viewport. Now, in order to look through that camera, you need to change one of the viewports so you can see through it. So for example, here we can go Panels, Perspective, Camera 1. And this will actually look through that camera. So you can see it here in perspective. We are actually, in fact, let's go ahead and turn on shading here. You can actually see this in perspective. In fact, if you want to, you could actually use your camera modification tools and just position your camera by zooming and rotating. And notice how when I do that, the camera in the viewport changes. So I'm actually literally moving this camera by zooming out here. Now the next type of camera, let's just go through the basic cameras here. The next type of camera is called camera and aim. So let's go ahead and select that. And when you do that, what it does is it creates a second node. Notice how I have a camera and I have an aim point. Again, let's go Panels, Camera 1. And now this camera is locked to this target. It's almost like using that manipulator tool for lights, is that it's always pointing at that target. The third one is called camera aim and up, but I'm going to show you a little trick. We could either create that through the menu, or one of the other great things is that if I go into the camera's attribute editor, so I keep that camera selected, do Control A, I can go into my camera attributes. And here I can actually change it from a regular camera to a camera and aim and a camera aim and up. Now what the up does, in fact, let's just go ahead and take a look at that. It creates a third little point here, which allows me to tilt the camera. Very simple. So now that I have this, I can actually change it from any one type of camera to another. Now let's go through some of these controls for the camera. Cameras in Maya are basically mimic 35 millimeter cameras. So if you have something like a focal length, it's going to be a 35 millimeter focal length. In fact, let's go ahead and maximize our camera view. What focal length means is how long is the lens? Is it wide angle or telephoto? Now notice how focal length and angle of view are connected. So the longer the lens, the narrower the angle of view. So for example, if I have a 135 lens on this, it's going to be a 15-degree angle of view. Now what this means for you is that the longer the lens, the less perspective in the scene. So this kind of flattens it out. So for example, if you're taking portraits, you want to take a portrait with a slightly longer lens because it flattens out the scene and also gives a little bit more depth of field. Now, if I want to, I could actually make this a very short lens. So, for example, if I wanted to make it a 12 millimeter lens, just type in 12, and now I've got a very wide angle of view. In fact, it has a 112-degree angle of view, which means now it's seeing a lot more of the scene from the same position. Now, when I had the camera zoomed in, I had to move it back in order to see the robot. In this case, I have to push the camera in or truck in order to get that same view. Now notice when I have a wide focal length, you get much more perspective. This is almost like a fisheye lens sort of effect. But the big key here is that angle of view and focal length are connected. So I'm going to go ahead and put this back to, say, a 40 millimeter lens. So we have that. Now we also have some other things. We have what are called clipping planes. What a clipping plane does is the maximum distance where the camera can see, minimum and maximum difference. So for example, if I took the clipping plane and I brought it way down to, say, to 10, I wouldn't see anything. Bring it up to 100, I can. But as I zoom out, you can see it doesn't render anything greater than 100 units away. This can be really handy for rendering things like special effects and that sort of stuff. Now, typically this is set to 1,000 or 10,000, so I'm just going to put that back. Now, in addition, we can also create what are called film backs. So if you're working with 35 millimeter or IMAX or any sort of film matching, if you want to match to live action shot in any of these formats, you can use those film gates. And then we also have additional settings here. One is for mental ray. The other is for depth of field, which we'll get to. We also have output settings, environment. Now, this is one that we've actually used before. What this does is it sets the environment or the color of the environment. So when I render this, for example, this is rendered against the background color of black. If I bring it to white, it'll render against white. If I change it to a different color, now this is the background color behind all of the geometry, it'll render red. Now, if we want, we could also create an image plane at this point. This is exactly the same as going View, Image Plane, Import Image. These two buttons are equivalent. Now, in addition, we have special effects. For example, change the shutter angle, and this will affect motion blur. And then we also have some display options. We can display our film gate, our display resolution, our render gate mask, and so on. Now, these are also available up here as buttons, and also in the view menu we have our camera settings. We can also turn on the gate mask, which kind of just masks out those areas that don't render, so we can actually see exactly what the camera sees. We can also turn on and off a field chart if we want. Now, if you also want, you could also make a camera into an orthographic camera, which is an infinite angle of view. That's basically like a top, left, or right camera. So sometimes you may need this for like a special effect or something like that. If you're going to do like isometric stuff, you can use that orthographic view. So once you understand the basics of cameras, you can start placing them. When you're working with live action and you're matching cameras, one of the big keys is to write down your camera settings because you can match them in Maya. Another way to achieve realism in rendering is through depth of field. Now, this is a common technique in photography where you highlight one part of the scene by keeping it in focus and blur out the rest of the scene so that you have a point of interest in the scene. We can simulate this in Maya using depth of field in a camera. Now, I have a file here called redwagondof.mb, and it has that red wagon in it. Now, if I just zoom out here, you'll see I have a camera already set up here. In fact, I've got this one here, which is called Camera 1. And let's just go ahead and zoom in there, and let's shade this window. In fact, let's turn on hardware texturing so we can see. For example, if we wanted to render this with the handle as the point of interest, we could blur the rest of the wagon. Now, if we just do a normal render, we get everything. But we can add depth of field by selecting the camera and going into the camera attribute editor. All we have to do is go all the way down to depth of field, of all things. Now, we can just turn it on and see what happens. Now, notice it takes a little longer to render. And we get blurriness because the depth of field is set to a specific focus distance right here. Now, we need to calculate how far it is to the object that we want to focus on. Now, we can do that by, actually, there's a little trick here. Under display, we have what's called a heads-up display. And we can just turn on all sorts of things that will show up in our display. The one I want to turn on here is called object details. And when I turn that on, and I select a specific object, then it shows me the distance from the camera. So, for example, if I chose this handle, it will show me the distance to the camera. But this is the distance to the pivot of the object. So I need to make sure that the object that I'm looking at is at the right distance. So if I want this handle in focus, the distance of this object from the camera is actually calculated from the pivot, which is all the way down here. Now, probably the easiest thing to do is just to create a dummy object in there. So I'm just going to create a thing called a locator here. And this is just a dummy object that doesn't render. And I'm just going to set that right on top of the handle. Now I can see that this particular object is at any distance. So if I want to focus right there, I know that that point is 13.535 from the camera. So all I have to do is go Camera Attribute Editor, go here and just type 13.5. That should be close enough. And then I can set the f-stop of my camera. I'm going to leave this at 5.6 and just do a render. Now you can see this is in perfect focus, and the background is out of focus, which gives you a really nice kind of bokeh sort of effect. Now, if I want to focus on something else, I can either just move this around, which is kind of nice, or I can just select the object. So let's say I want to focus on the wagon. That's at a distance of 30. So let's go ahead and go Camera Attribute Editor and go 30.6 and then do another render. Now, the handle is out of focus and the body of the wagon is in focus. Now let's go ahead and put this back to being focused on the handle, so I can just type in 13.5. Now if I want to, I can also change my f-stop. Now this works exactly the way the 35mm cameras work. So for example, if I do f1.8, which is a very wide lens, I'm going to get a lot more depth of field. The blurring starts a lot more quickly. If I bring this f-stop way up, let's say I do f11, I'm going to get a much lower depth of field. So this doesn't blur nearly as much. So the f-stop really determines the amount of blurring. Now I also have something called focus region scale, and what that does is it's your fudge factor. So you can type in a specific focus distance and a specific f-stop, but you can also fudge that, so you can actually make that focus region bigger or smaller. So if your f-stop isn't giving you exactly the right amount that you want, you can certainly expand that. So those are the basics of depth of field. And one of the things you can do is, if you have a 35mm or a digital SLR, play with depth of field on your camera to see how it works. And you can apply that directly to your work in Maya. Another way to add realism to a scene is by using motion blur. This is really important with moving images because most photographic cameras don't take an exact still image. If something's moving through the scene, it's going to blur while it moves. So we can simulate this in two ways using Maya's software renderer's motion blur options. So let's go into a scene. We're actually a scene called Red Wagon Animated. It's just that little red wagon, and it's just zooming through the scene. So let's go ahead to around frame 14 or 15 and just render that. If we render it, we'll see that we have a still image, but we don't have any blurring on this. Now, if this was actually moving through the scene, you would see a little bit of blurring in a realistic photograph of the scene. So we can simulate that using motion blur. We go into our Maya software renderer, and we have a motion blur tab. Now, if we scroll down, we can turn on motion blur. We have two types, 2D and 3D. Now, let me explain the differences between these. 2D is a motion blur that actually just blurs the pixels of the final rendered image. So it's kind of almost like a mock motion blur. Now, it renders really, really fast, which is nice, but it doesn't quite catch certain types of animation. Now, for example, this wagon, which is moving left to right across the screen, most of the blurring is going to happen on the left to right. But if, for example, this was tumbling and moving in 3 dimensions, 2D motion blur might not catch that. And so that's where 3D motion blur comes in. So let's go through both of them and see how they work. Now, 2D motion blur, again, just blurs the image. So we can just go ahead and turn this on and render it, and you're going to get blurring, but you're also going to get this real kind of weirdness here. Now, some of this is pixelation because I have this set at low quality rendering. If I turn it up to production quality, you might get a little bit better. But what it's doing here is it's motion blurring the alpha channel. Okay, so I've got this against a blank image, so it's actually doing motion blur against an alpha channel. If I want to see this on the image, I need to go down here to smooth and smooth to color rather than to alpha. And this will look better in this type of rendering. Now, if you're going to composite something with motion blur, you do want to blur to alpha channel, but if you're just rendering out of the camera, color is what you want. Now, you can see we have our motion blur, and this actually is a lot nicer. Now, we can affect the motion blur here by doing the blur length. If we crank that up, it should be a lot blurrier. There we go. Crank it down, we can do it a lot more subtly. We also have blur by frame. You can actually blur over multiple frames if you want. Another option you can use is use shutter open and close. Now, this actually simulates the shutter of a motion picture camera. So we can open the shutter at 50%, we can open it more or less. So for example, if we open it at 25 and close it at 25 or 0.25, we get a much lighter motion blur. And we also have a blur sharpness and a smooth value. Now, the smooth value just smooths out. It's kind of like a blurring value. So a higher smooth value will give you a blurrier kind of motion blur. Okay, so I usually just keep this at the default, but you can certainly play with that. Now, the next type of motion blur is 3D motion blur. Now, this has fewer options. You actually just have blur by frame, and if you want, you can use the shutter to open and close. Now, this is almost like an automatic motion blur because it's actually creating it more realistically. When you're faking motion blur, such as in 2D, you have all these parameters you use to fake it. But when you're actually doing something that's a little bit more authentic, you don't need to worry so much about all those fakey parameters. So let's just go ahead and take a look at this render. So as you can see, this is a little bit different in character than the other motion blur. In fact, it's a little bit more realistic. Now, if you want, you can certainly affect the length of it by stopping down the shutter, which means less time. A faster shutter speed means quicker action. So that's how you affect the amount of motion blur. In this case, is by doing the shutter open and shutter close. So those are some of the key tools for using motion blur. And I like to keep it turned on because anytime I'm doing animation, it's always nice to have a little bit of blur on your objects. Now let's talk about reflections and refractions in Maya. These can be done using the ray tracer. So let me show you how this works. We have a file here called refractions.mb, and it's just a kind of a transparent goblet with some oranges in it. If we pull up the scene and render it without ray tracing, we get this, which is not really all that realistic. Now, the first thing we can do is just turn on ray tracing in the Maya software renderer. So we go here to Render Settings, Maya Software Renderer, and we turn on ray tracing. Now, I'm going to turn this to production quality because what this does is it increases the number of reflections and refractions as a default in ray tracing for this render. So it just gives us more bounces of the light when the light runs through the scene in Maya. So let's go ahead and set that ray tracing on and render. Now, when we turn on ray tracing, the first thing you'll notice is that there are reflections. And these reflections are caused by the surface material. So for example, I select this tabletop, go into the attribute editor of that, and I'll find my little blend shader here. You can see this is the color, but the more important one for what we're concerned with is this reflectivity value here. Right now it's set to 0.5. If I bring it up, let's go ahead and bring it up to a very high number, and then just click on that viewport and do a quick render. You can see it reflects a lot more. If I don't want that to reflect, I have to turn that down to 0. And that essentially makes it a non-reflective surface. So you can see how it doesn't reflect. So I'm going to kind of keep it back towards the middle here so we have some nice reflections. And notice how reflections they act almost like shadows do in a scene, and that they anchor the glass to the tabletop because there's now a point of connection here where the glass meets the table. Now, in addition to this, though, we still don't have a really nice look to this glass. We've got some nice reflections, but it still doesn't look like glass. It just looks like it's kind of a shaded material. We can affect that by working with refractions. So let me show you how that works. I'm going to close this render window, select the goblet, make sure we're in the Blend 2 material, go down to Ray Trace options and turn on refractions. Now we have a number of options here. One is the refractive index, refraction limit. How many surfaces will this bounce through before the refractions go away? So for example, in this goblet, you have this 1, 2, 3, 4 surfaces. You could actually bounce through the inside and outside surfaces of the glass on both sides. And then if you had a fluid or something like that in there, you could probably go to at least 6. By default, it's 6, and you can probably keep it there. You can always increase that if you want. We also have stuff like light absorbance, which is how much does that surface soak up the light. And then in addition, we also have surface thickness and so on, and how much does it attenuate shadows. I'm just going to leave it, just turn on refractions and just leave it at the default. So let's just see what happens. When we do that, we really don't get much of a difference because we have a refractive index of 1. And a refractive index of 1 is the same as not having any refractions. Because what happens is when the light hits a surface, what refractions is that the light changes its angle. And that causes almost like a lens effect. And so when you have a refractive index of 1, there is no lens effects because the light isn't bending. So let's go ahead and increase that refractive index. Let's just go ahead and make it like 1.1. You really don't have to increase it by all that much to get the effect. Once I do that and I render, you'll see a much better difference there because now the light is actually changing angle as it goes through this surface. And you can see now I'm getting kind of a lens effect right down here. It really works. And so if I want, I can make the refractive index either above or below 1. When it's above 1, refracts the light at positive angle. Below 1 refracts it at a negative angle. So the best way to do it is just experiment and see how this works. So you can see when I have a refractive index below 1, you can see the effect here. In fact, you don't have to really do much of refractive index. In fact, if I just do 0.96 or 0.95, just slightly below 1, you'll get a really nice effect. So there. So you can kind of see how that works. So now that we understand a little bit about refractions, let's go ahead and see exactly how these work in the render settings window. So let's go here to render settings and go back down to ray tracing quality. Now we have 3 parameters here. We have reflections, refractions, and shadows. These numbers indicate the number of bounces the light will go for each of these types. Now we've done reflections and refractions. Let's also go ahead and do shadows. So to do that, I need to select a light in the scene. I'm going to go to my hypergraph window, come down here to Default Light Set and select Spotlight 2. Now I can come down and I can set two types of shadows. One is Depth Map. The other is Ray Trace. Let's go ahead and turn on Depth Map shadows and render it. You get a shadow. It's a nice shadow, but notice how the shadow is not transparent. So it doesn't really look all that real. Also notice right here where the bottom surface of the glass interacts with the table, you're getting this little striation here, and that's just an artifact of the depth map shadow. We can fix that by turning off depth map shadows, scrolling down, and just turning on ray trace shadows. We can leave this at the default and just do another render. Now notice how different this shadow looks from the other one. You have actual ray trace shadows. The shadow is actually showing the transparency. You can even see the oranges in the goblet. So you get a much more accurate shadow when you're using ray trace shadows, particularly with transparent surfaces. So those are some of the basics of ray tracing. And you can see how these make for much more realistic, transparent, and glassy surfaces. One of the issues you'll come across when rendering is the time it takes to render a scene. Now, when you're tweaking the way a scene looks, you're going to be doing a lot of renders. You're going to adjust a light, for example, and then render. You're going to adjust a texture, and then you're going to render. And those renders tend to add up, and they can really make your day a very long day. Maya has a tool that can really help you with this iterative process, and it's called IPR, or the Interactive Photorealistic Renderer. Let me show you how this works. We've got a file here called redwagon_IPR.mb, and it's just the red wagon with a few lights in it. So let's go ahead and just do a standard render. So if I do this render, I can, render the scene, change parameters, and then I have to render again. This scene renders fairly quickly, but if you start getting into things that take a while to render, this can start to add up. We can change this by using the IPR renderer. So let me show you. There's a couple of places we can get to it. One is if we go into our rendering palette here, we can go render. We have IPR render. I always go here, which is just the IPR render button. And what that does is it just renders the scene, but it stores a lot of the parameters for the scene on the disk. And so that way you can just left click and drag and draw a box around all the things you want to change. So for example, if I select this wheel, I can go into the attribute editor here and change the color of the wheel. So for example, if I want to make it white wheels, you can see how the wheels actually change color not only in the viewport, but also in that final render. We can also do other sorts of things. We can also change lighting. So let me go ahead and close this, and let's go ahead and zoom out here, and let's find a light. There's actually a light here, if you can see it. Let me zoom in. There's a spotlight right here. It's called Spotlight 1. And if I do another IPR, I can change some of these spotlight parameters. So all I have to do is draw a box around what I want to see, and then I can change, for example, the shadow color, and I can just see how that changes in the scene. I can also change light color. So I could take the color of the light, make it a red light, a blue light, whatever I want. I can change the intensity of the light, and this all reflects in this IPR. I can also change the cone angle of the light. I can actually bring the light in. I can change the penumbra angle of my light, and I can see exactly how this is affecting the scene. In fact, if I wanted to, I could even move the light. So if I go into this viewport here, I can move the light, and it'll change in IPR. Now, there are some things that don't come through. One of the more important things is some of the shadow parameters. So for example, here, let me go ahead up to this light and turn it back down here. I'm going to turn it back down to say 1.1, so we have a little bit more shadow that we can see. But let's go down to depth map shadows. Now, one of the things we can do is we can certainly change the shadow color, but shadow resolution is one of the things that cannot be changed in IPR, and there's a whole list of things that it will and will not do. We can change the way the shadows are filtered, but we can't change the resolution. So if I brought this down to a low number, you wouldn't see that. But I can re-IPR this either by just clicking here, or if you're in your render view window, you have another IPR button. It does the exact same thing. And now you can see I've got a much grainier shadow. And I can certainly add my filter size here to that shadow and refilter. But I can't change the original resolution of that depth map. Okay, now that's just one of many parameters that don't work. There's a lot that do. So just go ahead and play with IPR, and especially if you're doing some final rendering, it can really help to speed your process along. Up until this point, we've been rendering single images, but Maya is an animation package, so we will have to render image sequences so we can render animation. So the best way to do this, or the easiest way to do this, is through Maya's own batch renderer. Let me show you how that works. I have a file open here. It's the file called Red Wagon Animated, and this actually has some animation in it. It has a wagon kind of going through the scene here. In order to set up batch rendering, first of all, we have to do some stuff in the render settings window. So I can go to either window, rendering editor, render settings, or I can hit this little button here, which brings up render settings. Now, the best way to configure this is to just give it a file name and an extension. So for example, if I want it to be name_number extension, that's how it will name it. In fact, you can see here, the file name, it goes from and to. So I'm going to animate, in this case, start frame is 1, end frame is 10. So I'm going to animate the first 10 frames. This particular sequence is 24 frames long, so I can certainly type that number in here. Frame range, this just tells you what you're rendering. And here it'll tell you my first file name is the file name prefix, which is the name of my scene. Red Wagon Animated 1 through 24. If I want, I can certainly change that name by just typing in whatever I want. I can change the image format. Let's go ahead and render these just to JPEGs, just to make them small files. And then also, I've got here what's called frame padding. So if you notice, we've got Red Wagon Animated 1 through 24, but a lot of times you want leading zeros on those numbers, so that way they organize for other types of compositing packages and so on. Now, the best way to render animation in Maya is to use image sequences. Now, this gives you a couple of benefits. One is if for some reason the render fails in the middle of the render and you've got, 100 frames rendered, you still have those frames on the disk. But if you are rendering to something like a QuickTime or an AVI and it fails in the middle of the render, you have to go back to the very beginning and render those first 100 frames all over again. So it's much safer to render in image sequences, and that's kind of how Maya is set up. The other benefit for rendering image sequences is that you can distribute those images across multiple machines. So for example, if you're doing batch rendering, you can have machine 1 render the first third, machine 2 the second third, or whatever. You can certainly distribute the load among multiple machines, which you can't do again if you're rendering QuickTimes or AVIs. So we're setting this to JPEG, and we've got our scene name set. And then batch render is actually very simple. All you have is a option here that says batch render. We can certainly look at the options here. And there's really only one option. Do you want to use all the available processors in your machine? And that means if you have a dual core or quad core or multi-processor system, do you want all of those processors rendering, or do you want to specify how many processors to use? So you could actually background render on one processor while you continue to animate on the other, so you don't completely load down your system with rendering. In this case, we're just going to render with all processors, and we're just going to do batch render and close. And then your status of your rendering is going to come up here in the bottom right-hand corner. It's going to say result rendering with Maya software. And then once it gets going, it's going to start rendering fairly quickly. In this case, I have a fairly fast machine, so I rendered 24 frames in fractions of a second each. And now once I've got those done, I can certainly look at those files. So probably the easiest way to do it is to go View Image from the File menu. And let's make sure we're in our rendering project. We will find those rendered images in the images directory of our project, and here they all are. Now, if we want, we can also view an image sequence. So again, I can just go into my rendering project and go ahead and load up just the first one, and then it'll go ahead and automatically pick up that sequence, and then you can see how that renders. So those are the basics of batch rendering. Now, for those who have really intense rendering applications, there are third-party rendering managers for Maya. Maya doesn't include a third-party rendering manager on its own, so you do have to go outside of the original package. The one that I use a lot is called Smedge, but there are a number of other ones out there, and they can actually manage multiple machines and distribute the load amongst a number of different machines. So those are the basics of batch rendering in Maya. Now let's take what we've learned about lighting and rendering and go ahead and light and render a scene. We have a scene out here called toyshelf.mb, and this has the robot and the car and a few other things that we've created. And let's go ahead and pull them all together into a scene. Now, when I start rendering a scene, I take it one light at a time. I usually start with the main light and then add another secondary modeling light and make sure they're balanced and then fill in with additional light. Now, remember that every time you add a light, you are going to increase the brightness of the scene. We've got to be careful when we add lights not to overexpose our shot. So let's go ahead and start lighting this scene. I'm going to start by creating a main light that kind of simulates the light coming in from a window. So I'm going to go out into my scene here and just create a spotlight. And then I'm going to move that light out. Now, in order to see what this light is doing, I can go use all lights, and then also I'm going to turn on high quality rendering in my Camera One viewport. Now, as I pull out, you can see that this spotlight is starting to illuminate the scene. But I want this spotlight to simulate a window. Now, what I've done is I've actually created in Photoshop a very simple texture called window.jpg. So let's go ahead and attach this to our light source. I'm going to go into my Spotlight's attribute editor. And in the color channel for that light, I'm going to place that bitmap. So I'm just going to click here, create a render node, File, and in that file, I'm going to select window.jpg in our 07 rendering directory. When I do that, you can see in this camera viewport how the light is affecting the scene. So all I have to do is now position this light. I can go into my top viewport or wherever and just start positioning that. Now I'm going to use the manipulator, so I'm going to actually put a target here somewhere in that scene, and then I'm going to make the light come up and maybe a little bit from the left, and then just pull that light out until I've got it pretty much where I want. Now, another thing I can do is if I don't want to pull that light too far back, you can affect the angle. So if I go to my attribute editor, I can certainly bring up the cone angle of that light a little bit, and then just use that to affect where that light is coming from, and also affect the size of that pattern on the wall. Now that I have this, I can certainly do a quick render by clicking on the Camera One viewport and just doing a render. You can see I got this nice highlight here, but this isn't fully lit. This just looks like it's light coming from one direction. I need to make this look more like daylight, so I need to fill this in. Now, one thing also is that I'm rendering right now at 640 by 480. It's probably going to be a lot easier and a lot faster if I render smaller. So I'm going to go into my render settings window, go down here, and let's just do 400 by 300 in the image size, just so that we have a smaller amount to render, and so things will go a lot more quickly. Now I'm going to go ahead and fill this light in a little bit more. Let's create a spotlight. And this light I'm going to put up above. So I'm actually going to light from the top and make sure that that's basically my modeling light here. So this is actually going to give me the light I need from the top. Now again, I can adjust the penumbra angle if I want to, and the cone angle. Now look here at the top corner, I really want that cone to be outside of the field of view. As long as it's outside of there, it's going to look a lot better. Now I can certainly do a quick render here. Much better, it's a little bit brighter. There's a couple of things missing. One is shadows. So let's go ahead and turn on shadows for both of these lights. So I'm going to keep my Spotlight 2 selected and just use some depth map shadows. And I'm going to ramp up the filter size just a little bit. And also, I don't like black shadows. So I'm going to go ahead and just make the shadows a little bit grayer, like kind of a darker gray. Do a quick render on that to see how they look. I could also be using IPR here. That looks good, but also I want a shadow from the window, obviously. So I'm going to select that light that's creating the window, which is Spotlight 1. And again, I'm going to use depth map shadows, but I don't want this to be the main shadow, because if I render this, you're going to see I'm going to get a really big black shadow here, and that's not going to look all that good. So let's go ahead and just moderate this shadow a little bit. I'm going to make it obviously grayer, but another thing I'm going to do is I'm going to turn down the resolution a lot to 128, and then I'm going to filter it like at about 4, and that'll really blur out that shadow and make it a lot less apparent. So now I've got a much softer shadow on the wall and a much harder shadow underneath. So that gives me a much more direct shadowing. Now still, if I take a look at this rendered scene, you'll see that along the side here, he's still really dark. In fact, it's really dark coming from the side. And we really want to brighten that up. Now we're getting to the point where we have 2 lights in the scene. So any additional light we add is probably going to start overexposing it. But I'm still going to add a light. I'm going to add a point light this time, because I really don't need to cast shadows, and I just want a general light. So I create a point light. Now notice how that creates this light in the room. In fact, if I want to, you can see how when I move it over, it totally illuminates the sides. All I have to do is take this light, move it over a bit. In fact, and maybe move it just a little bit forward. Just keep it off to the side though. Now what I've got here though is I've got a lot of light in the scene now. I've got 3 lights in the scene. They're all at the intensity of 1, which is actually pretty strong. So I have to kind of bring that light down. So I'm going to keep this point light selected. And one thing that I can do is just dial down that intensity. That would work pretty good. But I really want to give a little more pop to this. So I'm actually going to change the color. I'm going to click here, and let's go ahead and change the color to almost like a dark bluish purple. And that'll kind of give almost the impression of shadow. In fact, look here. If I were to amp this up, you could see how that kind of gives almost the impression of a shadow, but it's also in color, and that gives it a little bit more pop on the side there. And it also helps the front of this car as well. Now I can, again, just play with the intensity of this. I can bring the intensity down, or the other thing I can do is that if I make the color closer to white, the intensity is going to come up. So watch how this works, that as this light goes closer to white, you're getting more illumination on the side. I can also intensify it, and that will also increase the intensity. So it's really a balance between the actual color of the light, and the darker the color, the darker the light, and then the intensity, which kind of is like an overall volume control. So let's just go ahead and get those balanced out the way that I want them, and then just do a quick render. Now this is looking pretty good. I mean, I don't have complete darkness on this side, but I still have a lot of darkness underneath here, especially underneath this ball. I can affect that by doing 2 things. The first thing I can do is actually add ambient light to the scene, which gives an overall wash of light. So let's go ahead and do that. I'm going to go ahead and create what's called an ambient light. In fact, we can do create lights, ambient light. Now when I do that, again, I'm adding light to the scene, so I have to be careful with this light. Now the one thing about ambient light is that it's really not all that directional. It's kind of a wash of light over the scene. So I really don't have to move that light around a lot. All I have to do is affect the intensity. So what I need to do here is just dial down that intensity a lot, maybe at about 0.15. And what that will do is just give just a general bottom floor of where the lighting will be in the scene. Now when I do that, you're going to see that, okay, yeah, I've got a little bit less darkness underneath this sphere, but I'm getting a lot of hotness right here in the top left corner. And that's because I've got a lot of light in the scene. Now what I can do is actually just start dialing down lights. I've got a lot of light in the scene. I need to start kind of bringing down the overall volume of these lights. So what I can do is actually take the first light that we put in, the spotlight, and go into the attribute editor and go up to the intensity and start playing with that, because I want to reduce that hotness. Now, if you can see how if I dial that up, you're going to get way too hot. If I bring it down, you can see how now it's going to be a little bit more balanced and a little bit more realistic. You have to think almost like a photographer. You don't want to overexpose the shot. You also want to guide the light and the eye so that everything is balanced. Now that's looking pretty good. Now there's another thing we can do, and that's actually add in some ambient color underneath here. Again, this is still kind of dark. Now, if I wanted to, I could still work with lighting, but you don't have to fix everything with lights in Maya. So if I select this sphere, I can actually go to the material applied to the sphere and actually change the ambient color. Let me show you how this works. If I click on ambient color, you can see how, in fact, just look how it's affected in the viewport. If I turn this way up, you'll see that it starts to glow. What this ambient color is it's the darkest color this object will ever be. So what I can do is I can dial that into something like a darker blue and watch what happens when we render. With a darker blue, you see that this doesn't completely go to black. So it gives it more of an impression of ambient light. Now this is probably a little too bright, so I'm going to dial that down just a little bit more. And you can see how this kind of brightens up the sphere so that it doesn't look so dark. Now, another thing we can do is we can start turning on stuff like ray tracing. Now that we have kind of a good light balance, let's go ahead and turn on our ray tracing in our Maya software renderer. I go to the render settings window, go to the Maya software tab, and just turn on ray tracing. Now, I have this set at production quality. And then let's do another render. Now, this render will take a little bit longer. Now, as you can see, when I've added in ray tracing, you've got the scene is now starting to reflect all of the light that's in the scene. And it's actually brightening up the scene. So now we have to kind of go through our scene a little bit and tweak some of that lighting. Now you can see I actually feel like it's almost a little overexposed. So one of the things we can probably do is just dial down some of these lights a little bit more. So I'm going to take this above light, Spotlight 2, and just kind of drop it down maybe to 0.9 or 0.8. And then maybe even take this light off to the side and drop that down a little bit. Now, again, I've already done this scene once, so I kind of know what I'm doing. But again, you're just going to play with this a light at a time and just kind of start giving an overall volume. Now, this is a little bit better. Now, I'm going to stop here with the lighting. Well, the last thing I want to do is give a little bit more focus to the scene. So let's go ahead and do some depth of field and focus in on the robot and make sure that he's the center of the scene. So I'm going to go ahead and select my camera attribute editor, and I'm going to go down to the depth of field tab, and I'm just going to turn it on. And then I'm going to render. And when I render that, it's blurred because down here my focus distance is off. So let's go ahead and on our heads-up display, turn on object details. And I'm just going to select my robot's body, and I know that his distance from the camera is 58.5. So now I select my camera attribute editor. In my focus distance, I type in 58.5. Then I do a render. Well, that looks pretty good. He's in focus, but everything else is kind of in focus, so I need more depth of field. I can do that by just turning down this f-stop. Let's make it f1.4, and again, just do a quick render. Much better. So now he's in focus. The other stuff is slightly blurred. It looks a lot better. Now, this is where I'm going to stop, but you can see that lighting in Maya involves you building light. You take the main lights and then continue to add lighting until you get the effect you want. Now remember, when you do add stuff like ray tracing, it will start to bounce light around the room and brighten the whole scene. So you need to make sure that all of your lights balance, and then you also check it against your ray tracing and everything else that you're putting into the scene. So as you light, just remember that you're lighting for mood, you're lighting to highlight specific objects in the scene, and you're lighting to tell a story. So remember that as you light your scenes within Maya. Now let's take a look at the Mental Ray renderer. This is one of the additional renderers that Maya has, and it's probably one of the more popular renderers because it has a lot of really great features that allow for soft lighting and much more realistic rendering. In fact, I have a scene loaded up here called Deco Car, and this has some of those effects in it. In fact, if we want to, we can just render it. We can go to our render settings window and make sure we have Mental Ray loaded. Now, before we render, I want to make sure that you have Mental Ray loaded. If you don't, sometimes you have to go into what's called the plugin manager. So if you go Window, Settings, Preferences, Plugin Manager, this is where you can actually make Mental Ray available if it isn't. Scroll down and look for Maya to MR.mll and make sure that that's loaded. And if you want, you can also check auto load so that it loads every time you open Maya. Now, once you do that, Mental Ray will show up. We have our Maya software renderer and Mental Ray as well. In fact, let's go ahead and render this in the Maya software renderer. So we go here, I'm going to just click on that window and just do a quick render. As you can see, we've got a scene that doesn't really look all that great because some of these materials don't actually render in Maya. So when I render in the Maya software renderer, you notice some of these surfaces aren't even showing up. And that's because some of these are actually textured and shaded using Mental Ray specific shaders, okay? So when we go into Mental Ray and make that our default renderer, we can just do a quick render of the scene. And now everything shows up. And you notice how we have a really soft lighting model to this. Also notice how on this surface, which didn't render in the Maya software renderer, we have what's called car paint, which is a really nice material that allows for stuff like metal flakes and, clear coating and all that sort of stuff. So we get a really high quality rendered surface as well as high quality reflections and all that. Now, Mental Ray is actually just a selection in our render settings window. It has the same common parameters as the Maya software renderer, but we also have a bunch of additional tabs. One here is for render passes. The other one is for features. Now, these are all the different types of features that Mental Ray can do, and we'll get to these as we work through Mental Ray. The next one is the quality settings. In fact, if we want, you can go to production quality, which is kind of the default quality. And the next one is called indirect lighting. Now, what this does is this allows us to turn on different things that give us much higher quality rendering. So, for example, if I turned on Final Gathering and did a render, now this may take a little while. Now, when you turn on Final Gathering, what it does is it actually computes secondary or bounce lighting. This gives you a much more realistic effect. So, for example, in this case, the sky is providing additional light, and we can calculate that with Final Gathering. We also have what's called caustics and global illumination, which are two additional ways to create indirect lighting. And then we also have a lot of different sort of options here, especially for what sort of preview we want. So those are some of the basics of how to get into Mental Ray. Now, one thing about Mental Ray is that it will render almost anything that you can render in the Maya software renderer. So you can take a scene that you've created in Maya and just switch it over to Mental Ray, and generally it will render in Mental Ray. So let's go ahead and get into some of the additional features of Mental Ray and show you how to use it. One of the big differences between Mental Ray and the Maya software renderer are the amount of materials available. Mental Ray has a lot more built-in materials and a lot more different surface types. In that way, it can make creating interesting surfaces a lot easier. Now, you can get to these surfaces by going to the rendering menu. And under lighting shading, if we go under assign new material, you'll see them here. If you go up to the top, these are all the standard ones for the Maya software renderers, such as the Blinn and the Lambert. But if we go all the way down, you'll see in this section a whole bunch of different shaders that you can use with Maya. Now, we're not going to go through all of these, but let's go through a few. We've actually have a scene open here. It's called mrmaterials.mb. In fact, let me do a really quick little render here to see how that looks. Okay, so it's basically just a sphere with something in the background in a room. Now, this is actually set up for Mental Ray. So let's make sure you render this in Mental Ray. Now, all of these surfaces here are just standard blends. Now, we're going to add new materials to the sphere to see how that looks. So let's go into lighting shading and let's go assign new material. And let's scroll down and find car paint phenomenon and just assign that to the sphere. When we do that, our attribute editor comes up and we can go over to this tab and start playing with the parameters. In fact, if I want to, I can just do a really quick render here to see what this looks like. You can see this gives a really nice kind of candy sparkle effect. It's actually kind of like a car paint. It's like hot rod paint or whatever you want to call it. Now, you can actually change a lot of different parameters with this. As I change these, you can look at the sample and see how this works. One is the ambient color. Now, that is just like the ambient in any of the Maya software render ones. It's kind of like the default, the lowest dark that you can get in this color. So you could certainly change this to whatever color you want, maybe even like a dark kind of violet there. Base color, now that's the color of the car itself. But also notice we have additional colors here. We have what's called an edge color. So if you look at this, you can see how you could actually make the edge of the object a different color. So this can kind of almost simulate the type of paint where you have one color coated over the other and it looks different from different directions. So for example, I can make the edge color maybe like even a green or something like that. Then we also have the lit color where the light is directly applied to the surface, and we can change that as well. And we can see how this looks by just doing a quick render. So you can see I've changed a lot of those surfaces and I'm getting some really interesting effects here. Now, if you go down to the bottom, we also have what are called specular parameters. And one thing I really like is you have basically metal flakes that you can put into there. So we can change the color of the flakes. We can also change the scale of the flakes. Well, let's just go ahead and render it with the regular flakes and you can kind of see how those look. But if you want to, you could actually scale those flakes up and you can kind of see how they would normally look. So if I bring that up to say 0.5, and maybe even zoom in a little bit so I can see these. So that's one of these materials. Let's go ahead and take a look at some of these other ones. Yeah, another one is called metallic paint, and that is actually very similar to car paint. But the one that I really like here is called material. So when I click on that, it gives me a very glossy material. In fact, if I render this, you'll see it's just kind of almost like a glossy gray sphere. But what's really nice about this is that you can actually use this to create very realistic glassy effects with this material. If I go down to the refraction tab here, I can actually change the index of refraction, but more importantly, I can change the transparency. So if I dial up the transparency a lot, change the index of refraction, do another render, you'll start to see some glassy effects. Now, if I bring that index of refraction down below 1, you're going to see something even a little bit better. So you can see how this gives a really nice glass effect. I really like this for transparent, semi-transparent surfaces. And of course, you can certainly change the color and make it kind of a piece of colored glass if you want. So for example, if I made that blue, you would have kind of a bluish glass there that's kind of refracting. And also notice it refracts well in the shadows. Now, the next one I want to show you, and I think this will be the last one I'll show you in this lesson, is the skin shader. Now, what the skin shader does is it actually creates a skin color, almost like for the skin of a character. And it also gives what's called subsurface scattering, which means that it actually gives almost like that iridescent glow. So if a light is coming from behind a character, you'll see a slight transparency and a slight bouncing of the light underneath the skin. So let me just do a quick render of this. And you can see this gives you a nice kind of smooth skin color. You can certainly change the colors of these by going through the scatter color. You can also add in a bump shader for bumpy skin, which you'd probably want to do as a texture map. And so these are some of the basic materials of Mental Ray. And you can see how you can go a lot further just with some of these standard Mental Ray materials than you can in the Maya software renderer. So this is just one of many reasons why you'd want to use Mental Ray. Another advantage of Mental Ray is that it has some additional shadowing and lighting options. So let me show you some of those. Now, Mental Ray has indirect lighting, which is a completely different subject here. Let's just look at the difference between the standard lights that Mental Ray has. I have a scene here called mrlights.mb, and it's just a simple scene with two primitives and a light. Now, what I can do is I can certainly just render this, and you'll see we have, a nice scene, but there are no shadows. Let me show you how Mental Ray works with shadows. Let's make sure that we're set to render in Mental Ray. And then I'm going to select this light, and let's just bring up this camera view. So I'm going to go into the attribute editor for that Spotlight 1, and let's go through some of the shadowing options. First of all, you can use the standard Maya shadows. You can use depth map shadows, and those will render, as you can see. We also can use ray trace shadows. So if I go down here to ray trace shadow attributes and turn those on, you can render those as well. And you see you get that kind of standard ray trace hard shadow, but it still works, and it will work with transparent objects as well. Now, if we go all the way down here, you'll see there's a Mental Ray tab. And under that Mental Ray tab, you have a couple of sub-tabs here: Area Light, Global Illumination, and Shadows. Open up Shadows, and you'll see we have a third way to calculate shadows, and that's using the Mental Ray shadow map. So if we turn this on, you'll see we have some parameters. One is the resolution of the map. This is very similar to what we have with depth map shadows in Maya. We also have a number of samples and a softness. Let's just leave these at these defaults here and do a quick render. Now what we're seeing here is we're seeing a little bit of this jaggy edge. That's because we have a bitmap of 256 and it's not being softened at all. So I can soften this by just adding a softness parameter here. Now this parameter is actually pretty touchy, so you have to use kind of low numbers here. So I'm putting in 0.1 for softness, and let's just do another render. And you can see now we have a softer shadow, but we're also kind of getting this breaking up of the shadow. We're kind of getting this pixelation here around the edges. Now we can solve that by upping the number of samples. So for example, if I bring that up to 8 and render, you'll see that it's a little bit softer. And what this does is it just uses more and more samples to smooth that out. So let's bring it up to a much larger number. Let's bring it up to 64 and do another render. And there we have a really nice smooth shadow. Now, if I want, I can certainly play with the softness. For example, I can put this down to 0.025 and give a much softer edge to the shadow and still have that high sample rate. So you have kind of a nice softer edge there. Now let's go up and look at one more difference, and that's in the way we do area lights. Now I'm going to go back out to my 4 view here and select this light. Let's take a look at what this light looks like. It's a cone, it's a spotlight. Now, when I turn on area light here, watch what happens. A little rectangle gets put at the back of that spotlight. Now, what I can do here is I can actually change the type of area light we have. I can change it to a disc. Now, see how that changes there. We have a sphere, cylinder, which would be like a tube or something like that. And we also have a user defined. I'm going to leave it at rectangle and leave this at the default of sample rate. Let's just do a quick little render with an area light. Now notice it takes a little bit longer to render because what this is doing is it's actually creating 3 times 3 light sources. So 3 times 3 is 9. It creates 9 lights and scatters them about that rectangle to create the light source. So right now we have slightly softer lighting, but not as soft as we would like. We can increase that softness by increasing the area that the light is emitted from. So I can do that by selecting the light and just scaling by hitting R and scaling it up. So I'm actually going to scale it up quite a bit. And let's just see what happens. So I'm going to go into my camera viewport and just render that again. What happens is you see that, yeah, the light is softer, but I'm getting a graininess. Well, we can fix that by adding in more lights or adding in more samples. So, for example, if I bring it up to 5 by 5, that makes 5 times 5, it puts in 25 lights. 25 light sources, or essentially 25 sample points. And it gives us a bit of a softer lighting, but maybe we still have a little bit of that graininess. I can certainly scale up the light a little bit more if I want. And let's go ahead and make this 8 by 8 to give it 64 samples and see how that works. Now, this will take a little bit longer to render because you have more samples, more light sources, more stuff to calculate. Okay, so now we can see how this area light is actually creating a softer look to the scene. But realize how this area light can jack up render times a lot. So there are other ways to create that sort of soft lighting, which we will get to in the next few lessons. But let me show you one more little tab here. That additional soft lighting comes from what are called caustics and global illumination. And what each light can do is it can do what's called emitting photons, which is a secondary light source which is used to calculate indirect lighting. Now, we're not going to get into that right now, but I just wanted to show you that this is here. So those are some of the basic differences of lights between Mental Ray and Maya. So get used to that, especially if you're going to be using Mental Ray a lot. Now let's take a look at depth of field. As with a lot of the other aspects of Mental Ray rendering, you can use a lot of the basic Maya presets. So let's just do a real quick depth of field like we've done in the Maya software renderer. In fact, let's just go ahead and render this first. I have a file called mrdof.mb, and I'm just going to open it and render. And you see we just have a line of objects here. So let's go ahead and do some depth of field on this. So we're going to do basically the same method we've done before. We're going to turn on our heads-up display, select the object we want in focus, and we note the difference is 15.096. Then we go to our camera attribute editor, and we scroll down to depth of field. Now remember, we're using Mental Ray here, not the Maya software renderer. And then we type that number in. So it's close to 15, so we can certainly do that. And let's keep the default at 5.6 for the f-stop, and let's just do a quick render. So you can see we're getting depth of field. And just like with the Maya software renderer, we can certainly increase the f-stop to increase the depth of field. Now, one thing you'll notice in Maya, this is something that happens a lot, is that as it starts blurring, you see a lot of kind of speckly kind of stuff going on in the background. This is caused by the way Mental Ray anti-aliases. So if we go to the render settings window, we've got to make sure we have Mental Ray selected, and we go over here to quality. Now, when we do production quality, it says the maximum sample level is 2. If we turn this up, it will start to get rid of that. So I'm going to turn it up to 3, and we'll see what happens. Of course, the more you turn it up, the more time it takes to render. Okay, so you can see that's smoothed out a bit. If we want to bring it up one more, we can do that as well. Now, this will take even longer to render, but let's take a look at this. So now you can see how when I've turned up this maximum sample level, it's certainly smoothed this out, but it really brought the render times up. So for now, I'm just going to bring this back down to the standard level of 2. But I just wanted to show you how to get rid of that sort of stuff. Now we've used the regular Maya method for doing depth of field, and that works just fine. But let's go ahead and look at another way of doing depth of field. So I'm going to go back into my camera attribute editor, and I'm just going to switch off depth of field. Now I'm going to go up here to the Mental Ray tab, and we're going to do depth of field completely differently. We're going to use what's called a lens shader. Now, a lens shader is essentially a way to affect the way that the camera takes a picture. Now, Mental Ray uses shaders for a lot of different things, but I'm just going to show you the lens shader just to kind of give you a taste of some of the stuff that Mental Ray can do. So if I click on this, it says Create Render Node. It brings us over to the Mental Ray tab. If we go up to the top, you've got all of the materials, and we scroll down, we have stuff like volumetric, all this other stuff, and we want to scroll all the way down till we get to lenses. Now we have a bunch of different types of lenses here. We have one for bokeh, which is another form of depth of field. We also have all sorts of other ones. The one I want to look at is called Physical Lens DOF. Just click on that, and it brings up some more parameters that we can use to do depth of field. Now, in this case, the parameters are the plane. Now, this is a negative number, okay? But this is the distance from the camera that it's going to focus on. It's the exact same number we would use here, which is 15. So when I select my camera attribute editor, make sure I know that number is 15, go down to my Mental Ray tab, and then just go down to that node, which is my depth of field node. So I just type in negative 15. The radius is how much does it blur. So when I go ahead and render with just negative 15 and that radius, you'll see I get a pretty good depth of field. But it's not a lot. So if I want to, I can certainly amp up this radius. If I bring it up to say 0.25 and render, you'll see a little bit of a difference. You'll see it's getting a little bit blurrier. If I want to bring it up to, say, a bigger number, say 0.75, you'll see a much bigger difference. So as you can see, this is just another method for calculating depth of field. Now, I find that the Mental Ray parameters are sometimes a lot more accurate than the ones coming from the Maya software renderer, but you can pick and choose whichever one you feel most comfortable with. Now let's take a look at motion blur in Mental Ray. We have a file called mrmotionblur.mb open, and There are a few differences in the way that Mental Ray handles motion blur. Mental Ray is a little bit better. One of the ways is that it actually motion blurs shadows. So actually, let's take this file and let's just do a quick render. I'm going to go into the Maya software renderer, make sure I have ray tracing turned on, and also make sure that motion blur is turned on. And actually, I'm going to turn on 3D motion blur. So ray tracing and 3D motion blur. And let's just do a quick render. So this is a simple scene. In fact, if we want to, we could even turn on a little higher quality. Let's do production quality so we can see this a little bit better. So when we do motion blur in Maya, one thing that doesn't get motion blurred are the shadows. Now this is going to be very important because if something's moving like this, the shadow is also going to motion blur. So what you have to do is you either have to kind of fake motion blur the shadow by doing like a depth map shadow and just making sure it's got a nice soft edge. But something with a hard edge like this ray trace shadow isn't going to motion blur. So let's go into Mental Ray and let's show you how motion blur works for that. Now in Mental Ray, motion blur pretty much works the same as it does in the Maya software renderer. We go over to the quality tab here and we scroll down and we find the motion blur rollout here. There it is. There's actually two types of motion blur, and these are very similar to what we have in the Maya software renderer. We have one called no deformation. Now what this is for is it actually is for solid objects that aren't changing shape. And we have another one called full. And what this will do is this will actually motion blur something that is changing in shape. So for example, if you have a character that's moving and its mesh is changing shape, it will actually motion blur all of that. So we can use one or the other, and actually no deformation is actually a little bit faster. So here we have some parameters here. One is called motion blur by, and this is just a multiplier to either increase or decrease the overall effect. Then we have shutter open and shutter close. Obviously, when the shutter is open and closed at maximum, you're going to get maximum motion blur. Bring either of these down and your motion blur will shorten. We also have what's called motion steps and time samples. Now these create the quality of the motion blur that you have. Now also let's go up to quality here. Let's just make sure that we're in production. And let's go ahead and return on no deformation. Let's just do a quick render here. So now we have this rendered. You can see that it's got a nice motion blur going on here. And also, if you look at the leading edge of these shadows, the shadows are also motion blurred, which is kind of nice. Now, if we want to, we can increase the quality of this by increasing the number of time samples. Sample the motion blur over a given frame. So the more samples, the better the quality. The more samples, the longer the render. So you have to kind of balance it. Time samples to 8. Let's see what happens. Okay, so you can see that's a lot less grainy when we do that. Now, the other type of motion blur is called full, which will motion blur things that are deforming. In this case, we don't have to do that, but if you have an object that is changing shape, particularly in character animation, you do want to turn that on. So those are some of the basics of motion blur in Mental Ray. One of the best reasons to use Mental Ray is to use indirect lighting. Now, indirect lighting is a realistic type of lighting where you have bounce lighting between the objects in the scene. Now, this is something you really can't get in the Maya software renderer. So Mental Ray really exceeds in this kind of soft, realistic lighting. Now, there are a number of methods for doing this. Let me show you the first one, which is called global illumination. Now, I have a scene here called mrglobalillum.mb. It's a very simple file. It has a sphere inside of a box, and it's set on a plane. Now, all I have in the scene is one spotlight. In fact, let's go ahead and just do a quick render. I'm going to go ahead and make sure I have Mental Ray turned on, and then do a quick render. Now, what you'll see in this file is that we've got the light set so it casts a very harsh shadow from the corner of the box. And so you really can't see inside that box at all. And now in the real world, what would happen would be some of this light from the floor and the side of the box would bounce up and kind of give a little bit of a soft cast inside the box to kind of illuminate the box. We can do that using global illumination. So I select my light called Spotlight. I go into the attribute editor. Now, global illumination is turned on in two places. You have to turn it on in the light. You also have to turn it on in the mental ray render settings. So first of all, let's start with the light. When we go over to the light, you'll see that we have our mental ray tab. If we scroll down, there's some of these that we've already used, like shadows and area light. But the one I want to go to is called caustic and global illumination. And what we can do here is we can emit photons. When I turn that on, what it does is it emits a secondary light source. It will illuminate the scene as normal, and then it will go back and re-illuminate the scene using these photons. And these photons actually bounce around the scene and create this secondary global illumination. Now, once I have it turned on here in the light, I still need to tell the renderer to go ahead and render the global illumination. So I go into my render settings window and go over to the indirect lighting tab. And all I have to do is turn on global illumination, and I'm going to just leave it at the defaults. And then I'm just going to go ahead and close this. Now I'll highlight my camera 1 window and just do a quick render. Now rendering will take longer with global illumination turned on, so be prepared to wait a little bit. Now, as you can see, it's maybe doing something, but we're really not getting much of an effect with the defaults. I'm going to close this and reselect that light. Now let's go ahead and take a look at what some of these values do. First of all, we have these photons, which again are emitting secondary light into the scene. So we need to brighten up this secondary light. We have what's called the photon color, which is the color of this light. We have the intensity, which is how bright is that secondary light source. And third is the exponent. Now the exponent is a fall-off value, so the further away from the light you get, the less intense the photons. Now typically you want to leave this at an exponent of 2, which means that it follows the inverse square law, which means it follows real-world physics. If you increase the exponent, the light will fall off quicker. If you decrease it, the light will fall off slower. So for us, the best thing to do is just to increase the photon intensity. I like keeping this exponent to 2 because, well, we're trying to create realism. So let's go ahead and keep the exponent at a realistic value. So when I increase the photon intensity, I just need to find a number that works for this particular scene. Every scene is going to be different, and so your distance from the light will also be different. So I'm just going to go ahead and select my camera and render it with a photon intensity of 80,000 instead of 8,000. Now, when I do that, you can see we're getting a little bit of an effect here. It's not completely dark inside this box. We're getting a little bit of a highlight on the roof of the box and a little bit down here and over here. Now, if I want to, I can continue to increase this photon intensity. In fact, let's just make it a really big number. Let's make it 250,000, and then just do another render. Now you can really see inside this box because what we've done is we've actually just increased the photon intensity. And this, in effect, increases the ambient bouncy light in the scene. Now let me show you something else so you can see exactly how this works. What we could do is we could actually turn the intensity of this light down to 0. So my initial illuminating light is going to be 0, but my photons will still be there. If I render this, what you'll see is the effect of just the photons. So what Maya does is it illuminates the scene, and then it re-illuminates it, and it creates basically 2 scenes. It creates this one and the original one, which was just the light in the scene, and then it mixes the 2 to create the actual lighting. I'm going to put this intensity back to 1, and let's go ahead and do one more thing with this photons. We have one more value that I haven't explained here, and that's the number of global illumination photons. If you can take a look at this, you can see some of these little circles here. And what this number of global illumination photons does is it creates a level of accuracy. So for example, if I brought this down to a very low number, let's say I brought this down to 50 and just made a very low number of photons in the scene, you'll actually see how this scene renders. Now, as you can see, we've got these little circles of light, and what these are photons. So what it does is it casts these big circles of light all over the scene, and then it mixes them. So the more photons we have, the more accurate the solution. Of course, again, as with anything, the more photons you have, the longer it takes to render. So you have to balance this. So let's go ahead and bring this photon intensity down to maybe 100,000, and let's keep the global illumination photons at 10,000 and just do a quick render again. So there you go. Now you've got a much more realistic render in the scene. With global illumination, you do have to kind of manage your resources. The big thing here is the number of photons and how many of those do you actually need to render this scene accurately. So you kind of have to just play with that value. And then, of course, the photon intensity is going to give you almost like a mixing value of how much do you want to mix this sort of light with the actual light in the scene. Now that you're going to have to do by eye, so there's no real method of creating an exact duplicate of what reality is. It's really what your eye tells you looks the most real. Okay, so let's go ahead and move on. Another way to get soft indirect lighting in Mental Ray is to use what's called Final Gather. Now this is a great way to create lights because what you can do is you can actually use objects in the scene to create light. Let me show you how this works. We've got a file here called MR Final Gather. It's just the car on a plane. Now I have the scene set up so there are no lights in the scene. Let's go ahead and make sure we're in Mental Ray. So I'm going to open up my render settings window. I'm going to leave that open and then just hit render. Now when I render, even though there are no lights in the scene, I still get an image. That's because in the render settings window, under the Common tab, if we go down here under Render Options, you'll see Enable Default Light. And now what this does is if there are no lights in the scene, Maya creates a light just so you can render. Well, we don't want that. So let's go ahead and turn that off, Enable Default Light. And let's just do another render. And we get lots and lots of black, which is exactly what we want because we're going to add a light in that's not really a light. So instead of creating a light here on the rendering tab, we're just going to actually create a surface. I'm just going to create a plane. So I'm just going to go here to Surfaces, create NURBS plane, just drag it out, and that's it. So all I have to do is just start to position this. I'm just going to turn this a little bit so that we can see it. And now in order for this to become a light, we need to have something that glows or illuminates the object's surface. We can do that with a particular type of shader called a surface shader. So I go into Lighting Shading, assign New Material, Surface Shader. Now what a surface shader does is it just shades the entire surface whatever color you give it and doesn't do any sort of shading. So if I create this out color as white, just kind of dial that up, then it becomes just a white plane. And if I render this, you'll see the plane, but you're not going to see the lighting until we do one more little trick here, and that's turn on Final Gather. Now before I do that, I actually do want to go out into my 4 view here and just take that plane and position it where I want it. In fact, here on panels, I want to make sure I'm in camera 1 and then just position that plane above the car so that can be the light source on the car. Now, I'm going to highlight my camera 1 viewport. Let's go to Render Settings and go over to Indirect Lighting. Scroll down to find the Final Gathering tab. Turn it on. Now again, select the camera 1 viewport and render. Now what you're getting is you're getting a little bit of light. You're not getting a whole bunch of light. You're just getting enough light. You can kind of see that, hey, maybe it is working. Now we can do one of 2 things. The first thing we can do is actually increase the size of this plane, because if it's bigger, it's going to actually cast more light. So if I do that, you may get a little bit more light in the scene. And yes, we are. We're kind of getting like a nice dim light. But we can't keep increasing the size of this forever. A better way to do this is to actually increase the intensity of the light emitted from that plane. We can do this by going over to this surface shader and increasing the value of this out color. But as you can see, it's already at the maximum. But we can actually make the maximum bigger just by clicking on this color tab and typing a new number into the value of this color. Right now it's at 1, which is normally the hottest color we can do. Well, we can actually make this even bigger just by typing in a bigger number. So for example, if we typed in, say, 8, that would make that now 8 rather than 1. And now this is 8 times the illumination. Now when I render, you see I'm actually getting a really nice soft lighting, and I'm getting a very cool little rendering model here. Now, the one thing is that we have reflections turned on the car, and so we can actually see our light source. Now, we may want that to happen, but we don't have to. So what we can do is actually select the NURBS plane that is our light source, go over to our NURBS plane shape here, and find the Render Stats tab. So what we're going to do is we're going to make this plane, this light source, not visible in reflections and not visible in refractions. When I do the render again, now I get the soft light without the visible light source. So you can use this for all sorts of things. Let's go ahead and do one more little thing. I'm going to go ahead and delete this plane, and we're going to do something a little bit more dramatic. I'm going to create a NURBS sphere around this car. And I'm going to move that sphere down a little bit. Now we're going to add a texture to this. We're actually going to add another surface shader, assign new material, surface shader, but this time for the out color, we can add in a file. So for example, I can add in my image. You can see here, if I go into O8 Mental Ray, under source images, I have one called sky. So once I have that sky, I can actually make the sky the illuminating source for this scene. In fact, let's go ahead and turn on hardware texturing so we can see how that sky is in there. Okay, now I don't have this completely mapped to the sphere, but let's just go ahead and take a quick render. You can see now the sky is illuminating this from all different directions, and it's actually reflected in the car. Now, if I want to, I can actually make this sky even brighter, doing almost the exact same technique that I did with this color. So I go into my sky texture node, and I scroll down to color balance, and again, I can take my color gain and make it more than one. So in this case, let's not go too far. Let's make it, say, 3 or 4. Now what I'm doing is I'm actually making this a little bit brighter, and this is actually a little too oversaturated here, so we can just turn this down a little bit. Now another thing you can do is you can combine this with a secondary light source. Part of the light's coming from the sky, and part of the light is coming from just a regular light in the scene. So you can mix and match these methods. So here I have a lot of the light coming from the sky. If I want to, I could, for example, add in a point light into the scene and move that light up and over, and maybe bring the intensity down just a little bit and see what that does. Now that'll probably give a little bit more of a pop in the scene. It'll definitely give a good, more overall lighting, but I'm still getting the lighting from the sky as well. So you can see I get a very nice, soft overall lighting. So I can keep my standard lighting, add in a little lighting from the sky, and I'm getting a much, much better rendering model. Final Gather actually renders fairly quickly, so this is actually a really nice way to do this sort of lighting. Now let's go over one more really nice feature of Mental Ray, and that's the ability to generate caustics. Now what caustics are the little bits of light that gets filtered through glass or reflected off of water or metal or something like that creates all of these little highlights. You can best see it under something like this, which is a martini glass or wine glass. And let me show you how to create that effect. We have a file here called martini01.mb. Now this is set to render within Mental Ray. So let's make sure we have Mental Ray set. And then let's just go ahead and do a quick render and see what we have. Now this is a martini glass with an olive in it, and it's on just a flat plane. Now the glass itself looks pretty good, but what we don't have are the shadows or the highlights that would be created when the light filters through the glass and the liquid in the glass. So we can do that by adding caustics to a light. Let's go out into the fore view of this, and you'll see that the scene has two lights. It has one light here, which is the general illumination, and then it has a highlight light here, which is called Spotlight 1. That's the one we're going to add caustics to. So first of all, let's go ahead and add in some ray trace shadows in this light here. Let's go ahead up here to ray trace shadow attributes and turn on use ray trace shadows. And then let's do a quick render. And as you can see, we've got a nice little shadow developing here from the light. Now, I still want to get the caustic highlights that would be coming from this glass when the light is filtering through. We can do that by turning on caustics. Now, this is very similar to the way that global illumination works. We have to turn on photons in the light and then turn on caustics in the render settings window. So I'm going to go down here to the mental ray tab and open up caustic and global illumination and turn on emit photons. Now let's go to the render settings window. I'm going to make sure I'm in the indirect lighting tab, and let's just turn on caustics. Now I don't want to go through all these parameters here. Let's just leave it at the default. Now select the camera 1 window and let's do a render. Now as you can see, there's really not much happening here. Again, just like with global illumination, we have the same situation. We have the photons, which actually create the caustic lighting. And the photon intensity is the intensity of that effect. Now, again, we have the exact same numbers here. We have the intensity of the photons as well as an exponent. So what I need to do here is start bringing up the intensity. Let's go ahead and bring it up to 100,000. Instead of 8,000, and then do another render. See what happens. Now you can start seeing the effect. You can see right here we have a little bit of a caustic illumination here coming from the light. If we want to, we can amp this up even more. In fact, let's bring it up way up. Let's bring it up to 500,000, and let's do another render. Now at 500,000, you can really see how the effect is taking place. Now this is probably too much. We're going to have to back it off to somewhere between 100 and 500,000. But as you can see, the light is now creating a caustic effect. It's also illuminating the liquid and the olive in the martini. So this is actually really nice. It gives us a really good effect here. So I'm going to bring this down to about 250,000, and let's see if we can get something a little bit in between those two. Now this looks a little bit better. Again, we have the caustic lighting, and we also have a little bit of illumination of the liquid in the glass. Now again, just as with global illumination, the number of photons will determine how the effect works. So for example, if I have this light selected, I can also up the number of caustic photons. Now more photons will increase the render times as well. Now as you can see, with 100,000 photons, the solution is a lot less grainy. It's a lot more accurate. So again, more photons is going to give you more accuracy. Now, I'm fine generally that caustics requires a lot more photons than global illumination to calculate accurately. But as you can see, you can get some incredibly realistic glass and reflective effects with caustics. Now, this can also be done for reflections, such as metal objects on a table, or, for example, the light reflecting off of water in a swimming pool, for example. So all of these effects can be created with caustics. Now let's take a look at Maya's paint effects. This is a really great way to create environments and naturalistic scenes because it allows you to paint things like trees and grass and flowers into a scene. It's very organic, really great way to populate a scene very quickly with organic stuff. In addition to doing things like trees and grass, paint effects can also do special effects and all sorts of other things. So let's just show you some of the basics. Let's just get our feet wet here in paint effects. We have a project that we need to set. Let's go ahead and set our project to 09 Paint Effects. And let's make sure we're in the file called road.mb. Now, this is a very simple scene. It has basically just two main objects here. It has a plane that is a ground plane, essentially. And we also have a sky. Now, we're going to go ahead and paint some foliage and grass onto this ground plane. So we can do that through the Paint Effects menu. If we're in our rendering menu options, we can go to Paint Effects and we have a ton of options here, okay? In addition to that, there is a Paint Effects shelf, which has most of these options and a number of brushes. So let's go ahead and start by selecting this ground plane. It's called NURBS Plane 1, and going to the Paint Effects menu here and going Make Paintable. Now what that does is it allows us to paint directly onto that NURBS surface. So in order to paint, we need to select what we want to paint. There's a nice little grass brush right here. And so if I select that, what happens is I can now just left click and drag onto the surface of that plane, and I can paint grass. So there we go. So now I have grass into that scene. Now this uses the Artisan interface, which is the same interface we use for 3D Paint, for sculpt surfaces, and a number of other things. So in order to change the size of the brush, all I have to do is that same keystroke B for brush, and if I left click and drag, I will make that brush bigger. And so then I can also paint the grass bigger. So if I wanted to make really big grass, I could certainly do that. So by changing the size of the brush, you're changing the scale of whatever it is you're painting. So now that I've painted some grass into the scene, I can do a quick render, and you'll see how this comes up. Notice how it renders the shadows, and you can see the grass is being rendered into this scene. Now, when you paint into a scene, let's go into our outliner and let's see what happens. When you paint into a scene, each stroke is a separate object. So every time I click this brush and paint some grass, it creates a new stroke. So just remember that every time you do that, it creates what's called a stroke. We'll get to why that's important a little bit later. But let me show you how to paint some additional things. Now, we can certainly select brushes from this top menu here, but this is only a small fraction of what Maya has available. Now, in addition to these, if we go into our General Editor's Visor window and go over here to Paint Effects, you'll notice we have a whole list of stuff. Now, all of this you can use as brushes. So in addition to foliage, you could just use standard paint brushes. You have animal fur and skins like snake skin and that sort of stuff. Meshes for cities. So for example, if I wanted to paint Manhattan, I could certainly do that. I can also do clouds, electrical effects like lightning, feathers. We also have a whole library of flowers. So for example, if I wanted to do sunflowers, I could certainly just paint sunflowers into the scene. Or daisies, dandelions, whatever. Food, stars and galaxies, tons of different grasses, a lot of trees. Now there's two types of trees here. There's these trees here, which actually will render faster, and then you have ones called trees mesh, and some of these you notice have clocks by them. That's because some of these actually take some time to render, and that's because these actually create actual meshes in the scene. So for example, if I created one of these oaks, you can see how it creates a very realistic oak tree with leaves and everything. Very complicated object, so it takes a little time to refresh. And we also have stuff like weather and watercolors, mesh, all that sort of stuff. So as you can see, you've got a huge palette of possibilities. Now, in addition to these standard brushes, you can also make your own brushes and customize stuff to make pretty much whatever you want in Paint Effects. So if you want to, you can go ahead and practice just by populating the scene with trees and flowers, and then we're going to get into creating your own brushes in the next lesson. Now let's take a deeper look into how brushes are constructed in Maya and take a look at the underlying aspects of Paint Effects. We already know how to select a surface and paint on it. That's pretty easy. But let's go ahead and take a look at how to create and modify what we paint so that we can get a little bit more of a custom look. I'm starting off in a new Maya scene, and let's just go ahead and create a NURBS plane from the top view here. And I'm just going to go into my perspective view, shade that hardware texturing so we can see what we're working with. And then I'm going to my Paint Effects shelf. I'm going to keep that selected and just go Make Paintable. And let's go ahead and just paint some more grass. So I'm just going to select this clump grass and I'm going to paint a stroke. Now, when I paint this, what happens is it creates a stroke. So I have my plane, and then on that, I've created this grass. Now, this stroke actually has two components. There's the actual path, which is that line that I painted, and that's what's called the stroke. And then on top of that stroke is applied a brush, which determines what is actually painted. So in this case, it's grass. Now, this could just as easily be trees or buildings or whatever, but right now we're painting grass. So let's show you how this works in the attribute editor. I've got this stroke selected. Go into the attribute editor. I'm going to zoom in a little bit here. And we'll see we have a couple of different nodes. The first one is our master node, which just determines where this stroke is. In fact, I can select this stroke and just move it wherever I want. It doesn't have to be locked to that surface. That stroke, if you can see there's a line underneath there, I can actually move that wherever I want. Now, the stroke itself also has the stroke parameters. Now, these include things like pressure sensitivity. So you actually can use pressure sensitivity to, paint the grass thicker or thinner or longer or shorter, that sort of thing. But also we have a number of options here. First of all is the display quality. How much of this grass is actually going to be displayed? So we could actually turn this all the way down to 0, and with no display quality, you can see the actual stroke itself. Now, if I turn this up, you're displaying more and more of these little grass things. Now, if you get a very complex scene, you may want to turn down your display quality just so your screen updates in a more real-time manner. We can also change what's called the seed, which basically just changes a random seed that, will give you a little bit of randomness to that grass. And we also have some additional options here, such as, what direction it's going, pressure sensitivity, and so on. So as I've said before, the stroke determines where the stuff is painted, but the actual stuff is located in this next node over. In this case, it's called Grass Clump 1, and this is called a brush. In fact, you can see it here. It's called brush. And this determines what exactly is painted. Now, by changing these attributes, we can completely change around what is painted. So let's just go through some of these. Now, for example, we have a global scale, which enables us to make this bigger or smaller or whatever. We can go through here. We can say, what channels are we painting in? Brush profile. So how wide or how narrow is that stroke? How close to that line are these little grass things going to be painted? Okay, so that's your width. Basically, it's the width of our brush stroke. We also have options for twist. So, for example, if I want to twist the grass around, I can certainly do that. And all of these can be animated, so you could actually twist the grass to create some sort of animated effect. We also have stuff for the actual mesh. If you scroll in here, if you zoom in to one of these little grass blades here, you can see that we have how many sections on each one of these and how many subsegments. So basically, how fine is the mesh that we're painting? You can also create thorns on the mesh if you want to. And you can also create stuff like environment. So if you want this to reflect, you can. We can also do shading. So this is great because we can actually change the color. So for example, if I wanted to make this red, I could certainly make it red, or I can make it blue or whatever. So you can see how that first color becomes whatever I choose. So if I want to make this a really green grass, I can certainly change this. We also have a color 2. So this is color 1, which is basically our base color. Color 2 is our tip color. So for example, if we wanted to make dried out grass, we can make these brown. Or if we wanted to make it very healthy grass, we could certainly make it green. You also have such options as incandescence, transparency. You can also have a randomness to this. So not every grass is going to be exactly the same color. Now, if you want to go beyond color, you can also add texturing to it. Okay, now I'm going to do that right now. You can also do illumination and shadow effects. So if you want these to actually cast shadows, you can. Do you want it to fake a shadow? Yes or no? Or do you want it to have real shadows? Another one is glow. Do you want this to glow? Now, for example, if you wanted to do lightning, you probably would want to glow. For grass, you probably don't. Now, this is probably one of the more important ones, which is tubes. And what any brushstroke does is create what are called tubes. If you look at this little grass is just basically a little tube that's attached to that stroke. So what we can do is we can create any number of tubes per step. So for example, if we dial this down, we're going to have fewer tubes per step of this stroke. So if I dial this down to a lower number, we can kind of get a little bit in and see how this is really working under the surface so we don't have so much in the way. We can certainly create a randomness. If we don't create randomness, then it's going to space these very evenly. You can also create any number of segments on these tubes. So for example, if I dial this down to 1, it's just one straight segment. More segments gives it more flexibility. We can also change the length. How long is our grass? Or how long are our tubes? And the tubes determine that it's grass. Do we want them long, short, whatever? We can also change width, so for example, the base and the tip, and so on and so forth. Now, if you want, you can also highly control the width of this. So for example, if I wanted to, I could create a graph here that actually gives you the outline of this grass. Now, in addition to how the tube is created, we also have what are called growth options. So if we want more than just grass, we can add twigs, leaves, flowers, and buds. So I've just turned grass now into a field of flowers. Now, each one of these also has its own parameters. So for example, the flowers have their own color, so you can make blue flowers or whatever. Translucence, all of these parameters, I can't go through all of these, but you can see we have a huge wealth of parameters here for totally customizing each one of these. Now, in addition to all of this, we also have what's called behavior, which allows it to react to forces such as wind and that sort of stuff. And also you can animate it. So all of these options allow you to completely customize how the brushes work. Now, once you've customized a brush, you can actually use it again just by going into the Paint Effects menu. Now, what I've done is I've taken that grass brush and I've significantly altered it. So what I can do is I can just go Get Settings from Selected Stroke, and now what that will do is the next thing I paint will paint exactly what I have here. So for example, if I take the paintbrush and I paint it, now I'm painting those blue flowers that I created. So as you can see, you can take any basic brush and completely change it into whatever you want. We've seen how Paint Effects separates the actual stroke from the brush. This can be used for a lot of really neat things. One is you can actually repaint something after you've painted it. So you could actually change the brush on an existing stroke. So let me show you how that works. We're starting in just an empty window. I have my visor window open because we're going to be painting some hair. And I'm just going to draw a small sphere. I don't want this sphere to be too big because I need to have it in scale for the hair that I'm about to paint. So I just want to make sure I turn on shading and turn on hardware texturing here so I can see what I'm doing. So I have my visor window open. So let's go ahead and do hair wet curls. Now, first thing I need to do is go ahead and select the sphere and go make paintable. Then I go down to hair wet curls and then just stroke that. Okay, so now I've created a stroke with some curls on it. In fact, if I wanted to, I could render that. You'd see those curly hairs. Now, I can go ahead and paint another stroke if I want, but let's say I decided, you know what, I really don't like that hair. Let's go ahead and change it to something else. Well, what I can do here is I can go to any one of these presets. So if I wanted to go to hair blonde wavy, all I have to do is highlight that, and that selects that brush. And then if I go into Paint Effects, all I have to do is just go apply settings to my selected strokes. And when I do that, you'll see that that selected stroke now goes to the blonde hair. So now I have two different types of hair. In fact, if I wanted to, I could select this other hair and change it as well. Now, how this works is that Paint Effects always has a brush active, and whatever brush we have active, we can apply it to selected strokes or the last stroke. So, for example, if I selected this particular hair here, the curly hair, I could get the settings from that stroke and then select the other one and just go apply that, and then everything will turn to curly hair. Now, I could select any of these other hair strokes, and that puts it into the active slot. And when I do that, then I can just apply those as well, and it will change that hair. What this means is that if I've painted something, let's say I painted some grass or some hair on an object and I don't like it, I can change it just by selecting what I want and applying it. And you can see how simple that is. Now let's take a look at how to apply one brush to many brushes within Maya. This can be very handy when you're painting large environments. So I've got my visor window up, and let's just take a simple plane. Again, it's a NURBS plane. I'm going to go ahead and highlight this and just shade that and just go ahead and go make paintable. And then I'm just going to select some of these flower brushes. So let's go ahead and select the dandelion. I'm going to paint some dandelions on the scene there. And then select a different type of brush. How about some sunflowers? I'm going to paint some sunflowers. And then how about some violets? Okay, so now I've painted 3 types of flowers in the scene. I'm going to minimize this visor window here. And let's take a look at it from the outliner perspective here. I've got the dandelion stroke, the sunflower stroke, and the violet stroke. Let's say I was painting a large field of flowers and I wanted to change things around. I could very easily select all of these strokes and make them into one flower. And essentially what we're doing is we're going to take all of these strokes and point them to one brush. So instead of having 3 strokes and each stroke has its own brush, we're going to take those 3 strokes and point them to only one. And we can do that by doing share one brush. I select those and go share one brush. They all now share the exact same brush. And in this case, it's the brush of the last one selected, which was the violet. So now all I have to do is select any one of these, go back into visor, change the brush. So I can select Dahlia. And if I go over to the Paint Effects windows and apply it to the selected stroke, you'll see that all of the strokes change, even though I only had one selected. So for example, I could just select this one and just change it to daisies, and everything changes. What this means is that all of these strokes point to one brush. So for example, if I selected one of these strokes and went into the attribute editor, you could go into this brush and change anything you want. For example, if I change the global scale, it changes the scale of everything, even though I'm only affecting one of these. Now, this can be very handy when you're painting large groups of objects because you will want to paint multiple strokes, but you'll want all of those strokes to be affected by the same parameters. So that's why share one brush really can help. Now, if we want to, we can also remove brush sharing, and what that does is it separates out all of the options for each of those brushes. So if you select all of these and go remove brush sharing, that will make them separate. So now that if I select this and change the scale, the other ones aren't affected. So when you share one brush, it concentrates all of the brush settings into one that you can change for everything. And then when you remove them, it separates them back out again. Now that we know how to create, modify, and apply brushes, we also need to learn how to save them. There are going to be a lot of times when you're going to create a custom brush and you want to save it for later. So when you come back to the scene, you can paint with the exact same brush. Now, Paint Effects does allow you to save out brushes, and let me show you how. I'm just going to create a surface here, and we're going to go into our Paint Effects window. go make paintable, and let's just paint a simple object here. I'm actually going to choose this tree here, and I'm just going to create a row of trees. That way I can just get to a brush. So let's go ahead and shade this so we can see it. And if I select that stroke, I can go into the attribute editor, go here to tree simple, and let's go ahead and modify some parameters. One, we can change the global scale. We could change the number of brushes, that sort of thing. Let's just do something really simple. Let's go down to tubes and go down to growth and turn on flowers. Let's just go ahead and make these cherry trees. Now these flowers are a little bit big, so let's go ahead and turn that petal length down a bit so that way we can have smaller buds there. And so now we have basically what are little cherry trees. Now what we can do is we can save this out to a preset, so that way if we want to come back and paint cherry trees, we can. So let's go to the Paint Effects menu, and let's just go ahead and make sure we get the settings from the selected stroke, and that kind of puts it into our paint buffer, and that makes sure that that's what we're painting. So for example, if I wanted to paint that right now, I could, and that would go ahead and paint more cherry trees. Now that I have that selected, I can save it just by going down to the bottom here and going Save Brush Preset. Now this gives us a couple of options. It's really very simple. We can give it a name, cherry tree, give it a label, and then we can save it to one of two places, either the shelf, which is right here, or into Visor. So if we save it into Visor, we have two places where we can save it. By default, it goes into just our standard preferences. So it goes into my George Maestri, that's who I am. It goes into my Maya Preferences brushes. If I want to save it out into the main one, I have to go into a system folder here. I have to go into Program Files, Autodesk, Maya, and then into Brushes. And then here we have all of the different standard brushes. These are where all the standard brushes are. So for example, I could put it into the trees directory if I wanted to. Now I'm not going to do this because sometimes you may not have permission to save into that system directory. And for right now, let's just go ahead and save it to the shelf. So I've got my names all set, and let's just go ahead and go Save Brush Preset. When I do that, I go to my shelf, and if I scroll down here, you'll see at the very end, I've got a cherry tree. So I could, for example, select something else, paint fire or whatever, and then come here to cherry tree and then just go right back to where I was and paint those same trees. Now what we did here was we actually added a Mel script to my shelf. Now you can edit shelves, and that's something we haven't gotten into. So let me show you really quickly how to edit this and how to get rid of it if I want to. If I click on this little button right here, I can go into my shelf editor, and this allows me to add shelves and also to affect the shelf contents of this selected shelf. So if I go scroll down to the very bottom, you'll see I have my cherry tree. If I want to, I can move it up and I can rearrange it, or I can rename it, I can change the image, or I can delete it if I want. So those are the basics of how to create and save your own brushes in Paint Effects. Now let's take a look at the Paint Effects window. Up to now, we've been painting in a viewport, and that is perfectly fine. But the one thing about painting in a viewport is that it's slower. And if you get complex Paint Effects scenes, you will notice a significant dragging down of system resources as you paint in a viewport. In order to overcome that, Maya has a Paint Effects window, which gives you a much faster way to paint in Paint Effects. So let's go ahead into Window, Paint Effects. Here we have two options. One is Paint Scene, Paint Canvas. I'll get to Paint Canvas in a bit, but let's just work on Paint Scene. And what that does is it brings up kind of a viewport. And from there, I can select whatever view I want. So I can go here to Camera. I can select my front, side, or top. In this case, we're going to select Camera 1. Now, this pretty much gives us the same view as we have in our viewport. But if I want to, I can turn on Object Shading as shaded, or textured. I can also turn on default lighting or use all lights. I can also display fog if I want, and that's if I'm using fog. Then I can paint in this window. So for example, if I want to get a brush, all I have to do is go brush, get brush. It immediately brings up my visor window, and I can pick whatever I want. So for example, if I wanted to paint some flowers, I could select flowers and just go to town. And if I wanted to paint something a little bit more complex, such as a tree, I could do that as well. Now, the thing about this Paint Effects window is that it allows you to change your resolution. So, for example, here I'm at full resolution, which gives me exactly what the scene will look like. If I want to, if my scene is getting a little too complex, I can turn this down and show it at 25 or 15%, and that way it's not updating as much information and I'm painting a lot more quickly. You can also change how the strokes refresh when I paint. So if you want it to refresh in rendered view, you can. If you want to refresh in wireframe, it will go ahead and paint that way as well. Now, the other cool thing about this is that I can change some of my basic parameters here. For example, if I zoom in here, you can see that for this tree that I have selected, I can actually change the color of the leaves right here without having to dig into my menu. So for example, if I want to make my trees red, all I have to do is change that, and that will change it on my current brush. So now I'm painting red trees instead of green. So a lot of the major parameters for these brushes show up right here, and this gives me much more immediate control. Now, this is just one way of using this window. The other way is to go into the Paint Canvas mode. Now, what this does is it allows me to actually paint onto a user-defined canvas. So I can create a new texture, okay, and it gives me some defaults. Let's just go ahead and select those. And what it does now, it gives me a canvas, and this allows me to paint on that canvas. So, for example, if I have the tree brush selected, I could actually paint trees onto that canvas. What's really nice is I could actually paint something else. Let's say I wanted to paint grasses. All I have to do is go into my grass here and just start painting Bermuda grass. And once I do that, I could actually create a background texture. This can actually be saved out as a bitmap. So I can save a snapshot, and when I created my canvas, it actually gave it a file. I could actually browse through here and give it whatever file name I want. So if I don't want to save this, let's go ahead and start from scratch here, and let's go ahead and just start painting grass. Now, if I want to, I could paint all of this grass and use this as the background texture for my actual Paint Effects grass, and so the two will match. Now, one of the nice things is that we can actually do different types of things. We can actually smear, we can blur, we can also erase. We can also do what's called roll. So I can roll and wrap. So for example, if I wrap horizontally and I'm painting with this brush, let's go ahead and just do a paintbrush here. When I go over one side, notice how it comes back over on the other. This allows me to paint a completely seamless texture. So what I've got going over the left matches on the right, so now I have a tileable texture. I can also wrap vertically as well. So if I go over the top, it comes back up on the bottom. I can also roll the whole canvas 50% over, so again, this allows me to create tileable textures. It's a very, very handy tool. Now, this can also just be used as a paint tool. So let's go ahead and create a new image. And I can use a lot of my standard airbrush tools. So for example, if I wanted to, I could just use airbrushes. I can use animal fur. You can use pretty much whatever you want. So for example, if I want to do lizard fur or snakes or whatever, and I can change my brush size just by holding down the B key. And so I can paint, again, whatever I want. So as you can see, this Paint Effects window really gives you a lot of power when it comes to painting tileable textures, as well as painting within a scene. Now let's take a look at how to kind of put everything together and paint a scene within Paint Effects. So let me show you some of the workflow that I typically go through when working with Paint Effects. Now we have a scene here called road.mb, and it's the same scene we've been working with. And let's go ahead and just paint this scene out with some grass and some trees. So the first thing I'm going to do is figure out what grass I want to use. So I'm going to go into Window, General Editors, Visor, and scroll around, find grasses here. And in this case, I think I want to use this bent grass here. Now, in order to paint on this surface, I need to select the surface and go Make Paintable. Then I select my bent grass and I can start painting. Now, if I don't like that brush, I can certainly change it. So let's just paint one stroke. And I actually want this grass to be a little bit bigger, a little bit different. So it's not exactly what I want. So I'm going to select that stroke, go over here to Grass Bent, and then I can, in my brush profile, I can make it wider. I want to paint more grass with each stroke. So I'm just going to go ahead and do that. And then if I want to, I can change my global scale as well. So I just want to be able to paint a wider stroke here. And then I want to maybe increase the density or decrease the density of the grass and maybe make it a little bit longer. Just like that. And then maybe affect the color just a little bit. So go here to shading, and I'm going to make it a little bit more green, maybe even a little bit lighter, and go here to color 2. So go ahead and make that base a little bit lighter, and then make the top, it looks like it's a good green. Okay. So now I have that brush. So all I have to do is keep that stroke selected and go Get Settings from Selected Stroke. And now when I start painting, you'll see I can paint a lot of grass at once. So now I can pretty much cover this hillside with a few strokes. Now notice how this is taking a little while to update. Now if your computer is slow, you may even take longer to update. This is actually a pretty fast computer. So one of the things you can do is select the stroke and just turn down that display quality if you want. And that'll go ahead and kind of loosen things up, so it makes it a little bit easier to paint within the window. Now, as we paint strokes, we need to start getting organized. This is probably one of the most important things with Paint Effects. Let's go into the window. In the outliner, I've actually done 5 strokes here. If I paint a lot of stuff into the scene, you're going to start getting a lot of these. And it's going to start cluttering up your outliner window. So I'm going to do 2 things to keep myself organized. First is, as I paint objects, I'm going to start grouping them by type. So let's go ahead and select all of the grass strokes here, and then just go Edit, Group, or Control G, just make a group. Just call that grass. So what I can do is select that group or select everything in the group, and I have that grass selected. What else I can do is I can go over here into my layers window and create a separate layer for Paint Effects. So I've already done that, and let's just go ahead and go Add Selected Objects. So now if I want to, I can turn the grass on and off, which will really help speed interaction. So if I want to see what all my Paint Effects strokes are, I can turn them on, or I can turn them off. I can also switch on and off the background, which is already put into that layer. Now I'm going to keep this layer on, but I just wanted to show you some of the organizational stuff. Now you can certainly create more layers. You can create one for the trees, one for the grass, one for the flowers, whatever you want. Now let's go ahead and add some flowers into this existing grass. I'm just going to go ahead and select this daisy and just go ahead and paint some of those in as well. So we've got some daisies kind of coming up over the hill here. And again, just go into your outliner and select your daisies once you've got them all painted and just group them and just give it a name. And right here, I'm just going to go ahead and add those objects as well. Now let's go ahead and go into painting a tree or two on this. Let's go into General Editors, Visor. There are two main types of trees. Now this kind of gets into some of the details as to how Paint Effects actually renders things. We have trees, and then we have trees mesh. Now I pointed this out before that some of these actually have hourglasses on them, which means they take a while. And they are very heavy in terms of geometry. So you have to be careful when you're painting some of these trees. Now, the reason these take a lot of time is that it actually creates geometry for the tree. It creates a mesh. That's why it's called trees mesh. Now, that's really cool because if you want to, you could actually fly around the tree and it's an actual object in the scene. Now, this type of tree is actually more of a fake 2D tree. So it looks good from one view, but if you fly around it, you may get some strange artifacts. I'm going to actually paint some mesh trees here. Let's go ahead and create a white oak. Now, let's just go ahead and just paint it. Now, see how it takes a while. Now, that's a little bit small, but we can certainly change that by going into the attribute editor, selecting the white oak leafy medium stroke, and just giving it a higher scale. But notice how this does tend to drag down that scene. Okay, so that's about the size that I want, somewhere around there. How the tree grows depends upon how you paint the stroke. I have another one here. In fact, let's go ahead and just go get settings from selected strokes. So now I've got a tree that's going to be about the same scale. And then it just depends on how you move your brush when you create the tree as to how that tree will be drawn. So if I don't like that tree, I can just delete it and just move my brush in a different direction and I'll get a different type of tree. Now, once you have all this done, you can certainly render it. Now, this may take a while to render because it does have a lot of geometry to go through and shadow. So notice how when it actually created the render, it rendered the background first, and then it popped all the trees and stuff in. That's how Paint Effects works. It actually is a post process. It just plops the trees on over the existing rendered image. So here's a really quick Paint Effects render. You can certainly play with this and have a lot more fun with it, but those are some of the general workflow techniques that I use when creating Paint Effects. Now let's talk about animation in Maya. Maya is very much an animation program, so let's go through some of the tools and some of the basic interface for animation. Animation in Maya, let's start by setting our project. We're going to go ahead and go Project, Set, and make sure we're set to 10 Animation. And I'm opening a file here called robotwalk.mb. Now, animation has its own menu set. So let's go over here to animation. And we have a number of options here, which we'll get to later. At first, I want to go through just the basics of the time slider and how to play back and look at animation in Maya. Now, along the bottom, we have a time slider. If I left click and drag, I can drag and see that robot walk. To the right, we have our playback controls here. So if I hit this, I can certainly play back or play in reverse. Or if I want, I can step forward a keyframe at a time, a frame at a time. I can go to the end or I can go to the beginning. Now, along the bottom here, we have two sets of numbers. The outside set of numbers from 1 to 48 is the total length of the animation. The inside numbers from 1 to 24 is a window into that animation. So, for example, if I have a very long scene, I can zoom in on the timeline and just look at a narrow range of frames. Now, I also can affect this by using this time slider here in the middle. If I grab the middle of this, you can see I can actually go left and right and create my start and stop frames here. I can also grab these boxes and expand or contract that window. So for example, if I bring it all the way out, then I'm doing all 48 frames. Now, if I want to make more frames, all I have to do is just type in a bigger number. So let's say I wanted to do 200 frames. I could do that. And now I'm looking at the first 48 out of 200. And of course, I can certainly zoom that up and view all 200 frames. Now, along the right here, we have an animation button. This turns on and off setting of keyframes, which we'll get to. But even further to the right, here, I have my animation preferences. Now, this shows how my time slider works. It gives me my start and stop frames, which I can certainly set in the interface here. But it also gives me a height. So if I'm hard of seeing, I can certainly see it bigger or smaller. You can turn on or off key ticks, which means if I, for example, go ahead and select one of the feet of the characters, you'll see that right here I've got these little red ticks. Those are essentially where I've keyframed this character. So, for example, if I make the key clicks wider or narrower, I can see them a little bit better. You also have playback options here. Do you want to update all viewports? So, for example, if I had 4 viewports active, do I want to see it animating in the top and left, or just the active viewport? Do you want to loop it, oscillate, which means go from 0 to 10 and back down to 0? Or do you want to do a continuous? And then also, do you want to play back every frame? Do you want to play it back in real time? And do you want the playback speed to be real time or not? Okay, in this case, we've got everything set to 24 frames a second. So if I save that and play it back in real time, you'll see that this kind of slows down a little bit. So this gives me a real good view of how this will actually play. So those are some of the basics of the animation interface, and let's move on to actually setting and manipulating keyframes in the next lesson. Now that we understand the basics of our time slider and some of the animation interface, let's go ahead and actually do some animation. So I'm going to keep things really simple right now, and we're just going to animate a simple ball. So let's go ahead and go and create a simple sphere and just shade that so we can see it. Now, you create animation by setting keys, and you do that in Maya by going to the animation menu and going Animate, Set Key. Now, there are some options here, and let me go through those before we actually get into animating. The options are, what are we setting a key for? Are we setting it for all manipulator handles and keyable attributes, which means everything, just the keyable attributes, and we can certainly select these, or just the manipulator handles. So if I have move open, then it will just set it for move. I usually like to keep it at the default. Now, we also have whether we want to set the keys at the current time, so wherever the time slider is located, or prompt for a specific keyframe. So if you wanted to set keys at a very specific place, you could have it prompt you for that frame number. We also have some options here for IK and FK, which is character animation based, and we won't be getting into that. Now I'm just going to go ahead and close this. Usually when I animate, I use the S key for set key, and let's just go ahead and do that. So I'm going to select the sphere, and I'm going to hit W for move, just so I have a manipulator up. And then once I have that, all I have to do is hit the S key. Now watch what happens. Over here in the channel box, all of these turn kind of a salmon color. And what that color tells you is that each one of these is keyframed, and there's animation on all of these channels. Also notice down here on the time slider, we have a tick at frame 1, which is where our time slider was set. This shows me that I have a keyframe at that frame. Now, in order to do animation, obviously you need more than one keyframe. Setting one key does nothing. We have to set more than one key. So what I'm going to do here is I'm going to go over to frame 12, and I'm going to zoom out a little bit here. And I'm just going to go ahead and move this forward. Now, if I move this with nothing on here, you notice how it snaps back because I don't have anything keyed. So let's go back to frame 12, move it forward one more time, and this time I'm going to set a key by hitting the S key. When I do that, again, the little tick comes up, and now I have animation. There is another way to animate, and that's using the auto key function. If you go over here and press this button, you'll notice how it turns red. When that's red, anytime I move the object, it will set a keyframe. So let's go over here and move to frame 20, and I'm going to zoom out here in my front window, and I'm just going to go ahead and move it again. So now my first key goes to here, and then my second key is here. And all I had to do in this case was just move it. So the rule here is that once a keyframe is set, you always have to set the first keyframe with the S key or with set key. But once that first keyframe is set, then this takes action. And once this was working, then anytime I move this object, it will keyframe. So you got to be a little careful with this because sometimes you may be inadvertently moving it and you'll be setting keyframes. Now that we have a couple of keyframes on here, let's go ahead and show you how to work with these. If I want to, I can right-click over any keyframe and I can cut, copy, and paste a key. So for example, if I wanted to move a keyframe around, I could go here to frame 12, cut that keyframe, move to frame 10, and paste it. And so now I've got it at frame 10 instead of frame 12. Now, another way to manipulate these keyframes is just to drag them. How you do that is you hold down the Shift key, left click and drag, and you can actually pull out this little window that goes around either one or multiple keyframes. This window has a series of arrows on it. If you select the middle arrow, you can just drag anything in that window, left or right. In this case, we only have one keyframe set. But we can also select the right or left arrow and scale the keys. So for example, if I move this keyframe a little bit over and I selected all of these, I could either move all of those keyframes or lengthen the animation by scaling. So another thing you can do is you can certainly select these keyframes and you can copy and paste them as well. So you can actually copy and paste multiple keyframes. So if I selected these two keyframes and I did a copy, I could go out here a little bit further in the timeline and do a paste. Now what that does is it actually pastes what's in that window at the frame. So for example, here I'm at frame 26. So actually I have my window from frame 10 to 18, I think. So it just pasted those keyframes there. So what I've got is I've got it going here, then I got going back and forth because this keyframe was copied here. And so basically it goes forward and then it goes back to that one and over. And again, I can select these and rearrange them however I want. In fact, I can just drag one in, or I can drag frames over, I can stretch. So there's a lot of ways to actually manipulate keyframes in the timeline. So that's the first way to set and manipulate keys. Now, manipulating keys on the time slider is certainly one way to affect animation. But if we want finer control, we have to go to the curves themselves. And we can do that using the graph editor. So let me show you how that works. We're in a file called car.mb, and it's just this basic car in a blank scene. And let's just go ahead and do some animation. So I'm going to go ahead and select the body of the car, and I'm going to highlight my side view. And we're just going to make this car start and stop. So I'm just going to zoom out a little bit, go to frame 1, hit S to set my key. Now I have auto key turned on here on the bottom right. And let's just go over to frame 16. And I'm going to move that car forward a little bit. So it starts to there. And then let's move to frame 24. And then I'm just going to set a keyframe. So basically the car comes forward, stops, And then let's go to 40 and move the car forward again. So it goes forward, stop, and then starts up again. So I have a couple of keyframes here. So let's see how those look in the graph editor. We can get into the graph editor by going Window, Animation Editors, Graph Editor. You can also turn the graph editor on as a panel in the window. In fact, there's a layout that has the graph editor along the bottom in a window if you want to use that. I like floating the graph editor, so that's what I'm going to do. So now when I select my car body, you can see I've got all of the curves for the body. And the only one that's actually moving is this Z curve. In fact, you can see how my translation in Z is moving. So it goes to a stop, stops, and then goes forward. And you can actually see this motion right here on this graph. The graph editor is great because what it does is it allows you to actually affect how Maya in betweens these scenes. In fact, if I look here, I can actually go into here, I can select my body of my car, and I can go through each individual curve. So example, translation in X, Y, Z, rotation, scale, really any number of operations. But the one I'm really interested in is translation in Z. So I'm going to select that. And now let's go through some of these options. Now the first thing you'll notice is that each keyframe has a dot. I can actually go through this window and zoom in, zoom out. I can left click and drag to select keys. If I want to, I can also select individual keys as well, just by drawing a box around them or clicking on them. Now you notice each key has a tangent, a Bezier handle associated with it. If I want, I can actually left click and drag the actual tangent here. So if I, for example, want to move a keyframe around, I can just middle click and drag, and I can move that key wherever I want. So if I didn't want this to happen at a specific frame, if I wanted to start it in a different place, I can move that keyframe around wherever I want. I can also affect the shape of the curve. So for example, if I drag and just select that handle and middle click, I can make it accelerate or decelerate. So for example, if I do it like this, that means the car will slow to a stop, but also accelerate. And I can do that at the end here. So if we look at the end here where it comes into frame 40, notice how it just stops dead, almost like it hits a wall. Well, most cars take a little time to stop, so I can just grab that handle, middle click, and if I flatten it out, then it will slow to a stop. So essentially what I'm doing here is I'm slowing in and slowing out. Now there are a bunch of options here that allow me to affect how these curves look. Along the top here, I have a number of preset tangent types. So for example, let's just go ahead and click all of these tangents, and I can make it go smooth, make it go flat tangents. Now what a flat tangent is if they're the same value, it draws a straight line between them. This is great for things like, if you don't want your foot going below the ground when you're taking a footstep or something like that. You can also do linear tangents, which actually has no curve. So it's basically just, a dead stop and dead start. You can also do just regular tangents here. We can also do step tangents, which enables it to jump between values. And we can also do this type of tangent as well. You can also break your tangents here, and what that does is allow you to get corners and that sort of stuff as well. Now there are some additional options here, and we'll go through some of these as well, but let's just go through a few of these. Now you can certainly add tangents in or add keyframes in using this button. You can also manipulate keyframes as a group by stretching or squashing them with the lattice. So for example, if I selected all of these keys, I could hit this lattice and I could actually stretch and squash my keyframes and change the character of my animation. If I want to, I can also select multiple keys and I can move them. I can also scale them. So I can use my move, rotate, and scale keys here. For example, if I wanted to scale keys, all I have to do is hit the R key and I can actually scale my values or my time. which is kind of nice. Then we have some additional menu options here. These here, pre-infinity and post-infinity, are for looping. There's some additional ones here to simplify your curves. Different types of keys if you want to convert, add, or mute a key, for example. Some of these are also duplicated. These are tangents that we have here. We can show different types of objects and attributes, so we can determine what sort of stuff is shown in this window, for example. So as you can see, there's a lot of different options for the graph editor, and it's a great way to really fine-tune and tweak your animation. Another way to edit your animation is by using the dope sheet. So let's go ahead and take a look how that works. Let's just do a real simple animation. I'm just going to create a polygonal cylinder here. And let's just go into my perspective view. And I'm just going to set a key here at 1. Turn on auto key. And then I'm just going to move it. And I'm also going to rotate it. And then maybe just move it and rotate it again. So now I've got a very simple animation. So if I wanted to, I could certainly look at this in the graph editor, and I could certainly see all of my keyframes here. But another way to look at it is in a more global way, and that's using what's called the dope sheet. Now this is great for if you're working with a lot of different things that are animated in hierarchies. But I'm just going to show it to you very simply here in the dope sheet. So what you have here is you have a little bit of an outliner here, and each object in the scene has its own individual keyframes for each curve. So notice how instead of looking like curves, they look like dots. So it's a much easier way to select and edit animation. So it's kind of halfway between working on the timeline here and working in the graph editor, because on the timeline you have just one key that you can move. In the dope sheet, you can actually go down to a specific key. So for example, if I wanted to move the rotation keys, I could just select them and then middle click and drag and move those rotation keys. And notice how I have additional keys showing up here on the timeline. So now it's actually rotating later than it did before. Now if I want, I could again select those keys and just move them back. Notice how we also have a summary here. The summary is for every key in the scene. So if I wanted to totally retime everything in the scene, you know, a dozen objects and they're all animating, and I wanted to retime everything, I could do that in this dope sheet summary. I can also do it on a per object basis. So I can just, for example, retime only those things I have selected, or I can retime everything. So I can retime, for example, everything for this object or everything in the scene, or just all the rotation keys or all the move keys. By selecting here on this line, that selects all the translation keys. But if I select down here, I can select individual X, Y, and Z. So you can see this is a lot easier way to just move keys around. But again, you don't have effect on the curves themselves. So I kind of like this. It's more of the intermediate window between the timeline and a full-on graph editor. So now let me show you how to do what are called breakdown keys. Breakdown keys are a special type of key in that they always stay in between two master keys. It's great for things like character animations, particularly like walk cycles, where you may need to stretch a step or something like that. And breakdown keys can really help facilitate that. I have a scene here called robot.mb, and it's basically our little robot. We're going to start by making him do a few steps. We can do that by going into the side view and setting a couple of keys. So let's select the left foot and just do a set key. Now I'm going to move forward to say frame 11. So we're going from 1 to 11. That's 10 frames. And I'm going to move it forward. Let's just move it forward 2 units and set that key. So now I've got his foot moving forward like this. Now, typically when a foot moves forward, it lifts off the ground. So we're going to go to the middle of the two. We're going to go to frame 6, which is in between 1 and 11. And we're going to set another key. Now, we could just set a regular key, but in this case, we're going to do what's called set breakdown. But first of all, of course, we need to move this into a certain place. So let's go ahead and move it up and then do a set breakdown. Now, what this does is it creates a middle key. Now, notice how this middle key is green rather than red. Now, watch what happens when I select one of these keys and move it. Let's select the key at 11 and move it. When I do, notice how the breakdown key follows along. So now I've stretched the animation. The key automatically moves with the two master keys. Now I can certainly move them both around. I can move one or the other, and this will always stay centered between these two. Pretty simple. That's the way breakdown keys work. Now let's talk about animating on a path. There are often times when you will want to draw a path and have an object move along it. A good example would be this scene here. I have a scene called carpath.mb. And in it, I have a car and I have a terrain with some foliage on it. Now I'm going to go ahead and hide the foliage. I'm going to hide this paint effects layer so we can see it a little bit better. And in this scene, I want to be able to move this car along this road. I could animate it manually along the road. It's kind of hard for me to actually get it to move along that path without a lot of little trickery. It's probably easier for me to create something that I can move the car along, and I can do that using a motion path. So the first thing I have to do is draw a path. So I'm actually going to draw this as a curve on surface. So I'm going to go ahead and select my plane, and then I'm going to make that plane live by hitting this little magnet button right here. Now notice how it changes color. Then I'm going to create a CV curve. And I'm just going to go ahead and draw that curve to match the path of that road. So that's pretty good. And because I drew it as a curve on surface, you'll notice that it's stuck to the road. So any changes in terrain are reflected in that curve. Now I can use this curve to animate to a path. Now I don't have to do this with a curve on surface. I can do it with just about any curve I want. All you need is a curve. I can animate the car directly on the path if I want to. Let me just do that very quickly. I can select the car, select the path, and this under animate, go motion paths, attach to motion path. And let's see how this works. When I do that, the car certainly does move along the path, but it's moving in the wrong direction. It's kind of twisted around. Now, what I can do is I can change that by going into the attribute editor and changing the motion path. So I can, for example, give it a new front axis, and I can turn it around. It's still on the path itself. Now, I can change that by hitting the insert key and moving the pivot. Now you can see it's the pivot of the object is actually what's attached to that path. So for example, if I hit the insert or home key on the Mac and move it, you can see how it's actually on that path. So I can just move this car down so that its bottom is on the ground. Now another way to do this, and this is probably the way that I like to do it a little bit better, is to create what's called a locator. So I'm going to actually go ahead and reload this file, and we're going to do it a second way. So I'm just going to go here to Recent Files and load car path and not save. So let's do this one more time. Again, I'm going to turn off my Paint Effects window here, and let's go ahead. I'm going to have to redraw the path here. So I'm just going to go ahead and make this live, create CV curve, and draw a path. Now I select this path, but instead of actually attaching the car directly to the path, I'm going to create an intermediary, and I'm going to use a locator. So I'm just going to go create locator. And what happens is it creates this little tiny object here called a locator, and it's just a null object. So I can select that. In fact, let's go into my outliner window here. I can select my curve, select my locator, and then I can go motion paths, attach to motion path. Let's go ahead and look at some of the options here for attach motion path. If you want, we can give it a certain time range. How long do you want the car to take to go down this path? Do you want the time range to be the time slider, in this case from 1 to 120? Do we want to give it a new start or a new start and end time? So, for example, if I wanted it to go from 1 to 90, I could certainly do that. And then we can also give it stuff like the length and as well as how it's oriented to the path. So I'm just going to go ahead and go attach. Just make sure I have this all selected, and let's go attach. When I do that, you can see how this locator now is moving along the path. And what I can do is I can take the body of the car and in the outliner, middle click and drag it over the locator. And when I do that, the locator is now parented to the car. So the car is a child of the locator. And now the car moves with the locator. So I've kind of got this intermediary. And now I can actually move the car and adjust it however I want. In fact, I could actually animate the car to bump around the path or whatever. Another thing you can do is you can actually affect how the object moves along the motion path. So if I select my locator, which is attached to that motion path, I can go to the motion path and I can actually do some stuff like, for example, I can change the axis. I can also turn on what's called bank. And what that does is it makes the car kind of lean into the curve. Another thing you can do is you can actually go into the graph editor. So I go Animation Editors, Graph Editor, and if I have my locator selected, you'll notice that it actually has a keyframe that puts it along the motion path. And if we look here, we have motion path attributes, U value. As this car moves along the path, it goes from 0 to 1. So when it's at frame 90, it's at exactly 1 on the path. In fact, if I zoomed in here, you would see that this value would be at 1. In fact, if I framed all here, you can see it goes from 0 to 90, and the distance along the path, it goes from 0 to 1. So I could, for example, make this slow out at the end, and I could also make it slow in by grabbing that handle, middle clicking, and dragging. I can slow out and slow in, so I can make the car start up slowly and slow down to a stop. If I go back into my graph editor, I can also change the start and end frame just by middle clicking and dragging that key. So for example, if I wanted to, you can see the number changes here. I could lengthen this. So I can make it go from 1 to, say, 120 rather than 1 to 90. So as you can see, there's a lot of options here with motion paths, and you can use it for all sorts of things. I like to use it on cameras to make sure that the camera is moving very smoothly through an animated scene. Another way to visualize your animation is to use motion trails and ghosting in a scene. So let me show you how this works. We've got a scene called robotwalk.mb. Now, if we want, I can just scroll through this. And you can see that I have the robot is walking through the scene. In fact, I'm going to zoom out here so I have 48 frames, so I have a little more to work with. Now, ghosting is probably familiar most to people who have done traditional animation, and they've done onion skinning. And that's where you lay one drawing over the other to see how things move through a scene. Well, you can do the same thing in Maya. All you have to do is select an object. In this case, I'm going to select his left lower arm. And then from the Animate menu, all you have to do is go Ghost Selected. And when you do that, what happens is it will ghost the object so you can actually see how the object moves through the scene. Now, if you want to get rid of that, you can just go Unghost. Now, if we want to, we can also take a look at some of the options for ghosting. And that is, do you want to go through global preferences, which is the standard way? We can also do custom frames, which is the number of frames to display. We can actually ghost on very specific frames. We can also do custom steps. So, for example, if I only want to do it every 10 frames or every 6 frames, I can certainly do that. You can also do steps before and after. So, for example, if I only want to really ghost after the current frame, I can turn this to 0 and turn that one to 1. And I also can create a certain number of steps, which is every 2 frames or so on. So how many ghosts do I have and how far apart are those ghosts, as well as when do they start and stop? We also have some additional ones such as custom keyframes or key steps. So I'm just going to leave it here at custom frame steps, and let's just see how that goes. You can see how now I've got this kind of working on like 2s or 3s. And again, if I don't want to see that, I can just do Unghost All. Another thing you can do is called motion trails. Now, let's see if we can do this on the body of this character. So I'm going to go ahead and select the body, go Animate Motion Trail, but I'm going to go to the options here because we need to do some stuff here. We can certainly give it a time range, whether we want to do it a start or an end, or we can go by the time slider. We can also do an increment, which is how many apart. I'm going to type in the number 10 here. And then I'm going to create the motion trail. Now, what this does, if you notice, every 10 frames, it gives me a number and a point. In fact, if I go into wireframe mode, you can see this a little bit better. And what it does is it gives me a point for every frame in that scene. So when he's at frame 1, this is where the center of the body is. Frame 11, 21, and so on. It's a great way to see how an object moves through the scene. Now, the motion trail is actually a separate object, so you could actually delete that or move it or use it as a template for doing something else. So as you can see, we have a lot of different options for visualizing motion within our viewports, and these tools can really help you do that. As you start animating, you are going to want to create tests. Playing back in the viewports is usually okay for simple objects, but as your scenes get more complex, Maya is not going to be able to update those viewports in real time. So instead of rendering out your entire scene, Maya has an intermediary step called a play blast. What that does is it just renders a very quick animation test so you can see how the motion of something is going without going through all the trouble of doing a render. You can create a play blast by going into Window, Play Blast. Now I'm in robotwalk.mb, so let's just go ahead and do a play blast of this. So let's go play blast. In fact, let's look at the options here. What are we play blasting? We're play blasting the entire time slider or a start and end. So for example, I can go from 1 to 48 in this instance. The actual view, do we want to show ornaments, which means stuff like the perspective and other stuff in the window? And how do you want to view this? Do you want to view it in Image Viewer or the movie player? I'm going to leave this at default. And then what is the display size from the window we're looking at and at what scale? So let's go ahead and just do a play blast and see what happens. Now what it did was, if you could notice when I actually did that, it reduced the window to 50% of size, and then it played through the animation as quickly as possible and recorded it to a movie. And now this is just a standard QuickTime movie that I can play back. I can also save this movie because it is a QuickTime. Now, this movie is already saved out. Because it's a QuickTime, I can actually put this into a video editor or something, and I can use it to, for example, cut my tests in with my actual footage. If you want, you can also do additional options in Play Blast. The other option is to use what's called the image viewer, which is Maya's own image editing program, and we can certainly take a look at it from there. We can also change the scale of this, so if we wanted to make it bigger or smaller or so on. We could also save it to a file, a very specific file if we wanted to. Let's go ahead and do one more play blast and let's just see how this works. So now we're showing this in Maya's own movie player. This is not QuickTime, this is Maya's movie player. And you can see it also plays pretty well. Now what this does is it loads your files into memory. So this may be a little more restricted than QuickTime, but it's just another way of looking at this. This particular movie player is a great way to look at image sequences as well, because what you can do is you could actually open images or animations. You can also import sound as well. Now I want to talk a little bit about constraints. What constraints are is a way to automatically animate and position objects. Let me show you some of the basic constraints in Maya. We're actually just going to start with a blank viewport here, and let's just go ahead and create a couple of simple objects here. I'm going to create two spheres, and let's create a polygonal box here. So I've got two spheres and a box. Constraints can be used to do a number of different things. Now they're located here in the animation menu, and we have a number of constraints here. Let's go through some of them. Now what constraints do is they automatically attach one object to another without actually having them in a hierarchy. So let's go through some of these. One is called a point constraint. So what this does is it actually constrains one object to another. So for example, if I select the box and then shift select one of the spheres and do a point constraint, what happens is the sphere jumps to the box and matches its motion. So for example, wherever I move the box, the sphere will go. I'm going to undo this, and I'm going to show you another way to do this, and that is to constrain one object to two. So if I select both spheres and then select the box last, and then do a point constraint, what happens is the box is now constrained in between those two spheres. So wherever I move those spheres, the box is in the middle. So this is a great way to attach objects without putting them into a hierarchy. In fact, we have these here, and none of these are actually hierarchically linked, but their motion still is. So it's great for that sort of stuff. Now, if I select an object, you can also see that the constraint is actually a node on the object. So I could actually affect the constraint by affecting this option here. I can also go into the channel editor here, and I can actually give it an offset and so on and so forth. Now, if I want to, I can get rid of it by deleting constraints, and that gets rid of it. Another type of constraint is called the aim constraint. Now I can use this, in fact, probably the best way to use an aim constraint is with something like a camera or a light. I'm going to go to my rendering shelf here and just create a camera. Now what I can do is select a sphere and then select the camera, and then I'm going to do an aim. With constraints, the last object selected is always the one that is constrained. So I can select, for example, all of these objects and then the camera, and it'll be constrained to the average of these two. But let's just do it with the sphere. So I can aim this to the sphere, and now wherever I move the sphere, the camera moves. Although the camera's not really pointed exactly at that sphere, I can change that by going into the aim constraint and creating an offset. So for example, I can do that and create my offset. And now once I do that, it will always follow. Let's go ahead and select this and go Edit, Delete by Type, Constraints, and let's go ahead and redo this again. Another way to do this is just to constrain relatively. So for example, if I have this pointed in this direction, so I select the box, select the camera, if I go into aim here, I can do what's called maintain offset. And so this will always keep the camera pointed where it was, and now it will go ahead and still move. In that case, I have to have the camera already pointed. There's another type of constraint called an orient constraint. So let's go ahead and select the sphere and then the box and do an orient constraint. Now what this does is it just constrains rotation. So as I rotate the sphere, the box rotates as well. You can do the same for scaling. You can also do parenting to create and break hierarchies in real time. Now I'm going to go ahead and show you something that's a little bit more practical, and let's go into our robot scene. Now this is our standard robot. I want to eventually make this robot walk. So let's take a look at the hierarchy of this. I have the left foot, the right foot, and the character's body. In fact, I'm going to drag that up here so we can see them all together. And they're all separate. So if I move the feet, I can actually move them outside of the body. Now this is great for when I'm actually making him walk because I can keep the feet separate from the body. But as I move the feet, you'll notice that they're actually moving away from the body. It would be nice if I could have the actual body of the character constrained so it's always between the 2 feet. So I'm going to do this in 2 steps. First, I'm going to create a locator. And what this is just a small object here that is just kind of like a null dummy object. Right here is my locator. So I'm going to select my right and my left foot of my character and then control select the locator in the outliner window. And then I'm going to go constrain point. Now notice how that locator snaps. But what happens is now this locator is always going to be located between the 2 feet. This makes it really easy to automatically control the body of the robot. So all I have to do is select the robot's body, middle click and drag over the locator. Notice how I get the double lines there. And now once that's a child of that locator, it will always stay between the feet no matter how I move them. So there's a really good practical use for constraints. So now let's take a look at how to cycle animation. Let's go ahead and do a really simple animation again. I'm just going to take a sphere and let's just go ahead and animate it. Very simple animation. I'm going to go into my front viewport and I'm just going to set a keyframe and I'm going to move, say, to 16 and then just move it. And then go ahead and set a keyframe. So now I've got this sphere just moving to the right. If I want to, I can cycle this. Let me show you how this works. Go into Animation Editor's Graph Editor. And let's go ahead and find the translation key that we used. In fact, I've got this one here, Translate X. If I hit the F key, that'll frame all, and that'll show me exactly what the motion is over X. So if I want to, I can cycle this in a number of ways. We can cycle it by using the pre and post infinity options under curves. So pre-infinity is anything before the first keyframe. Post-infinity is anything after the last one. Let's just work with post-infinity. They're the same. It's just whether you want, before or after. So let's go ahead and just do cycle. In fact, let's go ahead and zoom out here on the timeline. When you do cycle, what happens is at the very end, when it gets to 16, it cycles back at 17 to the very first keyframe. Now, if we want, we could also do cycle with offset. What that means is that it cycles, and then at the last frame, it goes to the first, and then it just keeps going. So, for example, if I do this, it'll pick a direction, and then it'll just basically keep going. Whatever this tangent is, it'll essentially extend it out. The next one is oscillate. It just goes back and forth. as it goes, it just goes back and forth between these. In fact, if I wanted to, I could actually make this even longer. Let's make it, say, 200 frames long so we have a little bit more time. So you can see how it oscillates back and forth. The next one is linear. What happens is that once it gets to the end, it just picks whatever tangent there is and goes with that. So if I change this tangent by middle clicking and dragging, it'll change how this works. It just takes whatever velocity it has at the end and uses it. So wherever this curve is pointed, that's what it will do. So if I point it up and make it accelerated, it will accelerate. If I point it to one side or the other, it will affect it in that way. And the last one is constant. So whatever it is at the end, it just stays. That's almost like having nothing at the end there. Now let me show you how this works for something a little more practical. Let's go ahead and animate our robot. And this is our robot with that constraint that I had put on the legs. So the body is pretty much moving automatically. So all we have to do to animate him is pretty much just move the legs. So let's go into a side viewport. Now I'm going to start this animation with the robot's feet a little bit apart. I'm going to just type in a number here into Translate Z. I'm selecting the left foot, and in Translate Z, I'm going to type 1, because he's going to move forward 2 units per step. So I'm going to start with a half a step forward, which is at 1, and then I'm just going to go ahead and hit S for set keyframe. Then I'm going to select the right foot and set a keyframe for that as well. Now I'm just going to go ahead and move forward to, say, frame 9. And I'm going to move this left foot forward 2 units. And in fact, if I want to, I can turn on auto key here, or I can set my keyframe. So now you can see the robot is moving his foot forward. Now in the middle there, at, say, frame 5, I want him to lift his foot. So all I have to do is make sure this is turned on, and then just lift it up. So now he lifts his foot up, sets it down. Now I want to go forward. How long is this? This is 8 frames long, so it goes from 1 to 9. So let's go to frame 17, and I'm going to set another keyframe. So what I've done is I've set a keyframe for beginning, middle, and then keyframes for the pause of the foot as the other foot moves forward. So I'm going to go to frame 9 where that foot sets down, and select the left foot, set a keyframe, and then go forward again to 17. And this time in Translate Z, I'm just going to type the number 3 because, again, he's moving his foot forward 2 units per step. And then just make sure I've got a keyframe set there. And then in the middle, I'm going to, again, move that up. And make sure it's at 0 on frame 17. So now I've got 1 step. All I have to do is select both of these, go into my animation editor's graph editor, select both of them, right foot and left foot, and then just go post infinity cycle with offset. When I do that, he now just continues to walk throughout the scene. Now I've got a nice walk cycle just using some of my cycles. Now I can do the same for the arms, I can do the same for the head, I can do the same for just about anything. In fact, I can make him walk for as long as he wants. Because I've got that cycle with an offset and everything's all rigged, he'll walk as long as there's animation. So there's some practical uses of cycling, and let's go ahead and move on from here. Now I want to show you another way to connect the motion of objects together. We looked at constraints and how you can constrain one object to another. A more sophisticated way of doing it is by using what's called a set-driven key. Now, what this does is it links the motion of one object to another on a keyframe by keyframe basis. But let me show you how this works. I have a robot here, which I've actually created. It's in a file called setDrivenKey.mb. And I've just kind of modified our standard robot by adding two doors, an upper and a lower door, and I also put a little ray gun on the inside. Now notice how the ray gun is a little too big to fit into that hole, but we'll fix that with a set-driven key. What a set-driven key does is it uses one object to drive the motion of another. In this case, we'll use the lower door to drive the motion of the upper door as well as the ray gun. So first thing we need to do is kind of figure out what we're going to animate here, or how we're going to get these motions linked together. Well, what I want is when the lower door opens, I want the upper door to open as well, to kind of mirror the motion. So let's take a look at this lower door. When it is completely open, the rotation along the x-axis is at 90. When that rotation is at 0, the door is closed. And it's almost the same for this upper door. But in this case, it's rotating the opposite direction. So when its rotation is at negative 90, it's open. But again, when it's at 0, it's closed. So what we can do is we can match the motion from one to the other. Now I'm going to worry about these ray guns a little bit later. So what we're going to do is we're going to select this upper door. We're going to go animate, set-driven key, set. Now what this does is it brings up this set-driven key window. Now this gets a little complex, but let me go through it with you. So we've got the top door is driven. Now we need to figure out what is driving it. Well, we already pretty much decided it's going to be the lower door. All I have to do is click on that door and then click here where it says load driver. So now I have the bottom door driving the top door. But what exactly is doing the driving? Well, in this case, the rotation of X on the top door is also driving the rotation of X on the top door. So X on the bottom door drives X on the top door. So now once I have those selected, all I have to do is hit key. And what that does is it locks the bottom door to the top door. So when the bottom door is at 0, the top door is at 0. In fact, if I look here, you can see if I click on the top door, notice how I've got a little bit of animation in here. This is actually salmon color, which means that channel is animated. So now all I have to do is move both of these to the proper position. So if I move this to negative 90, I can just type that in. And I can do the same thing here, but this time I'm going to type 90. So this one snapped back, but let me just go ahead one more time and type negative 90. You have to do the bottom one first. Now, once I have them both at 90, you can just go key again. Now, what this does is it creates a second keyframe. So when this goes to 90, this one goes to negative 90. Now, when I rotate, I select my bottom door and I rotate it, you'll see that the top door moves along with it. Now, what's really interesting is that if I move beyond there, the door won't go. But between 0 and 90, I have keys. In fact, if I take a look at my top door and I look at it in my graph editor, you'll see that Rotate X actually has, in fact, if I hit frame there, it actually has a rotation key. So this is actually my set-driven key, and I could actually slow in, slow out. I can do any sort of curve function on that and actually affect the way that its motion changes in relation to the motion of the driving object. So when I put this rotation to 0, that one is at 0. So let's go ahead and open this door, and let's do another one for the ray gun. So I want this ray gun to kind of squash in as this door closes, because when I close the door, you can see how it kind of protrudes out, and that's not what I want. So again, I'm going to select just the base of this. It's called Raygun 1. And this time I can leave my set driven key window open, and I can just go load driven. And so now I've loaded a new driven item. I could certainly go through my animate, set driven key menu here, but since I had the window already open, I just loaded that second one as the driven object. Now in this case, I don't want to drive rotation. I want to drive scaling. So what I want to do is scale this along the z-axis. So when the door is closed, this kind of scales in. And when the door is open, it scales back out to its normal size, which would be at 1. All I have to do is select scale z as the driven attribute, and again, rotate x as the driver attribute, and just hit key. Then I select my lower door, close it, and then all I have to do is select my ray gun here. In fact, I probably need to go into wireframe mode to find that. There it is. Okay. And then I just scale that in. In fact, let's take a look at this. Scale it in so it's behind that door. So let's go ahead and scale it, say, to 0.3, and then just do another key. So when I select my door now and rotate it, now I'm driving two properties. I'm driving the top door's rotation and the ray gun's scaling. So now all I have to animate is the door, and everything else falls into place. So you can see how I can create some very, very sophisticated mechanical assemblages. This is used a lot in character animation to move things automatically. It's a really great tool, so I hope you find some great places to use it. The last thing I want to show you is how to do sound. Now, I've got a file here called Robot Final, and I took our little robot and I put him on that shelf from the rendering chapter, and I actually just cycled some of that animation that we've done. In fact, let's go ahead and show you how that animates. I'm going to do this in wireframe here, so you can see how he's animating. In fact, let's go ahead and show that to you in shaded mode. So you can see how he animates, he walks forward, and then his little door opens up and he moves around. So let's go ahead and put some sound to this. Now, typically when we animate, a lot of times what we're doing is we're actually animating to an existing soundtrack. In this case, we're putting the soundtrack after the animation, but the process is still the same. So in order to bring sound into Maya, it's actually kind of a different process. You have to import the sound and then turn it on in the timeline. So if I go File, Import, I can find my sound. Now it's in my project, in my 10 animation project, and I have a directory called Magically Enough Sound. And there's one file in there. It's called robotservo.wave. And I can import that. Now once that's imported, you really still can't hear it. You have to turn it on in the timeline. So you do that by right-clicking over the timeline, and you scroll down here to Sound, and then you can turn on Robot Servo. When you do that, you see the sound here. And if you want, you can scrub. Okay, so that's kind of a servo sound. The best way to take a look at it is to probably do a play blast. So let's go ahead and just do a standard play blast, and let's play it in Movie Player. And let's make the end time, let's just do it to the time slider, which goes from 1 to 96. And let's just go ahead and do that play blast. And there it is. So that's the basic sounds. Now, as you can see the waveform in the timeline. This may be a place where you want to expand your timeline so you can see the waveform a little bit more strongly. Now, the other thing is how do you get rid of a sound? Well, one thing you can do is you can just turn sounds off by here. Or if you want to, you can actually delete sounds by going into what's called the tracks window. It's an animation window called the tracks editor, and you can see the soundtrack there. And if you want, you can actually just hit the delete key and completely get rid of that sound. So those are the basics of how to animate against sound in Maya.